everyone, welcome to Intellipaat. In today's live session, we will be learning about R programming from basics to advanced level along with hands-on demo and interview preparation. But before we begin the session, make sure to subscribe to our channel and also hit on the bell icon so that you will never miss an update from us. Now let's see the agenda of the day. Firstly, we will begin with Introduction to R programming. Post that, we will tell you how to implement variables in RStudio. After that, we will be learning few basic concepts of R programming like data types in R, operators, objects, loop statement, and lot more. After that, we will be moving on to what is data mining and also tell you what are the methods of data mining. Post that, we will introduce you to statistics. After that, we will be seeing a case study on book recommendation engine. Then later on, we will be doing a project in R programming, followed by the comparison of R programming and Python. Then finally, we have covered R programming interview questions and answers. So guys, this is the agenda. Now let's begin the session.
So what is R? So R is a language developed by statisticians for statisticians. So if you want to perform any sort of statistical analysis, R should be a go-to language. Now R is also a great visualization tool. So R provides packages such as ggplot2 and plotly so that you can create stunning visualizations. Now R is an open source, cross-platform compatible software. So it's just plug and play. All you have to do is install R once and then you can start having fun with it. And since R is an open source software, you can actually modify the code and add your own innovations to it. And being cross-platform compatible, you can actually run the same R code on different operating systems. And the best thing about R is it is a Turing complete language. That is, it can perform any task which a Turing machine can. Now that's amazing, isn't it? And this is what makes R such a powerful tool. So you can do various operations such as statistical analysis, implement machine learning algorithms, and also create stunning visualizations, all with the help of this super language called as R. So now that we know what exactly is R, let's go ahead and install R and RStudio in our systems. So we can install R from the site over here. So we can go to cran.rproject.org. Right, so we have different versions of R. So if you are using a Linux system, then you can download R for Linux. If you're using a Mac system, then you can download R for Mac. Similarly, if you're using a Windows system, you can download R for Windows. And since I'm using a Windows system, I'll click on this link. Right, so you see this link over here, install R for the first time, click over here. Now this is the latest version of R 3.5.1. So you have to click on it and then the download would start. Now since I've already downloaded R in my system, I'll go ahead and cancel this. Right, now after you install R, you would also require an IDE so that you can perform your tasks quite easily. So one such IDE is RStudio. So RStudio is a free open source software which provides a smooth interface so that you can perform all of your operations quite easily. And you can download RStudio from this site over here, rstudio.com. So let's go to rstudio.com and download RStudio. Right, so we have entered the site. I'll click over here, download RStudio. And we see the free version over here, RStudio Desktop Open Source License. Again, I'll click on download and you see different versions of R. So again, if you're using a Windows system, this is the right link for you. If you're using a Mac system, you can download RStudio for Mac. Similarly, if you're using a Ubuntu or a Fedora system, you can download these versions. And again, since I'm using a Windows system, I'll click on this link. Right, the download has again started. And since again, I already have RStudio installed on my system, I will cancel this. Right. So we have successfully installed R and RStudio in our systems. Now let's go ahead and understand what exactly is a variable. So simply put, a variable is a temporary storage space. So let's understand the concept of variable with this example over here. So let's say we have this cart and this cart would be a temporary storage space. Now I also have an apple with me and I decide to store this apple inside this cart on a temporary basis. Now, after some time, I decide to remove that apple and replace it with a banana. Now again, after some time, I decide to replace that banana with a mango. So this is the basic premise behind a variable. It provides a temporary storage space where we can keep on changing the values. Right, so now that we've understood what exactly is a variable, let's head on to RStudio and implement some variables. Right guys, so this is how RStudio looks like. So we have 4 panes in total. This is the script window, this is the console window, this is the environment pane, and this is the tab where we can install new packages and also build some plots. Right. So what I'll do is I will create a new variable and name that variable to be fruit, and I will assign it a value of mango. Now I will select this and paste it inside the console window. Now let me print fruit. So I get the result mango over here. And since fruit is actually a variable, I can change the value which is present inside it. So again, I will type in fruit, and this time I will assign a value of apple. So I will paste it in the console window. Now let me print fruit. So see that the initial value of mango has been replaced with apple. Similarly, I'll create the same variable and I'll change the value. So this time the value which I'm assigning this would be a banana. Let me paste it over here. Now let me type in fruit, let me print it. So we get a banana. So this is how a variable works, guys. So this is a temporary storage space where the values can be kept changing again and again. So what I've basically done over here is I have taken a variable fruit. Initially I had assigned a value mango, after which I had replaced that value with an apple, and again I had replaced the same value in the same object with banana. Right. So now that we've understood what exactly is a variable, so each variable is basically associated with a data type. So let's start off with the first data type, numeric. So a variable can store numeric values such as 5, 1000 and -33. So after numeric data types, we have the character data types. So a variable can also have character values such as these. So a character value could be either a single character Z, or it could be the word Sparta, or it could be 2 words such as hello world. Right. Now after the character data type, we also have the logical data types. So a variable can store logical values such as true or false. Now you guys need to keep in mind that in R, by convention, this needs to be in capital, right? So this keyword true is capital and this keyword false is also capital. And then we have the final data type, which is complex. So a complex data type basically comprises of 2 parts. First is the real part, and then we have the imaginary part over here. So 2 plus 5i, 30 minus 30i and minus 100.47i, all of these are complex data types. So similarly, a variable can also have complex data types. All right. So now that we've understood what exactly are data types, let's go to RStudio and implement some variables with different data types. So I'll start off by creating a variable which would have a numeric value. So I will name this as my obj, and first I will assign it a numeric value which is 123. Now I can use the class function to have a look at the class of the object. So let me type in class, and inside this class function I will pass in the object which I've just created, which would be my obj. Right. So the class of this object is numeric. Now what I'll do is, to the same object I will pass in a character value. So let's say I will pass in the word Sparta to this. Let me hit enter. Now let me have a glance at the class of this object. Class of my obj. So now we see that the class of this object is character, right? So initially the class of this variable was numeric, but then when I had assigned a character value to the same variable, the class changed to character. Now I'll go ahead and assign a logical value to this. So let's say I assign a true value to this. Now again, let me have a glance at the class. So class of my obj. So this time this is of logical type, right? Now finally, let me assign a complex type to this. So my obj, and using this assignment operator, let's say I would give this a value of 30 plus 100i. right? Now let me use the class function and have a look at the class of this object. So that would be my obj. Right, so the class of this object is complex. So what we basically understand from this is, as we change the type of the value given to the object, the class of the object also changed. So we started off by assigning a numeric value to the object. Then when we saw the class of that object was numeric, then we had changed the value and we had assigned the same object a character type, and that's class changed to character. Right? So this basically means that if we change the value given to the variable, the class of that variable would also change. Right, so these were data types in R. Now let's have a look at the different operators which are available in R. So these operators basically help us to perform some sort of mathematical or logical operations on top of our variables. So basically we have these 4 operators in general. So we can have assignment operators, arithmetic operators, relational operators, and logical operators. So let's start off with the assignment operators. So as you can see what is stated over here, assignment operators are basically used to assign a value to an object. And these are the 3 different assignment operators available in R. So we can just use the equal to operator to assign a value, or we have this another symbol over here. So here we have a less than operator, after which we give a hyphen. So this is another type of assignment operator. Here again we have the hyphen followed by a greater than symbol. This is another type of assignment operator. And if you have a look at this, we have some examples over here. So what we are doing is, we are assigning the value of 10 to this variable x using this assignment operator. Similarly here, we are assigning this value 20 to this variable y using this assignment operator. And similarly, we are assigning this value of 30 to this variable z using this assignment operator. So again, let's head to our studio and we will be implementing some assignment operators and assigning some values to some objects. So let's say I create the same variable x. So I will put in the variable name which is x, after which I will give in the assignment operator which is equal to, and I will give in the value now. So let's say the value which I want to give this is 10. Right. Now similarly, I will assign a value to the variable y. So I will give in the name of the variable which is y. And then I will use another variation of the assignment operator. So first I will give in the less than operator, and then I will give in a hyphen, and the value which I give is, let's say 20. So I'm basically assigning the value 20 to this variable y. And then I will give the value 30, and I am assigning this value 30 to the variable z. So this is basically inverse assignment. So first I give in the value, and after giving in the value, I would assign it to the variable. Right. Now let me print x, y, and z values. So x, y, and z. So we have successfully assigned the value of 10 to variable x. We have assigned 20 to variable y, and we have also assigned 30 to variable z. Right. So that is how we could work with assignment operators in R. Now let's head on to arithmetic operators. So these arithmetic operators are used to perform basic mathematical operations. And these are the different arithmetic operators which we have in R. So this plus symbol over here helps us to add 2 variables. Then we have this minus symbol which helps us to subtract 2 variables. Then we have this asterisk symbol which helps us to multiply 2 variables. And finally we have this / which stands for division. So with the help of this, we can divide 2 variables or 2 operands. Right, now we are back to our studio and let's perform all of these arithmetic operations. So I'll start with addition first. So we had just seen that we had created 3 new variables x, y, and z. So we will be performing all of those arithmetic operations on these 3 variables x, y, and z. So I'll start off by adding these 2 variables. So x, which is the first operand, then I will give in the operator which is plus. After which I will give in the second operand which is y. And we get the result which is 30. So the initial value of x was 10 and the initial value of y was 20. And when we add 10 plus 20, we get the value to be 30. Right. Now similarly, let me perform another addition operation. So this time let me add y plus z. So the initial value of y was 20 and the initial value of z was 30. And when I add these two, I get a value of 50. So these were some addition operations. Now let me perform some subtraction operations. So I want to subtract y from z. So I will give in the first operand, which is z, and I will give in the operator, which is minus, and then I will give in the second operand, which is y. So I am subtracting y from z, and this is what we get. So z is 30 and y is 20, and when I subtract 20 from 30, I get 10. Now let me subtract x from z, and let's see what do we get. So this time what I'm doing is, so the z value is 30 and x value is 10, and 30 minus 10 gives us a value of 20, right? So these were some subtraction operations, after which we'll start with the multiplication operations. So let me multiply x with y, and let me see what do we get. So x value is 20, so x value is 10 and y value is 20, and when we multiply 10 with 20, we got a value of 200, right? Now similarly, let me multiply y with z, so y asterisk z, let me hit enter, so we get a value of 600, because y's value is 20 and z's value is 30, and 20 cross 30 gives us a value of 600. So these were some multiplication operations. Now let's head on to division operations, right? So let me divide z with y, and let's see what do we get. So z's value is 30, y's value is 20, and 30 by 20 gives us 1.5. Now let me do y with respect to x. So this would be 20 divided by 10, and this would give me a value of 2. Right, so these were some arithmetic operators. Now let's look at relational operators. So these relational operators are used to compare two operands. So these are all of the different relational operators which we have. So this is the less than operator, and this helps us to find out if the first variable is less than the second variable. Then we have the less than equal to operator. So this helps us to find out if the first operand's value is less than the second operand's value. Then we have the greater than operator, and this helps us to find out if the first operand's value is greater than the second operand's value. And then we have the greater than or equal to operator, and this helps us to find out if the first operand's value is greater than or equal to the second operand's value. And then we have the is equal to operator. So here we just given two equal to's, and this helps us to find out if the values of both the operands are equal. And thus finally we have the not equal to operator. So first we give in the exclamation mark, and then we give in the equal to symbol. So this helps us to find out if the first variable is not equal to the second variable. Again, let's head back to our studio, and let's implement some relational operations. So let me check if the value of x is less than the value of y. So I get a true value because 10 is less than 20. Now let me check if x is less than or equal to y. Now this again is true because 10 is less than or equal to y. Now I will go ahead and check if x is greater than y. So this time I actually get a false. So this is because 10 is not greater than 20. Right. Now similarly, let me check if x is greater than or equal to y. This again is false because 10 is neither equal to nor greater than y. Now let me go ahead and check if the value of x is actually equal to the value of y. So this time again I get a false value because 10 is obviously not equal to 20. Now let me check if x is not equal to y. So this would obviously be true because 10 is obviously not equal to 20. So these were some of the relational operators. And then we have the logical operators. So the logical operators are basically used to make a decision on the basis of a condition. And the two most majorly used logical operators are the AND operator and the OR operator. So this is the AND operator. So let's have a look at this table to understand how does the AND operator work. So we have two conditions over here, and if both of those conditions are evaluated to true, only then the AND operator would give a true result. So let's take this case over here. So here the first condition is evaluated to false, and the second condition is also evaluated to false, and that is why the result which we get is false. Let's take the second case. So over here the first condition is evaluated to false, the second condition is evaluated to true. But since both of the conditions are not evaluated to true, the final result is false. Again, let's have a look at this third case. here the first condition is evaluated to true, but the second condition is false. And that is why the final result is false. So let's take this final case. So over here, this is the only case where both of the conditions have been evaluated to true. That is, the first condition is also true and the second condition is also true. And that is why the final result which we get is true. Then we have the OR operator. So the OR operator gives us a true result when either of the conditions is true. So let's take the first case here. The first condition is evaluated to false. The second condition is also evaluated to false. And since both of the conditions are evaluated to false, the final result is false. Then we have the second case over here. Here, the first condition is false and the second condition is evaluated to true. And since the second condition is evaluated to true, the final result is true. Then we have this third case. Here, the first condition is evaluated to true, but the second condition is evaluated to false. But since at least one of the conditions is true, the final result is true. And thus obviously we get a true result because both of the conditions are resulting true. Now let's go to RStudio and implement these logical operators. Right. So let me give the first condition. So the first condition would be x is less than y. Then I will give in the AND operator and I will put in the second condition. So the second condition would be x is less than or equal to y. Now let's examine this command properly. So x is less than y. This means that 10 is less than 20, which is true. Now let's examine the second condition. So over here, 10 is less than or equal to 20. This again is true. So true and true would give us a true result, right? Now let me change the conditions. So let me give the first condition to be x is greater than y. I will give in the AND operator. Now let me put in the second condition. So the second condition would be, let's say x is not equal to y. So here x is greater than y would be yielded to false because 20 is not greater, because 10 is not greater than 20. Then let's examine the second condition. This would be evaluated to true. So 10 is obviously not equal to 20, but the final result is false because one of the conditions is evaluating to false. So this was the AND operator. Now let's work with the OR operator. So again, let me give in the first condition. So the first condition would be x is not equal to y. Now let me use the OR operator and let me give in the second condition. So the second condition is, let's say x is greater than y. So guys, what do you think would be the result over here? So we get a true value. This is because the first condition yields a true value. So 10 is obviously not equal to 20. But even though the second condition is yielding false, since we have at least one condition which is yielding true, the final result is also true. Now let me do a variation over here. Now let me give in two false conditions and let me see what will happen. So the first condition would be x is greater than y. Then I'll give in the OR operator and then I'll give in the second condition. So let's say the second condition is x is equal to y. So this time we get a false value. This is because first condition is false. The second condition is also false. And when we use OR operator with two false conditions, the final result is obviously false. Right, so these were some of the operators in R. Now let's go ahead and understand objects. So basically every data element in R is an object. As simple as that, guys. I'm reiterating it. Every single data element is basically an object in R. And these are the 6 most basic used objects in R. So we have a vector, matrix, factor, list, array, and a data frame. So let's start off with the most basic object, which is a vector. So a vector is actually a linear object which contains elements of same type. So elements of same type, or in other words, elements which are homogeneous. And this is the syntax to implement a vector in R. So you will be using the C function or the combine function and you will be passing in all of the elements. Right? So over here, I am using the C function to pass in 3 elements, which are the numbers 1, 2, and 3. And similarly over here, I am creating another vector where I'm passing in 2 elements, which are true and false. So let's go to RStudio and create some vectors. Right. So I will create a vector and I'll name that vector to be my vector. Now using the assignment operator, let me assign some values to this. So I'll be giving only the elements of same type. So let's say I will give in elements of only numeric type this time. 1, 2, and 3. So this vector comprises of 3 elements, and all of those 3 elements are of numeric type. So let me have a glance at the class of this. So class of my vector. So we see that this is of numeric. Now what I'll do is, to the same my vector object, I will assign elements of different type. So this time I will be passing in elements of character type. So let's say the first element is character A, the second element is character B, and the third element is character C. Let me hit enter. Now let me have a look at the class of this. So class of my vector. So see that this time it is a character. Now again, to the same object, which is my vector, let me assign logical values. So the logical values would be true, false, and true. Now let me check the class. So that would be class of my vector, and this is logical. So you see that the class of the vector is basically determined by the elements which are passed to it, and all of the elements are basically homogeneous. Now what I'll do is, I'll actually pass in elements of 2 different types to the same vector, and let's see what would be the result. So the name of the vector is my vector. I will use in the C function or the combine function, and this time what I'll do is, I will pass in 2 numeric elements first, and after passing in 2 numeric elements, I will pass in 2 logical elements, true, false. So this is a vector which comprises elements of different types. So the first type is numeric and the second type is logical. So guys, what do you think would be the result? So do you think there would be an error, or we would be getting some other result? So let's see what we'll actually get. So let me print in my vector over here. So this is quite a strange result, isn't it? So we had actually passed in 1, 2, true, and false, but the result which we are getting is 1, 2, 1, and 0. This is because the logical values have been coerced to numerical values. So this means that a vector can have only homogeneous values. So the value of 1 and 2 are the same. So 1 is a numeric value, it remains as 1. 2 is a numeric value, it remains as 2. But this true logical value over here, this has been coerced to a numeric value of 1. Similarly, we have this false logical value over here, and this has been coerced to a numeric value of 0. Right. So this time I will pass in character values and logical values to the same vector. Let me name that vector to be my vector, and let me use the C function to assign some values. Right. So let's say the first 2 elements are characters. So the first element is the character A, and the next element is the character B. After this, I will give in 2 logical values. Again, there would be true and false. Now guys, what do you think would be the result for this? So let me just check. So that would be my vector. Right. So this time the logical values have been coerced to character values. So A and B were initially character and they remain as character. But these 2 values which were actually logical, their values have been coerced to character. So just to verify it, let me show you the class of this character. So class of my vector, this is a character. So even though I had passed in 2 character elements and 2 logical elements, the class of both of the logical elements has been changed to character, and the class of the entire vector is also character. Right. Now finally I will pass in all of the elements of the 3 different types. So I will pass in 2 numeric values, 2 character values, and 2 logical values. So I will pass in 2 numeric values which are 1 and 2. After this I will pass in 2 character values which are A and B. And then I will finally pass in 2 logical values which are true and false. Now let me hit enter my vector. So this time all of the values have been coerced to character. So this means that character data type has the highest precedence, the numeric values has the next highest precedence, and the Boolean values or the logical values would have the lowest precedence. Right? So again, just to verify, let me show you the class. So that would be class of my vector. So this is a character. So even though we had passed in elements of 3 different types, the class has been changed to character. So let me print in my vector again over here. So these are the 6 different elements which are present in this vector. So now I'll go ahead and show you guys how to extract individual elements from this character. So let's say I'd want to extract this 4th element from this vector. So let's go ahead and do that. So for that, I would have to give in the name of the vector first, which would be my vector. After that, I will give in 2 square braces. And inside that square braces, I will give in the index number. So the index number is 4 over here. So the numbering starts from 1, guys, right? So this is index number 1, 2, 3, 4, 5, 6. And since I want this element over here, the index number would be 4. Right. So this is how we can extract the element B from this vector. Similarly, if I wanted to extract this 6th element over here, all I have to do is give in the name of the vector, which would be my vector. I will give in 2 square braces, and inside that I will give in the index number, which would be 6.
Just a quick info, guys. Test your knowledge of R programming by answering this question. R functionality is divided into a number of dash: A. Packages, B. Functions, C. Domains. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Right, so we have extracted this false value. Now, let's say we wanted to extract only the alternate values or the alternate indexes from this vector. That is, the 1st, 3rd, and the 5th values from this entire vector. So for that, I would have to give in the name of the vector. Then I'll give in 2 square braces, and using the C function or the combine function, I'll be selecting the 1st, the 3rd, and the 5th index. Right? So from this entire vector, I have extracted the 1st element, the 3rd element, and the 5th element. Now, similarly, if I wanted to extract all of the elements starting from index number 2 to index number 5, this is how we can do it. So I will type in my vector over here. I will give in square braces. I will put in the 1st index number, which is 2, and then I will put in a colon, and then I will give in the last index number, which is 5. So like this, we can extract all of the elements starting from one particular index to the last index. So let me hit enter. So we have extracted all the elements starting from index number 2 to index number 5. So that is how we can work with that. That is how we can work with vectors. So next we have lists. So list is actually similar to a vector, but the only difference is a list can contain heterogeneous elements. That is, even though if you pass in elements of different types to the same list, they will be not coerced to the data type of higher precedence. So let's take this example over here. So this is how you can create a list. So first you will use in the list function, and then you will give in the individual elements. Now we see that one element is of numeric type and the other element is of character type. Now, even though this is of numeric, this will definitely not be coerced to character type. So this is the speciality of a list. So you can pass in heterogeneous elements where the heterogeneous elements will not lose their core identity. Right, so let me create the first list and name that list to be my list 1. And I'll use the assignment operator again. I will use the list function. Right. Now using the list function, what I'll do is I'll pass in 3 different elements. So the first element would be a numeric value 1. The next element would be a character value A. And the third element would be a logical value true. Let me hit enter. Now let me print out the list. So let me show you guys how does a list look like. So my list 1. So guys, this is how a list looks like. So see that there are 3 different components over here. So there's the first component, second component, and the third component, right? So this first component contains the numeric value 1. The second component contains this character element A. And this third component contains this logical element true. Now let me show you guys the class of each of these individual elements. So let me show you how to extract individual elements first. So my list 1 Now let's say I would want to extract the second component. So if I want to extract the second component from the list, I will give in square braces. Now inside the square braces, I will give in another set of square braces. Now inside this, I will give in the component number. And since I want the second component over here, I will put in 2. So this is how we can extract the second component from this entire list. Now let me have a glance at the class of this. So class of, I'll give in the name of the list, which is my list 1. I'll put in 2 braces. Inside the braces, I'll give in another set of braces. And let me give in the component number, which is 2. So you see that this is of type character. Now similarly, let me check the class of this component over here. So the component would be 3. So the class is logical. Now let me check the class of this first component over here, which is 1. So numeric. So you see that even though we are assigning elements of different type, these elements are holding on to their true classes or to their true data types, right? So the numeric value stays as a numeric value, the character value stays as a character value, and the logical value stays as a logical value, right? So now I'll go ahead and create another list. So I will name this list to be my list 2. And this time what I'll do is I'll use the list function and I'll pass in 3 vectors inside this list. So I will pass in a numeric vector inside this. So I'll use the C function, and the numeric vector would comprise of these 3 elements 1, 2 and 3. After this will comprise of a character vector, and the character vector would comprise of A, B and C. So let me change this to small b over here. Then I'll pass in the third vector or the third component. So the third component would comprise of logical values, and the logical values are true, false and true. Let me hit enter. Now let me print out this list. So let's see what do we get. So it's my list 2. So this is the list, guys. So this is the first component, this is the second component, and this is the third component, right? So the first component contains a vector of 3 numeric values. The second component contains a character vector of 3 different individual characters. Then we have the third component, which contains a vector of 3 logical values. So now let's understand how can we extract individual elements from this sort of list. So let's say I wanted to extract this element from this entire list. So this element is present at the second location of the second component, right? So first I would have to give in the name of the list, which would be my list 2. After this, I will specify the component. So 2 square braces. Inside that, I will give in another set of square braces. So now let me specify the component number, which is 2. After this, I will give in the element position. So in the second component or from the second component, I would want the element present at index number 2. So I will give in 2 over here. And we have successfully extracted this value. Now similarly, let's say if I wanted to extract this true value from this third component. So this is element number 1 at component 3. So I would have to give in the name of the list, which is my list 2. So I'd have to specify the component number. So the component number is 3. Then I'd have to specify the position where the element is present. So it is present at first position. So from the third component, I am extracting the first element and we get the true value, right? So this is how we can work with lists. Now let's go ahead to the third object, which is a matrix. So matrix is not actually a linear object. It is a 2-dimensional object. So when I say 2-dimensional object, it would have both the rows and the columns. And this matrix would contain only homogeneous elements or elements of similar type. And this is how you can create a matrix. So we can use the matrix function. So this matrix function first takes in the data where all the elements come from. After this, we specify the number of rows present in the matrix. So this is the result for this command over here. So when we specify the number of rows to be 2, we get the number of rows to be 2 over here, right? So this is how a matrix looks like. So we have rows and we have columns, and all of these elements are coming from this data over here. So let's head to our studio and implement a matrix. So let me use the matrix function. I'll type in matrix over here. Then let me pass in the data. So the data which should be present in the matrix should be coming from this vector, and this vector would be comprising of the elements 1, 2, 8. So let me hit enter and let's see what do we get. So this is the matrix which we get. So we have 8 rows and 1 columns. So if we do not specify the number of rows in the matrix, then it automatically assigns each element to a new row. So since we have 8 elements over here, we have 8 rows and 1 single column. So let me go ahead and use the n row parameter to set some predefined number of rows. So let's say I'd want 2 rows in the entire matrix. So the n row value would be 2. Right. So this is our matrix, guys. So we have 2 rows and 4 columns. Now what you see over here is these elements are arranged with respect to column and not with respect to row. That is, so this is 1, 2, 3, 4, 5, 6 and 7, 8. These are arranged with respect to the column. So if I wanted these to be arranged with respect to the row, I have the by row attribute and I will set this by row attribute to be true. So these elements which were actually aligned with respect to the column now have been aligned with respect to the row. So 1, 2, 3, 4 are in one row and 5, 6, 7, 8 are in another row. So I will store this in a new object and name that object to be mat1. Right, now let me print mat1 over here. So this is our matrix. Now let's understand how can we extract individual elements from this matrix. So let's say I wanted to extract this element over here. So this element is present at row number 2 and column number 3. So again, I would have to give in the name of the matrix, which is mat1. Then I will give in the square braces over here. Inside the square braces, I will first specify the row number. So the row number is 2. Then I'll put in a comma. After that, I will specify the column number. So the column number is 3. Let me hit enter. Right, so this is how we have extracted the element or the value 7 from this entire matrix. Right, now let's say I wanted the element this 5, 7 and 8 from this matrix. So let's do that. So again, I would have to give in the name of the matrix, which is mat1. After that, I will give in 2 square braces and from the second row. So the row number is 2, which I'd given, and I would require the element which is present at column number 1, 3 and 4. So I will use the combine operator and I will specify the column values which are 1, 3 and 4. Right? So this is how we can extract these individual elements. And similarly, let's say if I wanted to extract this entire row from this matrix. So for that, I would have to type in the name of the matrix, which is mat1. I will use the square braces. So I will give in the row number, which is 1. And since I don't want all of the columns from this row, I'll not assign anything over here. So I'll just leave it to be blank. Right? And voila, we have extracted all of the elements which are part of the first row. Right, so that is how we can work with the matrix. Next, we have an array. So arrays are basically just an extension to a matrix. So matrix was a two-dimensional object. So arrays, since they are an extension to matrix, they have more than 2 dimensions. And the elements which are stored in an array, they are all homogeneous. So this is the syntax to create an array. You use the array function and then you pass in the data values. After that, you set the dimensions. So this, what you see over here, 3, 3, 2. So this basically tells you that we will be getting 2 matrices which would have 3 rows and 3 columns each. Right, so if this seems too confusing to you, let's go to R and let's actually create an array by ourselves. So to create the array, let us first create the vectors which would be passed in as the data elements inside the array. So let me create the first vector. I'll name that first vector to be v1. And the values in this vector would be all of the numbers starting from 1 to 8. Now I will create another vector and name that vector to be v2. And the elements which would be there in this vector are the numbers starting from 9 to 16. Let me hit enter again, right? So let's have a glance. v1 is all the numbers from 1 to 8 and v2 is all the numbers from 9 to 16. Now I can go ahead and create the array. So I will use the array function. Now let me give in the data. So the data is coming from those 2 vectors over here. I will use the C operator to combine those two vectors. First vector is v1, second vector is v2. So we have successfully given the data. Now let me set the dimensions, right? So let's say I would want two matrices where I have where I want each matrix to have 2 rows and 4 columns. So I will use C. So I will give in the first value, which would be for the row. So I would want 2 rows, I would want 4 columns, and I would want 2 such matrices. So this is what we get. So this dim value of 242 basically states that I have 2 matrices which are of 2 cross 4 type. So each of these matrices has 2 rows and 4 columns. So let me store this in a new object and name that object to be ARR1. Let me print ARR1 now, right? So this is our resultant array. Now let's understand how can we extract individual elements from an array. So again, I would have to give in the name of the array, which is ARR1. Then I will give in the square braces, and inside these square braces, let's say I'd want to extract this element over here. So this element is present at second row, second column of the second matrix, right? So these would be the values. So I will give in the row number, which is 2. I would give in the column number, which is also 2. Then I will give in the matrix number, which is also 2, right? So we can extract this element like this. Now let's say I would want to extract this element value 8 from this entire array. So this is present at row number 2, column number 4, and matrix number 1. So let me give in the name of the array, which is ARR1. So I will give in the row number, which is 2. Then I will give in the column number, which is 4. Then I will give in the matrix number, which is 1. Right? So we have extracted this element value 8 from this matrix. So this is how we can work with arrays.
Just a quick info, guys. Intellipaat provides online data science master's program in partnership with IBM. The course link of which is given in the description below. Now let's continue with the session.
And then we have something known as a factor. So factors are basically objects which are used to categorize the data. So let's take this example over here. So we have a character vector over here, but in this character vector, we have the same element value repeating twice. So we have male, female, female, male. So we have male repeating twice and female repeating twice. So this basically means that we can convert this into a categorical variable. That is, we can convert this into a categorical variable which would have 2 categories. The first category would be male and the second category would be female. So this is where the factor objects come in. So what we'll do is we will take this character object, we will put this character object as a parameter, the as.factor function, and then we can convert this into a categorical variable or a factor variable. So let's go to our studio and work with some factors. So now what I'll do is I'll create a vector once. So that vector would comprise of 3 character elements x, y, and z, and I will repeat those same values 5 times. And to do that, I would require the REP function, which stands for repeat. So inside this repeat function, I am creating a new vector which would comprise of 3 character elements. So the first character element is x, the next character element is y, and the third character element is z. So we have 3 character elements. Now what I'll do is I will be repeating these 3 elements 5 times. So let me hit enter. Right? So what you see is x, y, z is being repeated 5 times. So this is once, twice, thrice, 4 times, and 5 times. So now I will store this in a new object and I'll name that object to be my data. Let me check the class of my data. Class of my data. Right, so this is a character. Now since we already know that this character vector has 3 different categories, right? So let me print in my data again, right? So this character vector has 3 categories which are being repeated again and again, and these 3 categories are x, y, and z. So now if I wanted to convert this character vector into a categorical variable, all I need to do is use the as.factor function inside this as.factor function, I will pass in the my data variable and I will store it back to my data. Now let me have a glance at this class of my data. So this time we see that this is a factor. Right, now let me print my data. Let's see what is the difference, right? So see that these are all of the elements and the elements have been segregated, right? So we have 3 levels, X, Y, and Z. Okay, so this was how we can create factor objects in R. And then finally, we have a data frame. So data frame is basically a 2-dimensional structure where we can have heterogeneous elements. So here, each column can comprise of only homogeneous elements, while a row can either contain homogeneous or heterogeneous elements. So, and this is the command to create a data frame in R. So we will use the data.frame function, and inside this data.frame function, we can create different columns. So here what we are doing with this command is we are creating 2 new columns. So I am naming the first column as name, and the values which would go in the first column are Sam and Bob. The name of the second column is age, and the values which would go into the second column are 32 and 48, right? And this is the resultant data frame which we get. So we have 2 columns. The first column is name, the second column is age, and the values under name are Sam and Bob, and the values under age are 32 and 48, right? So now let's go to R and create a data frame by ourselves. So now what I'll do is I want to create a data frame which would be comprising of 2 columns. The first column would comprise of names of fruits, and the second column would comprise of the cost of those fruits. So I will use in the data.frame function, and I will name the first column to be fruit name. Now let me assign values to this first column by using the C function. So let's say I want 3 fruits over here. So the first fruit would be mango, the second fruit would be apple, and the third fruit would be banana. So now we have created the first column. After this, we'll go ahead and create the second column. So the second column would be fruit cost. So let's assign some cost to those 3 fruits. So the first cost value would be, let's say, 105. The second cost value would be 57, and the third cost value would be 80. So now I will store this in a new object and name that object to be fruit. Let me have a glance at fruit now. So we can use the view function to have a glance at a data frame. So view of fruit, right? So we have successfully created this data frame which would comprise of these 2 columns. So the first column is the name of the fruit, and the second column is the cost of the fruit. The first column comprises these 3 values, mango, apple, and banana, and the second column comprises these 3 values, 105, 57, and 80, right? So now we'll learn how to extract individual columns from this data frame. So let's say I wanted to extract this fruit cost column from this data frame. So for that, I would have to give in the name of the data frame first, which is fruit. After that, I will use in the dollar symbol, and using that dollar symbol, I will select that column which I want to extract. And since I want to extract this fruit cost column, I will select this. So what I'm basically doing is, from the fruit data frame using the dollar symbol, I am extracting the fruit cost column. So let me hit enter, right? So we have successfully extracted this column from this data frame. Now let's also understand how can we extract individual values from this data frame. So let's say I wanted to extract this value from this data frame. So this value is present at 3rd row, 2nd column. So if I wanted to extract that cell value present at 3rd row, 2nd column, then I'd have to give in the name of the data frame first, which is fruit. I will give in square braces. First, I will give in the row number, which is 3. Then I will give in the column number, which is 2. Let me hit enter. All right. So we have extracted the cell value from this data frame over here. So these were the different objects with which we could work in R. Now let's head on to decision-making statements. So decision-making statements basically help us to impose a condition, and on the basis of that condition, execute some statements. So in general, we basically work with these two decision-making statements. So we have if and if else, right? So now let's start with if. So this is how the if statement works. So first we will give in the condition and check if the condition is true or false. So if the condition is true, then the rest of the statements will be executed, else nothing will be done, right? So this is how the if syntax works. So we'll give an if over here, we will give in the condition, and if this condition is evaluated to true, only then some sort of action is done, else nothing happens at all. Okay, so let's go to our studio and work with the if statement. Right, so now what I'll do is I will actually create a new vector and name that vector to be check decision, and inside this vector I will give in 6 numeric values, which would be 10, 20, 30, 40, 50 and 60. Right, so we have our check decision vector ready. Let me hit enter. Right, so we have this vector ready. Now let me use the if statement to find out if the element present over here, the value of the element present over here is greater than 30 or not. And if the value is greater than 30, I will perform some action. So I will type in if over here, then I will give in 2 braces. Inside this, let me give in the condition. So the condition would be check decision, and I am checking if the element value, this value which is present at index number 3. So if the value present at index number 3 of this check decision vector is greater than 30, then I will print out the element present at index 3 has value greater than 30. Now let me select all of this and let me print. Let's see if we get something or not. So guys, we don't get anything, so we don't get a result. So why is it that you think? So this is because this condition has been evaluated to false, right? So the third element was exactly 30. So let me print check decision over here. So this is the first element, second element, and this is the third element in check decision. So over here, the condition is if this element's value is greater than 30, only then we will print this, else nothing will happen. And since 30 is not greater than 30, nothing is happening over here. Right. So now let me make a small alteration over here. So what I'll do is I am checking if the element present in the third index, the value is equal to 30. And if the value is equal to 30, I will print the element present at index 3 has value equal to 30. Let me select this command. Let me paste it over here. Right. So this time, this condition is evaluated to true. So the index which is present at 3 has the value 30. And since this is evaluated true, that is why this statement has been executed and we get the result. The element present at index 3 has value equal to 30. So that was the if statement. Now let's look at the if else statement. So the problem with the if statement was if this condition was evaluated to false, nothing else was happening. So this is where if else statement comes in. So here what we do is we check the condition first, and if that condition is evaluated to true, we do certain set of actions. But if the condition is evaluated to false, we do an alternate set of actions. So we just don't leave it out there, right? If the condition is evaluated to true, we perform first set of actions. If the condition is evaluated to false, we have an alternative set of actions. And this is the syntax for that, right? If condition, this is evaluated to true, then these statements are executed. Else, or in other words, else the condition is false, then the statements below this are executed. Right. So now let's use the if else statement. So now I'll be working with this same check decision vector. So now this time what I'll do is I'll be using the if else clause, and I will check if this value is greater than 30. And if this value is greater than 30, I will print value is greater than 30, else I will print value is not greater than print 30, right? So it's a very simple thing, guys, right? So I am using the if statement over here, and over here I will be using the vector which is check decision, and I am checking if the element 3 of the check decision vector, the value is greater than 30. And if the value is greater than 30, I will be printing value greater than 30. Else, I will print value not greater than 30, right? So now let me select all of these and let me paste it over here and let's see what is the result, right? So we get value not greater than 30. So what has happened over here is, so we have checked the condition, this condition evaluated to false. And since this condition evaluated to false, we will come to this else block over here. So this else block is printing value not greater than 30. Right, so these were some decision-making statements. Then we have looping statements. So the looping statements basically help us to iterate a certain task, right? So I'm repeating it again. The looping statements, as the name states, they help us to loop a certain set of actions or iterate or repeat a certain set of actions. And the two most commonly used looping statements are for and while.
Just a quick info, guys. Test your knowledge of R programming by answering this question. Which of the following is used for statistical analysis in R language? A. Studio, B. RStudio, C. Heck. Comment down your answer in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
So let's start off with the for looping statement. So this is how this works. So we have the syntax over here, for variable in vector, and then these are the statements which are executed. So what we are basically doing is we will extract the first element from the vector, then we will perform certain set of actions, and then we'll check have we reached the last element or not. So if we haven't reached the last element, we'll go back, we'll extract the next element, we'll perform the same set of actions, and then again we'll check if we have reached the last element. And this process goes on till we have reached the last element, right? So let's go to RStudio and implement a for loop. So this time what I'll do is I'll create another vector and I will name that vector to be check loop, and the values which I'm assigning to check loop would be 100, 200, 300, 400, 500 and 600. So let me print check loop over here, right? So we have a vector ready. So now this time using the for loop, what I'll do is I will be adding 50 additional, so I'll be adding additional 50 values to each of these elements, right? So this 100 will be turned into 150, 200 will be turned into 250, 300 to 350, this to 450, this to 550, and this to 650. So let's do that using the for loop. So I will use for, and we automatically have the snippet over here. So first I need to give in the variable name which would parse through the vector. So let's say I name it to be I, and the vector which I need to iterate through would be check loop. So this I would start from index value 1, and this will iterate through the entire vector. And after iterating, what I'm going to do is I'm going to add a value of extra 50 to each of these elements. So print of I plus 50. So let me explain this properly. So what will happen is for I in check loop. So for I in check loop, initially the value of I would be 100. And since the value of I is 100, I am adding another 50 to this, and the result would be 150, right? So once this is done, I am going back and I'll check if I've reached the last element or not. No, I have not reached the last element. So the next element is 200. So now I'll take in that 200 and I'll add another 50 to it. So the value would be 250. Next, I'll go back and check if I have reached the last element or not. Again, I have not reached the last element. So this time the next element's value is 300. So this time I'll print 300 plus 50, right? So this is how it'll go on till the last element is encountered. So let me select all of this. Let me print it over here. Right. So this is the result. So initially we had 100, 200, 300, 400, 500 and 600. And those values have been changed to 150, 250, 350, 450, 550 and 650 using the for loop. So next we have the while loop. So let's understand how this while loop works. So here first the condition is evaluated, and if the condition turns out to be true, then this certain set of actions are done. And if this condition is evaluated to false, we exit out of the loop. So let's say we keep repeating this till the loop or the condition is evaluated to true, right? So I'm repeating it again, guys. So this condition or the loop will run till the condition is evaluated to false. So as long as the condition is true over here, this loop will continue to go on. Right, so let's implement a while loop over here. So I'll be working on the same check loop vector. And this time what I'll do is I'll add additional 100 to the same elements. So I will use while and I will give in condition over here. So the condition would be while I is less than length of check loop. So now here I will not automatically get a value. So you would actually have to initialize the value of I. So let's say the initial value of I is equal to 1. And let me actually set it to be I is less than or equal to length of check loop, right? And if this as I is less than or equal to length of check loop, what I'll do is I will add additional 100 to this. So print of check loop, I'll use the square braces. I will pass in I over here and I will add additional 100 to each element. Then I would also have to increment the I value with 1. So let me go through this again, right? So initially I am assigning the value of I to be 1. So here what is happening is, so this would actually be 1 is to length of check loop, right? So this would actually, so this would be the same, guys. I is less than or equal to length of check loop, right? So what we are doing is first we are checking if the value of I is less than the length of this. And since there are 6 elements in total, one is obviously less than or equal to this. And since this is less than or equal to this, we will be printing the first element and adding 100 to this. After that, we'll be adding one more to the I value and then check if the I value is less than or equal to the length of the check loop. And this goes on till I value is greater than the length of check loop. So let me select all of this and let me paste it over here. Right. So this is what we get over here. So this is how we can work with the while loop.
So this is the assignment. So we'll start off with the select function from the deployer package. So again, we'll have to select the 5th column and the 15th column. Let's do that. So again, this is very simple. We've already seen this, how to select some columns from the data set. So which is a 5th column, 1, 2, 3, 4, 5 dependents, that is a 5th column. So again, first we'll give in the name of the data frame. Then using the pipe operator, we will connect this data set with the select function, and I am extracting only the 5th column and storing it in customer 5. So view of customer 5, right? So this basically gives us the dependence column from this entire data set. Now similarly, we can also extract the 15th column. I'll just let that be because again, that's very simple and it's redundant, right? So after this, we'd have to extract the column numbers 3, 6, 9, 12, 15, and 18 and store it in customer 3 multiple. All right. So Again, the name of the data set, the pipe operator, the select function, and inside the select function, I'll give in all of the column numbers which I want to select. So 3, 6, 9, 12, 15, and 18, I'll certain customer 3 multiple, view of customer 3 multiple, and these are all of the columns that we have just extracted. Right. Now I have to extract all the columns starting from column number 10 to column number 20. So for this, I'd have to just put in a colon over here. So first the name of the data set. So inside select, so it'll be 10 to 20, right? So the first column number, a colon, and then the last column number. So I'll be extracting all the columns starting from column number 10 to column number 20. So C 10, 20, view of C underscore 10, 20, right? All the columns, and this is what we have. After this, we'd have to extract all the columns which start with the name capital P, right? All the columns which start with capital P. So this is something different. So now inside the select function, we have the starts with attribute. So with the help of the starts with attribute, I can extract a particular pattern. So over here, I'll give in a pattern over here. So I want to extract all those columns which start with the letter P, and I'll store this in customer P, view of this, right? So we have extracted all those columns where the column name starts with P. Now similar to starts with, we also have the ends with attribute, and over here we are extracting all those columns which end with S, like this column over here, like this column over here. All right, so we are extracting all those columns which end with S, or the name of the column ends with an S. View of customer, this is S actually. All right, so these are the 5 columns where the column name ends with an S. All right, so these were very simple actually, I believe, just using the select function to select some columns. And then we have the filter function where we can filter out some records on the basis of a condition. So first, we'd have to extract all those customers where the internet service is equal to DSL. Let's do that. So customer churn, pipe operator, and then the filter function, and the condition is internet service is equal to DSL, and I'll store it in customer underscore DSL. View of customer underscore DSL. So let me have a glance at the internet service, right? So we have only those records where the internet service is equal to DSL. So there are 2,421 customers whose internet service is DSL. All right. So after this, we'd have to extract those customers where the contract type is month to month and store it in customer month. Let's do that. So this time the condition is contract is double equal to month to month. That's it, as simple as that. So this is a contract column. So over here, basically we have 3 values, month to month, 1 year and 2 year. And we are supposed to extract only those columns where the contract is equal to month, and we'll store it in customer month, view of customer month, contract column, where is it, right? So there are 3,875 customers whose contract type is of month to month. Right. And then the next question, we are supposed to extract all male senior citizens whose payment method is electronic check and store the result in senior male electronic. So over here, the first condition is gender needs to be equal to male. The second condition is senior citizen value needs to be equal to 1. And the third condition, payment method needs to be equal to electronic check. So let's do that. First, we'll given the name of the data frame, the pipe operator, and then inside the filter function, we have to given the three conditions. So the first condition is gender needs to be equal to male. The second condition is senior citizen needs to be equal to 1. And then the third condition is payment method is equal to electronic check. So basically we are extracting all male senior citizens whose payment method is equal to electronic check. And also return senior male electronic. So view of senior male electronic. So there are 298 senior male citizens whose payment method is electronic check. So any doubt with respect to this command over here? So basically we have given three conditions inside this filter function. Any doubts still here? No? Great. Okay. So after this, we'd have to extract those customers where the tenure is greater than 70 months or their total charges is greater than $8,000. So till now we have used the AND operator. Over here we'll be using the OR operator. So this time the first condition is tenure needs to be greater than 70 or total charges needs to be greater than 8,000. And we'll store this in customer total tenure. View of customer total tenure. Right. So let's have a glance at tenure. So we see that the tenure is greater than 70. Let's have a glance at total charges, right? So now, even though over here, the total charges is not greater than 8,000. So let's actually take, right? So this first cell value over here, even though the total charges is not greater than 8,000, but the tenure is greater than 70. That is why we have this a record over here. Similarly, even though the total charges is not greater than 8,000, but still again the tenure is greater than 70, so that's why we have this record. So it's OR operator. So either this condition has to be true or this condition has to be true, right? So let's head on to the final question on the filter function. So now we have to extract those customers whose contract is of 2 years, payment method is mail check, and the value of churn is equal to yes. Let's do that. So again, three conditions. First condition is the contract needs to be of 2 years. The second condition, payment method is equal to mail check, and third condition, churn is equal to yes, and we'll store this in 2 mail years. View of 2 mail yes. So this is quite interesting, right? So we have just 3 records or 3 customers where the contract is equal to 2 years, the payment method is equal to mail check, and the churn is equal to yes. Or in other words, there are only 3 customers whose contract is of 2 years, payment method is mail check, and will be churning out to another network. So this was all about the filter function. Right, so let's head on to the next function of the deployer package, which would be sample in, sample frac, and count. So we are supposed to extract 333 random records from the customer churn data frame. Let's do that. Right. So we given the name of the data frame, which is customer churn, and then the sample n function. Basically, again, so this is basically an analogous to the sample function from the base R. So sample n is a part of deployer. So you can consider this to be analogous to the sample function from base R, right? So we want 333 random records from the entire customer churn data set, and I'm storing that into customer 333. View of customer 333. So these are the 333 random records. Similarly, if I want 1000 random records from the entire data frame, I just have to give in 1000 inside this. View of customer 1000. So these are the 1000 random records which I have. Now So after sample n, we have the sample frac function, which helps us to select a random percentage of records from the entire data set. So over here, we are extracting 23% of the total records randomly, right? So we'd have to give in a fractional value 0.23. So this 0.23 basically means that we are randomly can we sample random samples from the first? Okay, so for that you'd have to so I don't think that is possible with the sample n function for this. That wouldn't be possible with the sample n function. All right. So first you would actually have to maybe select the first. Okay, so you'd have to do two steps for this. First would be customer churn. I want all the columns and I want the first 1000 records. So I will store this in customer 1000. Now out of this, I want a random sampling of 333, right? So you'd have to do this in two steps basically. Sample n and then 333. So I'll just do this in 3 view of 3, right? So you would basically have to do this in two steps. So the first step, you'd have to extract the first 1000 records manually, and then you'd have to do the random sampling. Right, so we were working with the sorry for that. Yeah, so as I was saying, we were working with the sample frac function and this. So we are extracting 23% of the records from this entire data set. View of customer 23%. So basically 23% of 7043 comes down to around 1620. So this is random sampling of 23% of the records from the entire customer churn data set. Right, so after this we have the summarize and group by functions. So we will basically not do the first two because again this doesn't mean anything. So we'll do the third, fourth, and fifth. So we'd have to find out the standard deviation of tenure and group it with respect to payment method. Let's do that. So what we are doing is we want to know the standard distribution, the standard deviation of tenure with respect to the different categories of the payment method. So I want to know the standard deviation of tenure with respect to electronic check, the standard deviation of tenure with respect to credit card, standard deviation of tenure with respect to mail check, and so on. So again, first I'll give the name of the data frame and then I will give in the group by function. So first I will group it with respect to the payment method column. So after I group it, then I will summarize. So inside the summarize function, I'll give in the standard deviation of the tenure. So this is what we get. So the standard deviation with respect to bank transfer is 23 months, with respect to credit card as 23.3, with respect to electronic check as 22.4, and with respect to mail check as 21.2. Right. Now you guys need to keep in mind that the sequence should be first the group by function and then the summarize function. So if you interchange these two, then this will not work. So let's say I will do Control X over here and then Control V over here. So now this won't work because we are giving the name of the column later on, right? So this is why this will not work over here. So basically first you would have to group and then you would have to use the summarize function. So this is how basically you can use the group by and summarize functions together. Now, after that, we'd have to find the median of monthly charges with respect to the contract column. Let's also do that. So whereas the contract column, right, so we want the median of this monthly charges with respect to 1 year, with respect to month, and with respect to 2 years. So again, first we'll give the name of the data frame, and then we'll give the group by function, and then we are grouping it with respect to the contract column. After that, inside the summarize function, we will, so we basically want to summarize the median of the monthly charges. Right, so the median monthly charges of those customers whose contract is month to month is around $73. Of those customers whose contract is 1 year, it's around $68. Of those customers whose contract is 2 years, it's around $64. And then finally, we want the variance of total charges with respect to internet service. Let's do that. All right, so I want the variance of monthly charges over here with respect to internet service. Was it? No, so that was variance of total charges with respect to internet service. So let me just change it to total charges over here. And then I need to group it with respect to internet service. All right. So now over here we have NA values because there are already some NA values present in the total charges column. So let's go ahead and remove those NA values. So over here, I just have to put NA.RM equals true. When I do this, those NA values are removed and I get the total charges for DSL, for fiber optic, and when the customer doesn't even have internet service. So this was working with summarize and group by. All right, any doubts till now? Right. So then we are also done with data manipulation. Now it's time to start with data visualization. So we'd have to make bar plots. So the first bar plot is for the phone service column. So let's create a bar plot for the phone service column. Where do we have phone service? Right. So we'd have to create a bar plot for this. And now, so basically bar plots, as you might already know, they are used to understand the distribution of categorical values. So this is how we can create a bar plot. So we'll use the ggplot function. And first we will start off with the data layer. So first the data is customer churn, and then we'll add the aesthetic layer. So we are mapping the phone service column onto the X aesthetic. Now, after we're done with the data layer and the aesthetic layer, we will go ahead to the geometry, which is bar plot. So to make bar plots, we will use the geom bar function. Oh, I actually have to load the package first, library of ggplot2. Only then I can use the ggplot function. Right, so this is the distribution of the phone service column. So we see that majority of the customers, over 6,000 of the customers have phone service. There are like very few customers, like less than 1,000 customers who don't have phone service. So this is the inference which we can draw from this bar plot over here. So now after creating the bar plot, we were also supposed to add a fill color and a boundary color. Let's do that. So now inside the geom bar, I'll just use the fill aesthetic and set the fill aesthetic to be equal to pink. So this is how we can assign a fill color. Now, after assigning the fill color, we were also supposed to add a boundary color. So we can add a boundary color by using the COL aesthetic, and that was supposed to be Peru, right? So we have added a fill color as well as a boundary color to this. Then we are supposed to make a bar plot for the internet service column. Let's do that. So again, data layer customer churn, and then we map the internet service onto the X aesthetic, and then we make a bar plot for this. So this is the distribution of the internet service column. So we see that there are more than 3,000 customers whose internet service is of type fiber optic. There are around, let's say, close to 2,400, maybe 2,400 customers whose internet service is DSL. And then there would be around 1,500 odd customers who don't avail internet service.
Just a quick info, guys. Intellipaat provides online data science master's program in partnership with IBM. The course link of which is given in the description below. Now, let's continue with the session.
So after this, we were supposed to assign the contract column onto the fill aesthetic. Let's do that. Right, so now basically we are not using fill as an attribute, we are using it as an aesthetic. So if you want to use fill as an attribute, we will give this inside geom bar. But if you want to use this as an aesthetic, we will give this inside the aesthetic layer. So basically we are mapping internet service onto the fill aesthetic. So the fill color of these bars would be determined. Oh, so it was actually supposed to be determined by the contract column. So let me change it to be contract. All right, so the fill color should have to be determined by the contract column. So this is how a plot will look. So over here, this pink color is for those customers whose contract is of type month to month. This green color is for those customers whose contract type is of 1 year. And this blue color is for those customers whose contract is of type 2 year. So if we take this first category where the internet service is DSL, then we see that the major proportion is of those customers whose contract is month to month. Similarly, again, those whose internet service is fiber optic, again for them, the contract is majorly month to month. Now, if we take the third case where people don't even avail internet service, then most probably their contract would be of 2 years, right? So there is a greater probability for those customers who don't avail internet service. So their major probability, so their contract for them, the major probability is to be of 2 years.
Just a quick info, guys. Test your knowledge of R programming by answering this question. R functionality is divided into a number of dash. A. Packages. B. Functions. C. Domains. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Right. So after this, we were supposed to set the position of the bars to identity. Let's see what is the difference over here.
Actually, I have a question.
Yeah, sure.
What is the count on y-axis? What is the count on y-axis?
Count as the number of customers over there.
But in the data set, I think more than 7,000 customers. So why is showing only 3,000?
Because this is the range we have over here. Out of the 7,000, there are 3,000 odd whose internet service is fiber optic. There are 2,000 odd whose internet service is DSL. and there are 1500 odd who don't even avail internet service. So like add this up, 3000 plus
Yeah, got it.
2500 plus 1500. So that comes down to 7000 odd.
Okay, I got it. Okay.
Right. Okay, identity is this. Seems like this is not changing to anything. Okay, great. So, and finally, we are supposed to make a final bar plot for the tech support column. Let's do that. Again, data is customer churn. We are mapping tech support onto the X aesthetic and the geometry is geom bar. So this time, the number of customers who don't avail tech support is very high. So there are around 3,500 customers who don't avail tech support. And these are those customers who just don't even have internet service. So there are 1,500 customers who don't even have internet service. And this value is basically for those customers who have internet service and also avail tech support. So there are around 2,000 customers who have internet service and avail tech support. So this is how we can draw inferences from this bar plot. After that, we were supposed to assign churn onto the fill aesthetic. Let's also do that. So this time the pink color that denotes those customers who will not churn out, and the blue color denotes those customers who will be churning out. So if you take this category DSL, then the proportion of customers who will be not churning out is high. So it is actually the same case for all three bars, right? So the proportion of those customers who will not be churning out is high in these three cases. Right. So that was how to make bar plots, right? So are you clear with making bar plots and adding colors to them, assigning different columns onto the fill aesthetic? Any doubts with respect to this?
No.
Okay. Right, so bar plot, we're done. And then we have to make histogram. So we have to make a histogram for the tenure column. And then we'll have to add the fill color, the boundary color, and change the number of pins. Let's do that. So again, the data is this, and we are mapping tenure onto the X aesthetic. So this time the geometry is histogram. So if we have to make a histogram, we have to use the geom histogram function. And this is the distribution of the tenure column. So if we want to get the distribution of a continuous variable, then we'll go ahead and make histograms. Right, so this you'll have to understand the difference between bar plots and histograms. So bar plots you'll use when you want to understand the distribution of categorical columns, and histograms you'll use when you want to understand the distribution of continuous columns. So this basically states that there are around like 600 odd customers whose tenure is like not even 1 month. They churn out before 1 month. So there is a very high proportion for this. And then again, there is again a high proportion. So there are around like 500 or 550 odd customers whose tenure is around 70 months or something. And if we take this one, so there are around 200 odd customers whose tenure will be around 42 months. So let's take this case. So there would be around 310 odd customers whose tenure would be 10 months. After that, we were supposed to assign a fill color. So we are using fill as an attribute, not as an aesthetic. So that is why we'll use this inside the geom histogram function. And the fill color which we are assigning is medium spring green, right? So this color which you see over here, this is medium spring green. After this, we are also assigning a boundary color by using the COL attribute, and the boundary color is azure. So this is azure. And then finally, we will go ahead and change the number of bins. So this warning which you see, using bins is equal to 30, pick better value with bin width, right? So by default, it just gives us 30 bins. So if you want to change the number of bins, then we can use the bins attribute. So this time I am setting the number of bins to be equal to 100. So when I set the number of bins to be equal to 100, this is what I get. Okay, so this was how we can create histogram for the tenure column. Now, similarly, we'll go ahead and create a histogram for the monthly charges column. So again, data is customer churn. We are mapping monthly charges onto the X aesthetic, and the geometry which we are using is geom histogram. So this is the distribution of the monthly charges. So there is again a very high proportion over here. So this tells us that around 1100 customers whose monthly charges is around $25, right? So this is the greatest the range. So there are very high customers whose monthly charges is very, very less. So there are 1100 customers whose monthly charges is just around $25. And if we take this case, so there are very few customers, so there would be around maybe 280 or 280 odd customers whose monthly charges are actually greater than 100, and there would be like exactly 300 customers whose monthly charges are $100. So again, if we take this peak, so like close to around 300 customers whose monthly charges would be around maybe 55 or 60 over here. So this is how you can draw inferences from this histogram. Now after this, we are supposed to map the payment method onto the fill aesthetic. Right, so over here, what we've done is we have mapped the payment method onto the fill aesthetic. So this pink color denotes bank transfer, green color denotes credit card, blue color denotes electronic check, and this dark pink or purple, whatever color you call this basically represents the mail check. So again, there is like no purpose to add this color, so this just brings in more chaos. But then again, later we'll see that we have something known as a facet grid. So using facet grid, we can separate each of these categories into separate facets. So that is when the visualization would be even better. All right. Now, after this, what are we doing? So we are setting the position to be equal to identity. Right. So the difference between this and this is basically, so whatever, so let's take this case over here. So the bank transfer. So this bank transfer is the like absolute value of this, right? So the absolute value of bank transfer would be from this to this. So this will be around 200 odd. And this is again the absolute value of credit card, which is around maybe, how much is this? Again, 200 odd. So now what we'll do is we will be basically stacking the absolute values on top of each other, and we'll get only those values. So over here, mailed check has the maximum count. The other values basically go behind this. So the other bins which you saw in the earlier graph, electronic check, credit check, and bank transfer, those bins have been basically stacked behind this, this mail check. So identity basically is, it shows you the true identity. The other values or the other categories go behind this original histogram. So this basically helps you to understand the proportion of those bins which have the maximum values over here. So let's see over here, let's say if the monthly charges is somewhere around $25, then most probably their payment method is mail check. Similarly, if you take this group over here, so this group, if the monthly charges is somewhere between $75 to $100, then the major proportion of customers, their payment method is electronic check. So this is the sort of inference which you can draw from this. Now, similarly, let me also map the online backup column onto the fill aesthetic, right? So this is what we get over here. Again, these are the absolute values. So let's see if I set the position to be equal to identity over here. So this is the difference. So this is the absolute values. This is when the position is equal to identity, right? So this time, if the monthly charges are around $25, then most probably they don't even have internet service. And if their monthly charges vary from $75 to $100, then they will have internet service and they will also be availing online backup. And similarly, if we take this, so this would be somewhere between $70 and $75. So if it's $70 and $75, then most of the customers have internet service, but they are not availing online backup. Right. So any doubts still here on how we are using this identity position, the difference between this and the previous plot? Okay. So we'll just make the final histogram then. So we'd have to make a histogram for the total charges column. Let's also do that. Control C and then ES. Okay, right. Right. So x-axis, we are mapping the total charges, and I'll actually delete this first and then add it later. Right. So this is a distribution of the total charges column. So we see that the majority of the customers, their total charges is somewhere around, how much would this be? So this will be 1250. So this will be somewhere around $500 maybe, right? So there are very, very few customers. So let's take this. So there would be around 125 odd customers whose total charges are around $5,000. Again, there would be around, let's say, 50 odd customers whose total charges would be greater than $7,500. Now let's also map the gender column onto the fill aesthetic. So fill should be equal to gender. Right. So over here, this pink corresponds to all of the female customers. This blue corresponds to all of the male customers. Right. Again, let me set this to be identity over here. So what this basically means is there is just a greater proportion of male customers in our data set than female customers. We have this totally blue because, again, there is a greater proportion of male customers in our data set than female customers. All right. Now let me map the internet service column onto the fill aesthetic. All right. So we see that we have three colors actually. So let me remove identity first. So we have three colors. Blue is for those customers who don't even have internet service. Green is for those customers who have internet service and their internet service is fiber optic. And pink is for those customers who have internet service and their internet service is equal to DSL. So again, the people who don't have internet service, so their maximum total charges would come to around maybe $1,800 or somewhere like that, right? And there is a greater proportion of those customers who avail either internet service of DSL or fiber optic, right? So this was all about histograms. Now we'll go ahead and make some scatter plots. So we'd have to make a scatter plot between total charges and tenure and map total charges onto the y-axis and tenure onto the x-axis. Let's do that. So till now, we did, so we had just one column mapped onto the x-axis. So in scatterplot, we'll have one column mapped onto the x-axis and one column mapped onto the y-axis. So this over here is basically total charges versus tenure. Total charges is mapped onto the y-axis and tenure is mapped onto the x-axis. So this is the aesthetic layer. And then if we have to make a scatter plot, we will use the geom point function. So this is basically the distribution with respect to tenure and total charges. So you see that as the tenure of the customer increases, the total charges of the customer would also increase. Now after this, we are supposed to assign color to this. So I am assigning a color of wheat 3 to these points over here. But so this color which you see, that is equal to wheat 3. Now I am using COL as an aesthetic, not as an attribute, and I am mapping the payment method column onto the COL aesthetic. I'll hit enter. All right, so again, so this is like very chaotic over here. So we pretty much don't really understand what this is. So again, to make better sense of it, we will have to facet this data with respect to different payment methods. Now I will map the gender column onto the color aesthetic. So again, this really doesn't make sense. We'll have to facet the data. All right. So that was basically between the total charges and tenure. After that, we'd have to make a scatter plot between tenure and monthly charges. Let's also do that. So we are mapping tenure onto the y-axis and monthly charges onto the x-axis, and the geometry is geom point. Now this scatter plot basically tells us that there is no proper relation between monthly charges and tenure. So we basically can't say that if monthly charges increases, tenure also increases, or if tenure decreases, the monthly charges increases. So we can't say if there is any sort of relationship between these two variables. Now, just for fun, let's also add some color to this. So we'll add yellow green to this. I'm using COL as an aesthetic. Sorry, I'm using COL as an attribute, and I'm assigning the color of yellow green. So this color which you see, this is yellow green. After this, I'll map the internet service column onto the COL aesthetic. So this time I am using COL as an aesthetic, and I'm mapping internet service onto the COL aesthetic. Now, when we map the internet service onto the COL aesthetic, so we basically get a sort of a bifurcation. So with this, we understand that. So this blue color is for those customers who don't have internet service. This pink color is for those customers whose internet service is DSL, and this green color is for those customers whose internet service is fiber optic. Now, the inference which we can draw from this is those customers whose monthly charges is like $25 or less than $25, their internet, so they basically don't even have internet service. After that, those customers whose monthly charges are between, let's say, $25 to around $70, then their internet service would be equal to DSL. Similarly, those customers whose internet service, those customers whose monthly charges is between $75 and $100, then most probably they would be availing the fiber optic internet service. All right. And then I'll also map the contract column onto the COL aesthetic. And let's see, what do we get? Well, this is not much clearer as compared to the previous plot, isn't it? Right, so again, we'll have to facet this to understand this better. So this was scatter plot. So basically we have mapped one column onto the y-axis and one column onto the x-axis, and we've used the geom point function to make all of these scatter plots. Right, so then we have box plots, and this time we have to make a box plot between tenure and partner column. Right, so now box plots are used where we have to understand the distribution between a categorical column and a numerical column, or basically a continuous variable and a categorical variable. So over here I am mapping tenure onto the y-axis and partner onto the x-axis. So over here, tenure is my continuous variable and partner is my categorical variable. So this were the aesthetics. So the geometry which I'm using is geom box plot. If the customer has a partner, their tenure value, their median tenure value is somewhere around 50 months. On the other hand, if the customer does not have a partner, then most probably his median tenure value is not even 20 months, right? So this is basically how we can draw inferences from box plots, right? So we'll basically compare the median values. So over here, the median value, if the customer has a partner, then seems like his tenure would be longer. And similarly, if the customer doesn't have a partner, then seems like his tenure will be shorter. So again, after this, let's also add some color to this. So we'll use the fill aesthetic and we'll use the fill as an attribute, and we'll map violet to these box plots. So this is violet. Now after this, I'll also add a boundary color, which will be snow 3, right? So this is the boundary color. After that, we'd have to make a second box plot where we have tenure and multiple lines. So tenure is onto the y-axis and multiple lines is onto the x-axis. Let's do that. So this is our box plot. So this time we see that if the customer has multiple lines, then he would have the maximum medium tenure value, right? So if the customer has multiple lines, then his median tenure value would be around 45 months, most probably. And if the customer has, so the customer doesn't even have internet service, then his median tenure value would be somewhere around 30 months. So this is for those customers. So they have multiple lines. They have phone service, but they do not have multiple lines. In that case, their tenure would be somewhere around 18 months or so. Now what we'll do is we'll go ahead and map the partner column onto the fill aesthetic. So this time we basically get 2 box plots for each of these corresponding categories, right? So this pink color denotes those customers who don't have a partner, and blue color denotes those customers who have a partner. So as we saw in the earlier case, those customers who have a partner seems like their tenure value is higher than those customers who don't have a partner, right? So each of these 3 categories, so let's take this category. So this is for, again, those customers who have phone service but do not have multiple lines. So seems like the median tenure value is like very high compared to this. Again, median tenure value very high, median tenure value compared to this very high. Right, and then what do we have? Yeah.
What is the dots on the first box plot? There is multiple dot on first box.
So those are basically the outliers, right? So normally when the customer does not have multiple lines, so basically his median tenure value would be somewhere between 1 month to around 25 months. So this is an aberration actually. So maybe there are 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 customers whose tenure value is basically an aberration. So normally the customer's value would lie somewhere in this range. So these are basically outliers over here.
Okay, thanks.
Right. Then we are supposed to make a box plot between tenure and contract. Let's do that. So this time tenure is onto the y-axis and contract is onto the x-axis. So again, so these outliers, we have outliers over here, we have outliers over here, right? So let's start with this. So normally if the person's contract is on a 2-year basis, then his median tenure would be greater than 60 months, right? His median tenure is greater than 60 months, and normally the tenure would be somewhere between 70 months to around 50 odd months, right? 50 months to 70 odd months. So these values which you see, these are outliers. So maybe around 10 odd customers who basically 10 odd customers whose tenure is less than maybe 15 odd months, right? These are again outliers. Again, in this case, so what we see is these are totally contrasting values. So if the person has a 2-year contract, then his tenure will be quite high. On the other hand, if the person has a month-to-month contract, then we see that his tenure is quite low over here. So if it is a month-to-month contract, then his median tenure would be somewhere around 12 months or so. So these are again outliers. So there are like only 4 customers whose tenure is greater than 70 months and their contract is month to month. And for this case, so this is like 1 year. So those customers whose contract is 1 year, their median tenure would be somewhere around 40 months.
Just a quick info, guys. Test your knowledge of R programming by answering this question. Which of the following is used for statistical analysis in R language? A. Studio, B. RStudio, C. Heck. Comment down your answer in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
Now let's map the internet service onto the fill aesthetic. So now what we get is 3 different box plots for the corresponding different internet service, right? So maybe you can have a look at this graph and draw inferences by yourself. All right. So we are also done with box plot, and then we will go ahead and facet our data. Right. So faceting again, so it basically whenever our graph is very chaotic, there are too many data points, there are too many columns mapped onto the same graph, we can use a facet grid to facet all of those data into different groups. So that is basically when we use a facet grid. So over here, first we are supposed to build a box plot between tenure and multiple lines, and then map the internet service to the fill aesthetic. So let's do that first. So this is our plot over here. Now we see that again, so drawing inferences might be a bit difficult from this. So this is where we will go ahead and facet the data with respect to the internet service column over here, right? So for that, we will have to use the facet grid function. And first we'll give the tilde symbol, and after the tilde symbol, we will give in that particular column on the basis of which we are supposed to facet the data. Right. So this was our original plot after faceting our data. So we have basically faceted the data on the basis of the internet service. So this is one group for the those customers whose internet service is DSL. This is one group for those customers whose internet service is fiber optic, and again this is one group for those customers whose internet service who don't even have internet service, right? So now drawing inferences from this is much easier than the previous plot. So we see that if we take these two cases, so if the internet service is either fiber optic or if the customer doesn't even use internet service, so they, so there is like 100% likelihood that they don't have a phone service, right? Now, all those customers who don't even have phone service, then all of those customers would belong to this category. So all of those customers would basically have the internet service DSL. Right. So this was the first part in fisting a data. After that, we will go ahead and create a scatter plot between total charges and tenure. Let's do that. And we are also mapping the contract column onto the color aesthetic. So again, drawing inferences from this is a bit chaotic. So what I'll do is I will facet this data on the basis of the contract column. So first I'll give the tilde symbol and then I'll facet this data on the basis of this contract column. Right, so this time I have 3 different facets. First facet is for those customers whose contract is month to month. Second facet is for those customers whose contract is 1 year. And third facet is for those customers whose contract is of 3 years. So again, this is basically much easier to either show it to other people and also to draw inferences from this. Similarly, again, the third was we have to build a histogram for just monthly charges, and then we have to map payment method onto the fill aesthetic. Right, this is done. Again, this is very, very chaotic. So we can facet this into different groups. Right. So now again, this is much more prettier than the previous plot. So we have different facets with respect to each of the different columns. So this is why we basically use faceting to make our graphs more pleasing to witness. So this was all about yeah.
Can we add bins to the same bar plot?
You can. So first you'd have to set this over here. Right. So inside this, I will set the number of bins to be equal to 100. Right? So we've changed this. So basically the number of bins, you'd have to set this inside this function over here, geom histogram. Now let's say I change this to maybe 1000. Let's see how it looks. Right, so this is how our graph will look when we set the number of bins to be 1000. So is that clear?
Yes.
Great. So this is how we can facet the data, and then finally we'll work with the theme layer. So the theme layer helps us to add themes, as the name basically states it. So first we will go ahead and create a bar plot for the gender column. Right. So what I'm doing is I'm creating a bar plot for the gender column. Now, after this, I have something known as the theme layer, right? So till here, the syntax is the same. Now, after this, I will add the theme layer on top of this. So inside this theme layer, with the help of this theme layer, I can add a color to this panel. So this, what you see, this is the panel onto which we draw our graphs. So with the help of the panel, we can add a color to this panel, and also this white background which you see, that is known as the entire plot. So with the help of the theme layer, we can add a color to the panel, and we can also add a color to the entire plot. So we will use the panel.background attribute and set a color to this. So we will just type in panel.background, and then we have the element rect function. So if we want to modify any of the rectangular objects in the theme, so this plot is a theme. So this plot is a rectangular object. This panel is a rectangular object, right? So if we want to modify any of the rectangular objects, then we will use the element rect function, and we will set it a fill color, which is chartreuse 4. So we have successfully mapped a fill color to the panel over here. Right, till now whatever graphs we saw, we were just creating the graphs, but then again we were not adding themes to the panel and the plot, right? So with the help of the theme layer, we have added a color to the panel. Now similarly, we can also add a color to the plot, to the whole plot. So till here again the command is same. After that I'll add another theme layer and inside that theme layer I'll add a background color to the entire plot, and the color for that would be corn silk 4, right? So I've also added a color to the background plot. So this is how we can add color to the panel and also to the background. All right, so any doubts over here on how we're using the theme layer? Right, so first we have to use this theme function. Yeah, go ahead.
These colors, where do we get, how do we get to know like what are the colors? Because this is not a RGB color or not a, so
Right.
these names are something specific to this ggplot or?
No,
or
so we have the colors, we have the colors function. So just use this command over here and you'll see all of the different colors which are available in R. So I'll just copy this command and paste it over here in the chat. Right. So use this command to have a glance at all of the available colors. Right.
Thank you.
Yeah. So after this, we are supposed to make a scatter plot between tenure and monthly charges and add a title, give a color to the panel, give a color to the plot, and then center align the title. Okay, great. Let's do that. So we are creating a scatter plot between tenure and monthly charges. This is our base plot over here. Now, after creating the base plot, we have the labs function. So with the help of this labs function, I can assign a title, right? So inside this, I will use the title attribute and assign this a title. So the title for this would be tenure versus monthly charges. So this was the initial plot. After that, we have used the labs function on top of this and added a title to this. Now, after adding the title, we will go ahead and add a color to the panel. So again, we'll use the theme function, and inside that we'll use the panel.background attribute and set the fill color to be coral 2. Right, so this color which you see, this is coral 2. Again, after this, we will also add a color to the plot. So till here, it's the same function. After that, we'll also add another theme layer. This time we will use the plot.background attribute and assign this a fill color of beige. So this becomes a final plot, right? So this is our scatter plot. This is the color of the panel. This is the color of the plot. And then we were also supposed to center align the title. So till now, whatever we've used, it's element rect, right? So we were supposed to make changes to rectangles. That is why we've used element rect. Now we are supposed to make changes to text. So if we are supposed to make changes to text, then theme layer has a function known as element text. And inside this, we will adjust this. So this is where we can use the hedge just attribute and center align this. So when we give this a value of 0.5, this will be center aligned, and we will also assign this a color of red. And And this is our final plot. So initially, this is what we had. After that, we center align this and also gave this title a color of red. Right, so we will follow this on adding the different theme layers on top of this. So ggplot2, the best part of ggplot2, why it is widely used in the industry is you can keep on stacking the layers one on top of the other, right? So like you see over here, this is the initial plot. So we just had the data layer and the aesthetic layer. On top of that, we added the geometry layer. On top of that, we added the labels layer. On top of that, we added another theme layer. And again, we added another theme layer, 2 more theme layers on top of that, right? So this is basically the advantage of ggplot. You can keep on stacking layers one on top of the other, right?
Just a quick info, guys. Intellipaat provides online data science master's program in partnership with IBM. The course link of which is given in the description below. Now, let's continue with the session.
So, statistical method for making simultaneous comparison between two or more means a statistical method that yield value that can be tested to determine whether a significant relation exists between variables. So essentially here we try to know about the difference of the mean of two or more groups. Like if we want to compare, there would be more and more example. One more example is given. A car company wishes to compare the average petrol consumption of 3 similar models of a car and 6 vehicles of each models. So what essentially we are saying that we are considering 3 different models and 6 vehicles of each model. So we have altogether 18 cars. Out of those 18 cars, there are 3 groups, there are three different varieties of cars, and we are using 6 cars from each group. So we are going to compare all 3 groups together to find out that how is which car is similar to other, or which group is similar to others, or which group is dissimilar to others. So it helps us to find out the the difference between the mean of different groups. Now the question comes, manually we can compute the mean and we can say that the mean of one group is higher than the mean of other group. Yes, that we can do, but essentially when we talk about the difference in mean, we are talking about the statistical significant difference. We are not talking about the overall average difference of the mean. There may be overall difference in the mean exist, but that should not be statistical different. The moment we talk about statistical different, there is certain measurement to compute or to say the difference into the statistical standpoint. So it's not as a overall difference in the mean. We talk about difference considering certain statistical assumptions, certain statistical procedures. Another example is given. A teacher interested in comparing the average percentage mark attained in examination of 5 different subjects and has the mark of the 8 students who all completed each examination. So we have 5 different subjects and we have 8 students. So we want to compute that is there any statistical significant difference between the score obtained by the student. We'll see more and more example. So essentially what ANOVA looks at the way group differ internally versus what differences between them. So it seems a bit complicated, but essentially what here we try to do, here we compare each and every group with others, then we try to do a overall comparison clubbing all groups together. So the process of ANOVA calculations can be explained taking the examples given here, that ANOVA calculates the mean of each group then it calculates the mean of all group combined, that is overall mean. Then it calculates within each group the total deviation. So here we are talking about the deviation, and deviation is what? It's basically the difference which come across the total deviation of each individual score from the group mean, that is within group variation. So here we talk about overall mean and we talk about within group variation. Then we calculate the deviation of the each group. So overall mean, within group, and each group. That's what. So there are three different types of mean computation. One is at the overall level, second is group wise, and then we compute the deviation of the each groups. That's how the deviation is there. For that we'll be using some data set available here, but before that I would like to talk more and more by help of some Excel sheets available with me. Now let's consider we have three different samples: sample A, sample B, and sample C. So in sample A there are 5 values. In sample B as well I have 5 values. In sample C I have 5 values. That is, I am saying that this is the numbers from group A, this is number from group B, and this is number from group C. So in first step what we do, we first compute the mean of each and every group. So this is the mean. Then we try to find out the difference between the mean and the value from each group. So here 2 minus 4 is what the difference is. Here 3 minus 4 is the difference. Here 7 minus 4 is the difference. So here we compute the difference. So this cell computes the difference. Then we square it up. We multiply the difference by the difference itself. So what exactly we are doing? E4 multiply E4. So we are squaring it up. And the moment we square it up for each and every element of group A, we sum it up. So now here total sum is 22 for this group. So for sample A, this is sum of the difference. So we can say this is sum of the difference. Similarly for group B, the value is 10, 8, 5, 7 likewise. So and the mean is 8. We compute the difference. Likewise, we square it up and sum it up. For group C, we perform the similar task. Now, then we add up all differences together. That is 22 plus 18 plus 14. So that is what done here. So we added it up together. And the sum is 54. So this is called sum of the squares within group. So this is called sum of the squares within group. So we need to be careful. We are talking about within group. So there are certain terms which talk about with group. Here we are talking about the within group. This is 54. Now in second step, we put all values together. This is of the first group, this is of the second group, and this is of the third group. We put all values together, then we compute the mean. So if you see, the mean is 8.33, that is written here. And then we perform the same task, value minus mean. That is 2 minus 8.33, the value is given. 3 minus 8.33, this value is given. Likewise, it is going up. So we perform this task for each and every element. Then again we square it up. That is minus 6.33 multiply with the minus 6.33. We did for each and every group. And again we sum it up. So my sum is 257.33. The sum is coming here. So this is called the total sum of the squares. So remember, we are using different terms here. In previous case, we call it sum of squares within group. Here we are saying sum of the squares, total sum of the squares. Now, in third step, exactly how is the process? Again, we put all values together, we compute the average, that is mean. This is my first group, wherein average is this. This is my second group, average is given. This is my third group, average is given. Now, this is called X bar. That is the mean of each and every group. Now, here I am saying it the mean of total group. So I am saying it xt bar, that is mean of the total group. Now, so we need to I use different terms so that we understand that how this calculation is going on. So now I'm computing x bar, that is mean, minus x total bar. So exactly what I'm doing, 4 minus 8.33, that is computed here. Likewise, for the second group, I'm computing 8 minus 8.33, that is 0.33 is given here. For the third group, 13 minus 8.33, that is 4.6 is given. So now here I computed difference between two groups, that is overall mean minus individual mean. Then I am squaring it up. So minus 4.33 multiply with minus 4.33. Likewise, we square it up. Then we are multiplying this square up with the total number of observation. So I know in my first group there are 5 observations. So I am multiplying this with 5. So 18.77 multiplied by 5 is 93.88. Likewise, here 0.11 multiplied by 5 is this, 21 multiplied by 5 is this. So this multiplication with the total number of element is there. Then I am summing it up. So the sum is 203. So here sum is given. So all three values are summed together. Now this is called total sum of squares. This is called sum of the squares between group. I'm sorry. This is called sum of the squares within group. So we know that here this is 257. So how the relation is, we computed three values. One is sum of the squares within group, that is 54. Then we computed sum of the total sum of the squares, that is 257. And now this is sum of the squares between group 203. So we can essentially see that 257, that is my second calculation, is sum of my third calculation and my first calculation. So this is sum of these two values. So now I am moving into more and more calculations. So calculation number 1. Here the value which we computed 203, what exactly we do? We divide this value by the total number of groups minus 1. So in our case there are 3 groups. So we are dividing 203 by 2. Because there are 3 groups, so we need to divide it by number of groups minus 1. So this value is here. In second calculation, whatever sum we obtained from my first calculation, we need to divide it by total number of element minus total number of groups. So there are 15 elements, 5 in each group, and we are dividing it by, and from 15 we subtract 3, there are 3 groups, and the calculated sum of squares in first case is 54. So we're dividing 54 by 12. So this is 4.5 is what my second calculation is. Now here we compute the F ratio. F ratio is essentially the value which comes through calculation 1 divided by the value which comes through calculation 2. So this is called, the F ratio is 22.6. Now this is F value. Now we are going to talk about the degree of freedoms, because essentially we are going to use F table. So for F table calculations we must have degree of freedoms for numerator and denominator. So for numerator, how the degree of freedom is computed, that is total number of groups minus 1, and for the denominators, total number of elements minus number of groups minus 1. So that is what essentially the term we use to divide both the values. So now what exactly we are going to do, we are going to calculate F, we are going to see F value in F table with degree of freedom as 2 and 12. 2 and 12 we calculated here. And here the calculated value at 2 degree of freedoms, 2 and 12 degree of freedoms is 22.6. Let's see into the F table. There is statistical table called F table. In the statistical table, for the F distribution, a value corresponding to 2 and 12 is here, it's given. So for 12 in case of denominator and 2 in case of numerator, the value is 3.89. If we see into the plot, but our calculated value is 22.6. So this is exactly 22.59 something. So this is my calculated value is 22.59, and this is the value which is coming from the table. If I look into the distribution of the table, I can essentially say that no, this value is outside the cutoff value which I am supposed to get by 2 and 12 degree of freedom. So if something comes in outside the cutoff region, that is called a rejection region. That is, here we reject the null hypothesis and we can easily say that no, that there is at least one group in the entire calculation whose mean is significantly different from the others. So that is how the interpretations or how the explanation goes on. So we found that our calculated F value was 22.6 with 2 and 12 degree of freedom, whereas in F distribution table the value for 2 and 12 degree of freedom is 3.89. So we essentially say that no, we are going to reject the null hypothesis, that is at least one of the group from the data is significantly different from the others. So that's what the objective is. Now we are going to look into R, that how exactly this calculation happens.
Just a quick info, guys. Test your knowledge of R programming by answering this question. R functionality is divided into a number of dash: A. Packages, B. Functions, C. Domains. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
So here I have the same data wherein I have three groups A, B and C, and essentially all values are same: 237, 26, 237, 26. So I am using the same data. So we have three groups, group A, group B and C. The last element of group C is 15, that is 15. So the last element of group C is 15. So this is what I'm going to use the same data, and we'll try to figure out that the computation which we did in Excel, is it exactly the same which is coming into the R. So now I am running summary. Summary help us to get information about each and every variable. So it is saying that there are two variables. One is group and second is score. So in group there are three elements A, B and C, and there are three members, that is three groups are there, and inside each and every group there are five elements, that is five members. We are going to use structure function which give us information about the type of variable. So essentially for ANOVA is run between a categorical and a continuous variable. So categorical is here group A, B and C. So categorical variable in R is called factor. So whenever there is categorical variable, R reads it as a factor. So it is sometimes it is not as default, so we need to make it into the factor. But essentially for ANOVA, your variable must be factor. One variable must be factor and another variable must be continuous. Continuous is a number wherein we can perform certain mathematical calculations like 2, 3, 5, 7, the value comes in. We are using the name function to find out the name of the variables. So it is saying that the name of the variables are groups and score. Now we are going to run ANOVA. So for ANOVA, the function is AOV, and inside that we use the continuous variable, that is the score. With a tilde sign we write group. So we are saying that my score is dependent variable and group is independent variable. So remember, dependent comes first and independent comes second. Why I'm saying dependent and independent, this will be better explained in regression and logistic regression section. But here essentially at this moment I would say that your continuous comes first and then categorical comes second. So that will help us to exactly find the positioning of the continuous and the categorical variable. Then we are saying data is equal to CALC. The CALC data which we created, that is the object which is in my R environment, I am using that CALC. So we need to understand the structure of ANOVA. So here we are creating an object called example, and this object is created by help of a function called AOV, that is ANOVA. Inside that function we are supplying two different arguments. One argument is the variable association, that is which one is continuous variable, which one is categorical variable, and the second argument is the data set, that on which data we are going to use it. So now I run example. So an example object is created in my environment. Now I want to see in detail about the output, the object which I created. For that there is function called summary. So the moment I run summary, I get the entire information about ANOVA. So it is saying that there are two groups and there are 12 elements. So how these elements are? This 12, we saw that how this 12 is calculated. That is total number of elements minus total number of groups minus 1. And we essentially saw the sum of the squares for group is 203. Sum of the squares for the group is 203. Then for the residuals, that is for the individual, it was 54. So for individual it was 54. Then we computed some F value, 22.59. That is 22.59. This is given into. So now here we are getting that what all we computed, that is coming exactly the same in our environment. So why I explain Excel spreadsheet? Reason being, it helps us to understand the different steps been computed. So here in R, we get simply the output. But how is the background, how that computation happens into the background, that is essential to know. So that's the reason that we perform a manual computation as well as we perform a computation using the R functions. Now, here we are getting three asterisk. So three stars is given. It is saying that the groups are, at least one group is significantly different from other group. So remember, null hypothesis for ANOVA is there is no statistical significant difference between the groups. That is, the difference in the mean of each group is almost zero. So there is no difference in their mean, or we can say that all means have the similar kind of distribution, wherein the alternative hypothesis says that no, at least one mean is different from others. So here we are rejecting the null hypothesis and we are saying that at least one mean is different from others. So now the question is, which mean is different from the others? We know that there are three groups, A, B and C. Statistical output is saying that at least one group is different from the others. Now the objective is to know that which group is different from the others. For that we have another example. So for that we are going to use some data which is available on some website, and we'll extract those data, and by help of that data we'll run the same ANOVA function. So here there is a data set available on the website. So the location of the path is given, that where exactly this is available. So we are saying that http personalityproject.r.org r datasets. Likewise, information is given. So from here we are extracting the information and creating an object called data.ex1 by help of a function called read.table. So read.table help us to read these values, and we are specifying the object which is created here. So there are two ways possible. Either we write the entire value which is written inside the balance quotation mark, we simply copy this entire content from here to here and put it here, or we write like this. So first we create an object which is equivalent to these values, and then put that object inside the read.table function, and essentially we say header is equal to true. Header is equal to true means we want to read the value with the variable names. So that's what header is equal to true. So in a spreadsheet, suppose there are, usually in spreadsheet the first row is about the variable name. So in that case we need to say header is equal to true. There is some alternate source of data wherein we normally do not get with the headers. So in that case we need not to read data with the headers, but here the essential requirement is to read the data with headers. So that's the reason we are saying header is equal to true. And again we are using the same AOV, that is ANOVA function. So inside that data, the data which we extracted, there is a continuous variable called alertness, and there is a categorical variable called doses. On that we are running ANOVA. So here we are doing the same stuff. We are creating an object using this HTTP option. Then by help of that object we are creating another object called data.exe. So that object is created. If we want to see the structure of the dataset which we created, that is data.exe1, so we can see the structure. So structure says that there are two variables. One is doses, that is factor, and second is alertness, that is integer, that is continuous. if you want to say in detail, so this is the variable. This is exactly the way we saw in previous case. So there are different groups for the doses, and there are different alertness. So this is one is the categorical variable, and second is the continuous variable. Now we are running the ANOVA function, that is AOV, considering alertness as it's the continuous and doses as the categorical. So an object called AOV.ex1 is computed. Now we want to see the summary, the way we saw the previous summary, wherein the entire residual, some of the squares, f value, everything comes in. So the moment I run it, it is saying that the probability is 0.0298, and here there is double star. It is saying that we are going to reject the null hypothesis, that is at least one group in the given data is different from the others. So that's what this asterisk, that is star mark, indicates. Even by looking at the probability value, if this value is less than 0.05, so in that case at 95% confidence or at 5% significance, we reject the null hypothesis. So essentially we are doing the same stuff here. We are saying that no, there is at least one mean into the data, that is one group in the data which is statistically different from the others. So that's what the interpretation is. So here we can, by looking at the output, we can say that there are three groups, and essentially this value is 15 is what? This is total number of observations minus total number of groups minus 1, and this is sum of the squares within group, total group, and essentially this is how f value is computed, the way we saw into the previous case. Now the question is, here in the output we got that at least one group is different from the others, but essentially which group is different from the others? For that there is another test called 2k test, 2k. So we run 2k test on AOV.ex1 to get the difference, that which one is exactly different from others. So we are running 2k test here. So now the best part with this test is it prints a group wise comparisons. So it is saying that when we compare group B and group A, we are getting that probability value is 0.2768. That is what, as I mentioned earlier, that if this p value is less than 0.05, so in that case we reject null hypothesis at 95% confidence or at 5% significant, and say that both groups are statistically different. But in our case this value is greater than 0.05, so we cannot reject null hypothesis, and we say that no, group B and group A both have the similar kind of distribution, that is we cannot reject null hypothesis in case of group B and group A. Now, so this is called group wise comparisons. In second group comparison, that is C and A, the value is less than 0.05. So here it says that no, group A and C are statistically significant from each other at 95% confidence or at 5% significance. So group C and A are statistically different from others. Now next comparison between group C and B. Again we are getting this value is less than 0.05. So we can say that group C and B are statistically different from each others. That is, we reject the null hypothesis in case of group C and B, and we can say that group C and B are statistically different from each others. So here one thing is very clear, that group A and B are similar, whereas the group C is different from A and B. So we can say that group C is statistically different from group B and group A. Let's see it visually. So that's what we run. So when we run this code, we got the summary output, and on top of that I run QK HSD test to find out the group which is significantly different from others. So in previous case, when we run summary, we got some information about doses, their mean value, their F value, is it significant or not. So we saw the same output coming in our previous case. We are going to inspect manually that how is the mean behavior of each and every group. So now, considering this AOV.ex1, what exactly we're trying to do here? This is my grand mean, that is overall mean. This is mean of group A, this is mean of group B, and this is mean of group C. So we have three different groups, and here we come to know about the mean of each and every group. Now second option is to get the similar, to get some visual information about the groups. So here we are running the box plot. So box plot for all three groups. So this is for group A, this is for group B, and this is for group C. So here we can say that for group A, the mean is lying, this thick black line is the mean value. So even visually we can see that group C is different from group A and group B. That is what coming in my output as well. So this is what we run. We run the mean of the all three groups, and the moment we run the box plot looks like this, the way we saw. So even box plot is a good way to visually inspect the behavior of the data, the behavior of means, and how values are coming across. Now we are going to talk about two-way analysis of variance, wherein in previous case we had only we had two variables. One was continuous and second was categorical. In this case, we are going to consider multiple variables together. That is, essentially there is one group, and for that group there are multiple variables. So it's not, in previous case it was group and doses. Here we are going to consider, apart from doses, there is one more variable. So we are going to see the impact of different variables on the groups. So is, like, suppose I'm giving one example. There is one publication which publish publish books on math and physics. There is another publication which publish book on math and physics as well. One school use one publications, another school use another publications, and the student of both the schools appear for state level or the national level examination, and now we have a score of the students. We are going to check that is there any kind of statistical significant difference exist between both publishers group. If we assume that book is the only important factors which contributes into the final score which we get into the examination. Fine. So here assumption is the book is the only factor which affects the score which we get into the examination. Right. So in books we have, so book is one variable, publisher is one variable, and for publisher there is math score, there is physics score. So for publisher 1 there is math score, physics score. Publisher 2 there is math score, physics score. Now we are going to compare publisher 1 and publisher 2 by help of math score and physics score. So in previous case it was only one group and one continuous variable. In this case we have multiple groups and multiple continuous variable. So again we are using some dataset available on the website. So we have gender information, male and female, and we have doses. So different kind of dose was given. So there are two types of dose, A and B, and there are two types of gender, male and female. So for male, dose A and B both was tested. For female, dose A and B both is tested, and for that we have their result. This result, so we are going to compare that how is the impact of doses on different genders when we consider alertness as a as a continuous variable. So again we run the same function, that is AOV. Alertness is what? It's my continuous variable, and we are using gender and dose. So remember, whenever we have more than two variables, we write like this. So the moment we write like this, we get individual impact as well as the combined impact. Combined impact is what? Gender and doses both together. So we'll get probability value for gender, we'll get probability value for the doses, and at the overall level we get the probability value for gender and doses both together. Let's see that. This is summary of ANOVA, which says that for gender this is the probability. So if I consider gender as standalone, I can say that no, it is not statistically, gender is the impact of gender on alertness is not significantly different. So I cannot say, because this value is greater than 0.05. So we fail to reject null hypothesis. In case of doses, the value is 0.666. Again, this is more than 0.05. So here we fail to reject the null hypothesis. Now, this is called interaction impact. So here, this is interaction of gender and doses. So if both comes together, this is also not significant. So here we can say that no. The output is saying that no, none of the variable is significantly different from the others. So this is how our observation looks like. This is how the data is. When we run the summary, when we run the ANOVA and on the summary, we saw like this, values were coming with certain degree of freedoms and doses. So that all we saw, and I explained that what is the meaning of those all values. Now we are going to print the mean of each and every group, that how exactly mean looks like. It says that the mean for the grand mean is 14.06. The mean for gender, female, is 16.25, and for male this is 11.88. In terms of doses, if you talk about dose A, the mean is 13.50, and for B it is 14.62. Now, if we try to find out the mean of doses on different combinations, like for female and dosage type is A, so mean is this. For female, dosage type B is this. For male, dosage type A is this, and for female, dosage type B is 12.50. So likewise, this is a kind of cross tabulation wherein we have entire information about each and every cell or each and every component. Now let's plot the box plot. The moment we draw the box plot, we get those entire information. It is saying that this is the mean of A and F, that is type doses A for the female, doses B for the female, dose A for the male, and dose B for the male. So this is how the box plot looks like. So even if I compare the mean of, let's compare with the A and B with female. So these are very close to each others. That's the reason that there is no statistically significant difference was coming across. Even for A and male and B and for male, though the dispersion for the, you can say the range for B and male is quite high, still their mean value are very close to each other. So that's what we are getting here.
Just a quick info, guys. Test your knowledge of R programming by answering this question. Which of the following is used for statistical analysis in R language? A. Studio, B. RStudio, C. Heck. Comment down your answer in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session. Just a quick info, guys. Intellipaat provides online data science master's program in partnership with IBM. The course link of which is given in the description below. Now let's continue with the session.
You must have heard of data as one of the important and essential resource in 21st century for all the businesses. So the ability to analyze and act on data is increasingly important to business in 21st century, and also keep up with the market, to compete in the market and to adapt the quickly changing demands from the customers. The businesses should be data centric, and the managers of these organizations may need to understand high volumes of data before they make the necessary decisions for the businesses. Also, researchers from the University of Texas found that companies can generate big financial returns by making just small improvements in the data or utilizing more data, improving the data quality, usability, and intelligence, remote accessibility. So, it can shoot up the sales of the organization to 14.4% if they increases the usability of its data by 10%. So this shows how important data is. So the importance of data processing can increase the productivity and profits, helps in better decision making, helps in creating more accurate and reliable business strategies to boost revenues. We will be talking about data mining a lot. Using R, we will be implementing a case study. So without wasting any time, let's move on to the why do we need data mining. So I'll give you a real life use case or scenario of food ordering app. So the owner of a online food ordering company realizes that he's facing revenue losses. So he encounters all the factors, he analyzes all the factors on his own, that the application is fine, the customer service is fine, the notification strategy for getting sales is fine, the marketing strategy is fine, the delivery of the food is fine. So where they are lagging in the business. So here comes a data analyst with a lot of data mining techniques to analyze the organizations or the company's data. So he analyzes all the factors and data of customer service, the application, the marketing strategies, the delivery of the food, and the notification system, the cost of the food. So also he analyzes the market and the competitors in the market, their prices, their offers, and comes to a conclusion that the company is not giving good offers to their customers, and that is the reason that all the customers are going to their competitors and using their application. So the solution to this problem is simple: give the customers a good offer and they will be yours, and you can get a good revenue generation and you can get a good growth by giving them the offers. So this is the visualization and analysis of the data, and the finding of the solution to a problem. So you can understand and you can see from this that how much important is data in real life. Now let's move on to the next part, that is what is actually data mining. So going to the definition, so data mining is simply a process used to turn raw data into useful information. So by using various softwares, the companies can look for patterns in the large batches of data. Then businesses, they can also learn more about their customers to develop more effective marketing strategies, increase their sales and decrease the cost, optimize their products cost so that their customers are willing to buy from them. So data mining is basically the process of extraction of data for business, then collect specific business factors to evaluate the data, such as in this use case that we saw of food ordering app. So the various factors can be the notification system, the marketing strategies, the delivery of the product or the food, and the customer service. So these can be the specific factors for evaluating the business model. Then find useful information from the data, then analyze the data to draw some useful insights and make some decisions to optimize the business strategies. Now let's move on to the next part, that is data mining processes. So these are the processes involved in data mining. That it starts from data extraction, then data pre-processing, data mining, extracting patterns and visualizing data. So we'll start by data extraction. So data extraction is basically extraction of the data from multiple sources in the form of videos, audios, text, image, and it is stored to the databases of the organization. So in the real life, the data is in the form of unstructured. So it is not always structured. It can be found in the form of images, videos, audios, or maybe text. So we need to make it structured for further pre-processing. So the next part is, or the next process is data pre-processing. It consists of cleaning the data, removing the redundancies, and after that removing the missing data, then manipulating the data to understand its variable so that we can understand the relationship and the association between the variables and the data points in the entire data set, and finally transforming data into a readable and understandable format so that machines can understand the data very well and we can work on it so that we can make a predictive model out of it. Now the next one is data mining. So data mining consists of various techniques such as classification, regression, clustering, association rule mining. So the data in various formats, it can be in exe format, CSV format, doc, and various other formats. So it can be, the algorithms are created using the mining techniques such as classification, regression, clustering, and association rule mining. Then the data in the various formats such as you can see in the screen, that is .exe, .csv, doc, xlsx, xls. These data are fed to the data mining techniques or the data mining algorithms to classify the data, make clusters of the data, and apply association rule mining for establishing a relationship or knowing the association between the data. So these data mining algorithms or techniques are used to build a model which, when given a new data set, can predict some outcome. So it is a type of predictive modeling or making a predictive analysis out of the data set. Now the next is extracting patterns. So when the data is fed into the algorithms, it tries to find the relation between the data, tries to extract the patterns from the data so that a useful information can be fetched out of the data that helps businesses to optimize their business strategies, boost revenues, and they can know the glitches in their business. So this is the use of extracting patterns from the data. Now finally, visualizing the data using beautiful graphs and interactive charts so that we can get statistical overview, a statistical number on what we have visualized and analyzed the data. Now the next one is the methods of data mining. So we'll be going to understand few of the methods. So these are classification, association rule mining, outlier detection, clustering, and regression. So starting off with classification. So talking about the field of data management, the data classification is a part of information lifecycle management process, and it can be defined as a tool for categorization of data, and it can help organizations to effectively segment their potential customers. So it is the process of sorting and categorizing the data into various types, forms, or any other distinct class. And the data classification enables the separation and classification of data according to the dataset requirements for various businesses, or it can be for personal objectives also. So it is mainly a data management process. So here is an example. A classification algorithm is first fed with the data of cars and bikes, and whenever a new data arrives, such as you can see, if the data of car, if the picture of car is given to the algorithm, then it classifies it as a car, and if the data of bikes or the images of bikes is given to the algorithm, it classifies it as bike. So this is the sole purpose of classification. So data is managed or data is segmented according to various classes, and so whenever a new data set arrives, the algorithm classifies it correctly. After that comes association rule mining. So consider an example that a customer goes to an e-commerce website and looks for a guitar, and he buys a guitar. Then after few months or few days, he also buys a piano, and then he buys a mouth organ. So the recommendation system of the e-commerce website records this sequence of orders and associate it with other orders. So suppose if another customers come and they order a piano or a mouth organ, then the recommendation system will also recommend the products as guitar or mouth organ and all of the musical instruments that are associated with it, so that their sales improves. So this helps these e-commerce websites, and this recommendation engine helps them to increase their revenue generation and to shoot up their sales. Then comes outlier detection. So outlier is the data, or over here you can see a graph that here is a set of regular points and one data point is lying outside the set of common slot of the points. So outlier is basically the data which is not lying in the common slot, and here you can see the graph for number of pens and cost. So from this graph you can see that the cost of 20 pens is close to around 1000 or 500 maybe. So this is the cost of the 20 pens. That means the cost of one pen is either 25 or 50. Now for outlier you can see the number of pens are 30 and the cost is 6000. So 30 pen cost 6000. So the cost of one pen is 300, and it is a large cost as per the common slot of the prices of the pen. So this takes the average cost of the pen a little bit higher from the average cost of the common slot of prices. So this is a redundancy in the output of the data, and it affects the predictive modeling or predictive analytics. So we have to perform outlier detection so that we can use the data effectively to make a predictive model. Now the next one is clustering. So clustering is basically making a group of cluster or segmenting a group of customers according to their similarity. So a common real life example that we can discuss is of Netflix. So what Netflix does is it creates a cluster of similar type of content, and the group of people who are watching type of content, and they make a cluster out of it. They create different groups of people that helps them to recommend the type of content they watch. So this is the application of clustering. So in data mining, this technique helps in analysis of various types of customers. Now the last one is regression. So regression is mainly the evaluation or the comparison of change of one value with respect to another. So here is a graph between X and Y that measures, or that is showing the data points lying over there, and a linear, you can see this red line that shows a linear relationship between the two. So basically the use of regression is to evaluate or measure the change in one variable with respect to another, to evaluate or to establish a relationship between them. So this is the purpose of regression. So we have understood the methods of data mining. Now we'll move on to the next section.
So we'll start off by reading data into R console. R provides different functions to read different data formats. So if you want to read a text file, you can use the read.table function. For comma separated files, you can use read.csv function. For reading JSON files, you have the from JSON function. And similarly, if you want to read data from HTML tables, R provides a function called read HTML table. So you can read all formats of data into R. And since our customer churn data is of .csv type, we'll be using the read.csv function. So let's head on to RStudio. So this is RStudio, guys. So I'll use the read.csv function to read the customer churn data set. All right, I'll put in the double quotes. Now, this is the data set, guys. This is the .csv file. I'll click on properties and I'll copy the path from over here. And I'll paste the path. Now, you need to keep in mind that this is actually a / when you're giving the path, right? And after giving the path, I'll give the name of the file, which will be customerchurn.csv. And I will store this in a new object, and I'll name the object to be customer churn as well, right? So this, what you see, is actually an assignment operator. So I'm reading this path and I'm saving this file into an object called as customer churn. Right. Now let me have a glance at this data set. So what I'll do is I'll use the view function. So I'll type view and I'll type out customer churn. So this is our customer churn data set, guys. Now let me use the class function to have a look at the type of this object. So I'll use class and I'll give the name of the object, which is customer churn. So what we see is this object is of type data frame. That is, this is actually a data frame. Now, if you're coming from the SQL background, you can say that a data frame is actually sort of a table. So over here, all of these columns are of the same data type, and each row represents a record of this data frame. Right, so let's say if I select this column tenure, then this will be of one particular data type. So let me go ahead and see what is the type of this. So I'll use class and I'll type customer churn $tenure. So I see that this is of integer type. That is, this tenure column is of integer type. Now, another thing that you need to keep in mind is all of these columns are actually vectors and factors. That is, a vector is a set of homogeneous entities and a factor represents categorical values. So now let me type out class, and what I'll do is I'll type out customer churn $gender. So I get that the class of this object is factor. Now what we see over here is this just has two categorical values, female and male. So whenever we have just categorical values, then most probably the class of that column is of factor, right? So we've understood what a data frame is, and we've also had a look at vectors and factors. Right, now we'll go ahead and understand how can we access individual columns from this data frame or access individual elements from this data frame. Now, let's say I would want to access the column device protection from this entire data frame. So how can I do that? But it's actually simple. So what I'll do is I'll start off by giving the name of the data frame. It should be customer churn. Then I'll use the dollar symbol and I automatically get a list of all of the columns. And since I need the device protection, I will type DEVI. I'll select this and I'll store this in a new object, and I'll name this new object as C underscore device protection. Right, so let me have a glance at this actually. So I'll type view of C underscore device protection. So what I've basically done is from this entire data set, I've just selected this column and stored it into a new object and named that object as C device protection, right? So similarly, if I want to select the payment method column, I can do the same thing. So what I'll do is I'll type out the name of the data frame. I'll use the dollar symbol and I'll type the name of the column, which will be payment method over here. And I'll store this in, let's say, C payment. Now let me have a glance at this. So I'll type view C underscore payment. Right. So I have separated this column from this entire data set. Right. So this is one way by which we can select individual columns. We can also use the second method. So the second method is also simple. So what we'll do is we'll start off by giving the name of the data set. Then I'll give the square braces. Now inside the square braces, the values which are on the left side of the comma represent all of the rows, and the values which are on the right side of the comma represent all of the columns. Now let's say I would want to select this gender column. So what I'll do is I'll just give the numbering of the column, that is at which position the column is present. So I'll type out 2 over here and I'll save this in, let's say, C underscore gender. Now let me have a look at this. So I'll type view C underscore gender. Right. So I have used the square braces to select the second column from this customer churn dataset. Now, similarly, if I want to select the first column, I can do the same thing. So what I'll do is I'll just put 1 over here and I'll name this object as C underscore ID. Right. So let's have a look at this view of C underscore ID. This is the column which gives me the customer IDs. Right. Now, we can also select multiple columns in the same way. So let's say I would want to select the second, sixth, and seventh column from the customer churn dataset. So what I'll do is I'll put a comma over here. I'll use the combine function, right? And I'll give all of the columns that I want to select. So I need the second column, the sixth column, and the seventh column, right? And I'll store this in C underscore 267. So let's see what is the result now. Again, I'll type view of C underscore 2, 6, and 7. Right, so I have successfully selected second column, sixth column, and seventh column. So let's actually verify. So yes, this is the second column, 3, 4, 5, 6. So 6 is tenure, 7 is phone service. Right, so we have sixth and the seventh column. So this is how we can separate out some specific columns from the data set. Let's say I would want these two columns over here. So I can actually type out the names of those columns. So what I'll do is I'll type monthly charges and I'll save this in C month. So let me have a look at this view of C month. Right, so I have successfully selected out the monthly charges column. Now I can also select a set of continuous columns. So let's go and do that. Now let's say I would want to select all of the columns from senior citizen to multiple lines. That is from column number 3 to 4, 5, 6, 7, and 8. So I would want all of the columns from column number 3 to column number 8. So let's go ahead and do that now. So for that, what I'll do is I'll type the name of the data set. I'll put a comma over here. I'll put 3, and from 3 I'll use colon symbol. I'll just put out 8 over here. So this will give me all of the columns starting from the third column to the eighth column. So let's say I will save this in C underscore 38. So let me have a look at this now. View of C underscore 38. Right. So I have successfully selected out all of the columns from third to eighth. So the third column is senior citizen and the eighth column is multiple lines. Right now, so this is how we can filter out some specific columns. So if we wanted to filter out some specific rows, so let's go ahead and understand how can we do that. So now, as I've already stated, if you would want to filter out rows, we would want to give it on the left side of the comma. And if you would want to filter out some specific columns, you would want to give it on the right side of the comma. So let's go ahead and filter out some rows. So now, let's say I would want the second row of this data set. So all I need to do is type in 2 over here, and this will give me the second row. Right, so let me store it in C underscore, and let me have a look at this. View of C underscore 2. Right, so this is the second record whose customer ID is 5575. So let me just verify. Right, so this is the second record over here, and this is the same record that we have successfully filtered out. Similarly, let's say if I would want the record or the row number 100. So I'll just type out 100 over here, and let me store this in C underscore 100. Let me have a look at the result. View of C underscore 100. Alright, so this is the record which is placed at the 100th row, whose customer ID is this. Now we'll go ahead and understand how can we filter out multiple rows from this. So let's say I would want the first, fifth, and the 10th row. So I'll use the combine function over here, and I'll give all of the row numbers. So I need the first row, fifth row, and the 10th row. And I'll store this in, let's say, 1 underscore 5 underscore 10. Alright, so let me have a glance at this. I'll type C underscore 1 underscore and this. Right. So I have successfully filtered out the first, fifth, and the 10th row. So see that the gender of the customers at first and fifth columns is female, and the gender at the 10th column is male. Now what we'll do is we'll filter out a sequence of rows. So let's say I would want all the rows from let's say row number 100 to row number 200. So what I'll do is I'll type 100 to 200, and I'll store this in C 100 200. So let me have a glance at this. I'll type view of C underscore 100 200. Right, so this gives me 101 entries.
Just a quick info, guys. Test your knowledge of R programming by answering this question. R functionality is divided into a number of dash A. Packages, B. Functions, C. Domains. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Starting from row number 100 to row number 200. Right, similarly, let's say if I would want all of the rows from 10,000. So similarly, let's say if I would want all of the rows from 5,000 to 7,000, we can also do that. I'll just simply put over here 5,000, and then I'll type in 7,000 over here. Right, so let me just type out 5,000, 7,000 over here. Let me have a glance at this. So I'll type view of C underscore 5,000, 7,000. Right, so there are 2001 entries starting from row number 5,000 to row number 7,000. Right. Now what we'll do is we'll give out both the row numbers and the column numbers. That is, we'll filter out some specific rows and some specific columns. So let's go ahead and do that. Now let's say I would want the row numbers from 50 to 60, and I would want just the second and the third column. So let's go ahead and do that. So the row numbers from 50 to 60 and just the second and third column. So I'll use C2, 3. And let's just store in C random 1. Let me have a glance at this view of C underscore random 1. Right, so this gives me all of the records from row number 50 to row number 60, and I've just selected these two columns, gender and senior citizen. Now let me actually go ahead and complicate this a bit. So let's say I would want row numbers from 100 to 200 and also from 1000 to 2000, and I would want the columns 2, 3, 5 and 7. So let's go ahead and do that now. Right, so I'll use C over here. First part would be where I need row numbers 100 to 200, and I would also need row numbers from 1000 to 2000. Right, so this is my first part where I'm filtering out all of the rows, and I would need column numbers 2, 3, 5 and 7. So let me go ahead and put down all of these column numbers, and let me store this in C underscore random 2. So let me have a look at this view of C underscore random 2. Alright, so I have 1102 entries in total, where I have rows from 100 to 200, and as you see over here, just after row number 200, the row number gets to 1000 because I have filtered out all of the rows from 100 to 200, and then it starts from 1000 to 2000, and I've selected column number 2, 3, 5 and 7. Right. So this was an intro to our data frames, vectors and factors, and how can we access individual elements from the data frame.
Just a quick info, guys. Test your knowledge of R programming by answering this question. R functionality is divided into a number of dash A. Packages, B. Functions, C. Domains. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
We're going to look at the various types of inbuilt function in R and implement them on the customer churn dataset. So these are some of the inbuilt functions. So let's go to RStudio and work with them. So we'll head back to RStudio. Let me just have a glance at the dataset first. So I'll type out view of customer churn. Right, so this is a dataset. So we'll start off by understanding the structure of this dataset. So for that, I'll be using the structure function str, and I'll give in the name of the dataset, which is customer churn. Right, so this function gives me the entire structure of this dataset. So this basically tells me that I'm working with a dataset where there are 7043 observations of 21 variables, or in other words, there are 7043 rows and 21 columns, and these are all of the columns over here. So we have customer ID, gender, senior citizen, online backup, streaming movies, churn, and so on. Right, so now followed by the name of the column, we also have the data type or the class of the column. Right, so over here we see that customer ID is of type factor, gender again is of type factor, senior citizen is of integer, and these are the values. So the values are either zeros and ones. Right, and over here multiple lines is of type factor with 3 levels. So these are the 3 factor levels over here. So it could be either no, yes, or no phone service. And then similarly we have the internet service with the 3 factor levels. So it could either be DSL, fiber optic, or no. Right, again, so for contract we have 3 factor levels, which could be either month to month or 1 year or 2 years. Right, so we have found out all of this with the help of the structure function. All right, now we'll go ahead and implement the second inbuilt function. So we'll be using the head function for this. Right, so head function basically gives us the top 6 records of the dataset. Right, so I will just go ahead and give the name of the dataset over here, head of customer churn. Right, so this has given me the first 6 records. So we have the first 6 records for all of the columns over here. All right, now if I want to have a look at the first 10 records, all I'd have to do is give a number over here. So now I have the first 10 records of the dataset. So similarly, if I just want to have a look at the first 2 records, I'll just give the number 2 over here. Right, so I can have a look at the first 2 records of the dataset. So similar to head, we have another function called tail. So tail function gives the last 6 records of the dataset. So I'll go ahead and give our customer churn dataset over here. So you can see the row numbers over here. So they start from 7038 and they end at 7043. So basically this tail function gives us the last 6 records of the dataset. Similarly, if I just want the last one record of this dataset, I'll just give the number 1. Right, so this is our last record. So row number 7043. Similarly, if we want the last 10 records, I'll put 10 over here. Right, so it starts from 7034 to 7043. So these are the last 10 records of the dataset. Right, so we are done with head, we're done with tail. Now we'll use n row and n call to find out the number of rows and number of columns. Right, so I'll type n row and I'll give in the name of the dataset. Right, so with this we find out that there are 7043 rows in this column. Similarly, I will type n call and I'll give the name of the dataset customer churn. Now we find out that there are 21 columns in this dataset. Right, so now we have some numerical columns in our dataset. So we have monthly charges and total charges. Now what if I would want to find out the mean values or the maximum values of monthly charges? So let's go ahead and do that. So let's say I would want to find out the mean of monthly charges. So all I need to do is type out mean over here and then give the column over here. So I'll type customer churn dollar. I'll select the column which is monthly charges. Right. So the mean of monthly charges for all of the customers is around $64. Similarly, if I'd want to find out the minimum of monthly charges, I'll type out min. I'll give the name of the dataset and then I'll type out monthly charges again over here. Right, so the minimum monthly charges are $18. Similarly, if I want to find out the maximum of monthly charges, I'll type out max. I'll give the name of the dataset, which is customer churn, followed by the name of the column, which is monthly charges. Right, so the maximum is $118. So similarly, what I'll do is I'll find out the mean, max, and min for the total charges as well. Now we also have the range function, which automatically gives us the minimum and maximum values. So I'll give range over here. I'll type the name of the dataset, which is customer churn, and I'll select the column which is monthly charges. Right, so range gives me the range of all of the values. So the minimum value is 18 and the maximum value is 118. Now, so let's say there's a lucky draw going on and we are selecting 5 customers randomly to give a discount. So we can use a sample function for that. So with the help of sample function, I'll be selecting some 5 random customer IDs. So let me go ahead and do that. I'll type sample and what I'll do is I'll select the customer ID column and I'll give the number 5. That is, from the entire data set, we are selecting 5 random customer IDs. Right, so these values which we see over here, so these are the customer IDs. So this is the first, second, third, fourth, and fifth. So this has randomly given us 5 customer IDs from around 7043 entries. So again, let's say if I would want around 20 random customer IDs, I'll give the number to be 20 over here. Right, so these are all the 20 customer IDs. Now next, if you would want to find out the distribution of some categorical variables, then we can use the table function. So over here we see that we have a lot of factors over here. So gender is a factor column, partner is a factor column, internet service is a factor column. So most of these are actually factor columns. So now if we have a lot of factor columns, we can use a table function to find out the distribution. So now let's say for this gender column, I would want to find out the number of female customers and also the number of male customers. So all I'd have to do is use a table function for this. So I'll type out table, I'll give the name of the data set, and I'll just select the column over here, which is gender. Right. So this basically tells me that there are around 3,488 female customers and 3,555 male customers. Right. So similarly, if I want to find out the distribution for internet service, I'll use the table function again. I'll give the name of the data set, and then I'll give the column name, which is internet service. Right. So around 2,421 customers use DSL, and 3,096 customers use fiber optic, and there are around 1,526 customers who don't use any sort of internet service. Right. Now, so let's say we would want to find out the contract of the customers. I'll again use a table function, and I'll type the name of the data set followed by the column.
Just a quick info, guys. Test your knowledge of R programming by answering this question. Which of the following is used for statistical analysis in R language? A. Studio, B. RStudio, C. Heck. Comment down your answer in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
Right. So there are 3,875 customers who have month-to-month contract, 1,473 customers who have a contract on yearly basis, 1,695 customers who have the contract on a 2-year basis. Right. So next, finally, we'll use a table function on the payment method column. Again, I'll type a table over here. Right, I'll give the name of the dataset, which is customer churn, and I'll select the payment method column. Right, so around 1,544 customers do it via bank transfer, 1,522 customers paid by credit card, and these are the rest of the customers who pay via electronic check and mail check. We're going to work with flow control statements and user-defined functions. Now, these flow control statements basically help us to control the flow of execution. So in general, the statements are executed from top to bottom. But with the help of flow control statements, we can manipulate the order of execution. So these are some of the flow control statements over here. If else, and switch are something known as selector statements. Then we have repeat, for, and while, which are looping statements. We also have some jump statements like continue and break. So let's have a closer look at selector statements. As the name suggests, the selector statements help us to select or manipulate data on the basis of a condition, such as if it rains, we'll not play football, or if you're sick, you'll not eat ice cream. So we'll just go ahead and start working with the selector statements. Right, so I'll start off and have a quick glance at our customer churn dataset. I will type view of customer churn, and we have our dataset right in front of us. Now I will start with the if condition, and I will check if this cell over here, the value in this cell is female, and if the test condition comes out to be true, then I'll change this value to be male. So let me go ahead and do that. Right, so I will type if, I will give the name of the dataset, which is customer churn, and the column is gender, and the row number is obviously 1. So from this dataset, I am checking if the value in this column is female. So if this is equal to female, then I will give some action over here. So what I'll do is I'll change that value to be male. I'll give the name of the dataset. I will select the column, and in this column, right, so this is cell number 1. And over here, I'll change the value from female to male. Right, so initially we had female over here. Now let me copy and paste it over here. Now let me have a glance at the customer dataset again. Right, so we have changed this value from female to male with the help of the if condition. Right, similarly we'll use the if clause again to check if the tenure over here, so we'll take this cell value over here. So if the tenure is, let's say, greater than 62 months, then what I'll do is I'll give this customer a discount of 10%, right? So over here I see the monthly charges, and over here we have the customer. So this is customer who is present at row number 10, and I will give this guy a discount of 10% for his monthly charges. Right, so let me go ahead and create another if clause over here. So I will type if customer churn dollar tenure is greater than 50, and this cell number over here is 10. Now this is very important, right? So this is cell number 10. If that value is greater than 50, then what I'll do is I will give a corresponding discount in monthly charges. Cell number is 10. So customer churn dollar monthly charges, cell number 10, and I will give this guy a discount of 10%. And that is why I am multiplying this value with 0.9 over here. So you see, we have taken out this cell value and I'm multiplying that value with 0.9, and that is how this guy will get a discount of 10%, and I am storing back the result into the same cell. Let me copy it and paste it over here. So let's just have a quick glance. So the initial value is 56. Now after modification, let's have a look at the monthly charges. Right. So initially it was 56. Then after using the if clause, we have changed his monthly charges to 50 by giving him a discount of 10%. Right. So this was if. Now we'll go ahead and also implement the if else clause. So we'll use the churn column for that, and we'll be using this cell. So let's say if we'll just check if the value over here is no, or in other words, it basically means that the customer will not churn out, or the customer will be using the same network, then we'll just print that thank you for using our network. And if this is yes, then we will print please give us a feedback on how we can improve our network. So let's go ahead and do that. Right. So if customer churn dollar churn, and this is row number 1, is double equal to yes, and if this comes out to be true, I just need to print please give us a feedback on how we can improve our network. Right. Else I will print thank you for using our network.
Just a quick info, guys. Intellipaat provides online data science master's program in partnership with IBM. The course link of which is given in the description below. Now let's continue with the session.
Let me paste it over here and let me see what will be the result. So we get thank you for using our network because this customer does not churn out. Right, so we are done with if, we are done with if else. Now we'll work with the third selector statement, which is switch. So with the help of switch, I will give this guy a discount on monthly charges with respect to the internet service. Let's say I will take this customer and I will say if this guy uses internet service of DSL, then I'll be giving him a discount of 10%. And if he uses internet service of fiber optic, then I'll be giving him a discount of 20%. So let me go ahead and do this using the switch statement. So I'll delete all of this. I will type switch over here. So over here I need to give the object. So object again. Now since this is actually a factor, I will change this to a character vector. So I will type as dot character of, and I'll give the column over here, which will be customer churn dollar internet service. Right. Now the first case would be DSL. Whereas if the customer's internet service is DSL, then I will give this guy a discount of 10%. Right, again, so let me have a glance at the cell numbers. So this will be 1, 2, 3, 4, and 5. Right, so over here, let me just give down the cell number, which is 5. So what I'll do is I'll select customer churn $monthly charges, cell number is 5, and I'll give this guy a discount of 10%. I'll give a comma. Now I'll give the second case, and the second case is if this guy uses fiber optic. So if this guy uses fiber optic, then I will give this guy a discount of 20%. So customer churn $monthly charges, cell number 5, and 20% discount. So I will have to multiply this value by 0.8. So let me go to monthly charges. So 1, 2, 3, 4, 5. So this was the initial value 70. Right. Now I will select all of this, paste it over here, and I'll store the result back to the same cell. So this will be customer churn $monthly charges, cell number is 5. Let me have a glance at the data set now. Let us see the result. So we have our monthly charges. So initially it was 70, and after giving this guy a discount of 20%, his monthly charges came down to 56. Right, so we are also done with switch. Then we have looping statements. So these looping statements basically keep on repeating a certain action, like keep on printing your name for 1,000 times, or keep playing the music for the next 1 hour. Right, so let's go ahead and work with this looping statements. So I'll start with for loop. Now we have this gender column over here, and I'll use the for loop to count the number of male customers. Right, so I will type for, and over here I'll give a variable, and I'll name this variable to be I. This is the vector. So I'll give a range over here. So for I n 1 is to n row of customer churn. So that is, this loop will run starting from 1 to 7043. Right. Now in this entire loop, I need to check number of male customers. So for that, I will use the if condition. So if customer churn $gender is double equal to male. Now I will create another variable over here and give this to be 0. So if customer churn $gender, again I need to give the cell, which is I over here. So if customer churn $gender, I is double equal to male, then I will increment the count value. So count will be count plus 1. Right, so what is happening is initially I value is 1, so now this will be evaluated to true, and again over here I am checking if customer churn $gender, the first cell value, if this is equal to male, then I'll increment count with 1. Again this loop will come over here, I value will be 2. Over here we'll check if customer churn $gender 2. So this is male again, so count's value will be increased to 2. Similarly then I's value will be 3, and we'll check the cell number 3 over here. Cell number 3 is male again, and again so the count value will be incremented and it'll be 3 now. So this is how this loop will go on. So let me print this over here. Let me print count. So we see that there are 3,556 male customers. So let me verify this with the help of table function. So I'll type table of customer churn $gender, and we see that this is actually true. There are 3,556 male customers. Right, so this was for loop. Now we'll go ahead and understand the while loop. Now with the help of while loop, we will get a count of the number of customers whose payment method is electronic check. Right. So now I will delete all of this. I will give a new variable which is I is equal to 0. I will create the while loop over here. I'll give a condition. So I will check if I is less than n row of customer churn. That is, if 1 is less than 7043. So this actually needs to be less than or equal to 7043. And if this is true, I'll go ahead and check my condition. If customer churn dollar payment method, here I'll give the cell number which will be I. So if this is equal to electronic check, then I will increase the value of count with 1. So count will be count plus 1. Right. So after doing this, I will also increment the value of I. So I will be I plus 1. So let us understand this properly. So I am checking if 1 is less than or equal to 7043, which is evaluated to true. And since this is evaluated to true, then I am using the if condition to check if the cell number 1, the payment method, is electronic check. So since this is electronic check, the value of count is incremented. Now after this if condition is done, I am incrementing the value of I over here. Now I's value will be 2. Then I'll check if the value over here is electronic check or not. Similarly, this loop will continue on. So let me go ahead and select all of this and print it over here. I'll type count. Now let me verify this. So table of customer churn dollar payment method. So see that the number of customers whose payment method is 2365, and over here we have got the count to be 2365. Right, so we are done with while loop. Then we have user defined functions. So these basically help us to modularize our entire program. Let's say if we wanted to find out the minimum and maximum values of every column. So all we need to do is create two functions, min and max, which can be applied on all the columns. So let's go to RStudio and create some user defined functions. Right now, again, I'll create a user defined function to get a count of number of male customers. I will name the function to be gender count. Now this is the syntax of a user defined function. So I will type function, and this is our parameter over here. Right. Now inside this, I need to write the entire code to find out the count of the number of male customers. Right. So I'll be using the for loop again to do that. So I will type for I in 1:, length of x. Right. And over here, I will check if x of I is double equal to male. And if it is equal to male, then I'll say count is equal to count plus 1. Again, I will create a new local variable over here, count, whose initial value is supposed to be 0. Right. So let's go through this function again. So this is the syntax of a function, and I am naming this function to be gender count. So over here, I will send this gender column as the parameter. Now, once I do that, I have initialized local variable where count is equal to 0. And over here, the loop starts. So for I in 1 is to length of x. So length of x, that would be the length of this column, which would be 7043. So this loop will go from 1 to 7043. Right. And inside this over here, we check for each and every cell. So if x of I, so for first iteration, it will be x of 1. So we'll check for this cell. So if this value is equal to male, then count's value is incremented by 1. Again, I's value is 2. And if the value in the cell is male, count's value is also incremented by 1. And this goes on. After the entire loop is done, I'll also print the value of count over here. Alright. So I will select all of this and I will paste it over here. So we have our function to be ready. Right, so gender underscore count, and I will send the gender column as the parameter. Right, so we get a value of 3556. Let me verify this again. Table of customer churn $gender. Right, so we see that number of male customers is 3556. So now the best part of functions is we just need to make a small change over here if we need to find out the number of female customers. So all I'll do is I will change this to be female, and I can pass in the same column to find out the count of number of female customers. Right, so I will use this function again, gender count, and I'll say customer churn $gender. I'm sending this as the parameter. Now let us see the count. Let me verify this. So I will type table of customer churn $gender. And over here we see that the number of female customers are 3487, and that is the same value which we've got with the function. Right, so this was an implementation of user-defined function. We'll work with the basic data structures in R. So we'll start with one-dimensional data structures, which are vectors and lists, and then we'll head on to matrices and arrays, which are multi-dimensional data structures. So the most basic data structure in R is a vector. It's a homogeneous unidimensional object. So what do I mean by homogeneous? Well, all of its elements must be of same type. Like over here, we have a collection of birds linearly arranged. Now let's go ahead and implement this in R. Alright, so we are back to our studio. I'll start off by creating a character vector, and I'll name it as bird. And I'll go ahead and give down some names of birds. So our first bird would be eagle. Then we have parrot, and our final bird would be pigeon. Now let me print this. Right, and let me also go ahead and check the class of this vector. So I'll type class of bird. Right, so we see that this is a character vector. That is, all of these three elements are actually characters. Now I'll be creating an integer vector, and I'll name this as numbers. So I'll just list down the numbers from 1 to 9. Let me print this now. So this is a vector which comprises of numbers from 1 to 9. Let me go ahead and check the class. So I'll type class of numbers. So this is integer. Then we have a numeric vector type. So in numeric, we can give floating point or decimal values. So I'll name this to be decima, and I'll give some floating point values. So I'll just give some random floating point values over here. Let me print this. Now let me check the class. So I'll type class of decima. So see that this is of numeric type. Right, and then finally we have a logical vector, and in logical vector we can just have two values, either true or false. So I'll name this to be logit 100, and give out some logical values, true, false, and if I'm too lazy I can just give T and F like this over here. Right, so let me print this logit 100. Right, so these are all of the values of this vector. Now let me check the class. So I'll type class of logit 100. So see that this is of logical type. So this was an implementation of vectors in R. So then we have a list. So a list is a heterogeneous collection of elements. That is, the elements do not have to be of the same type, and each element actually retains its own identity even when it is present in the list. Like over here, we have a heterogeneous collection comprising of a bird, an apple, and a car. So let's head to R and work with list. So this is how we create a list. I type out list, and let's say the first element is the integer 1. Then I'll give a character value, and I'll name it to be Nirvana. After that, I'll give a logical value, and this is true. I'll store this in mix bag. Right. So let me print mix bag over here. So this is how our list looks like. So we have three elements. First is integer, next we have character, and then finally we have a logical value. So let me check the class of this object. So I'll type class of mix bag. So you see that this is a list. Now I'll also go ahead and check the class of individual elements. Right, so I'll type class of mix bag and I'll give 2 square braces and I want to check the class of the first element. Right, so we see that it is numeric, second is character, and the third element is logical. Right, so let me actually print the list for you guys. So this number 1 is of numeric type, this element nirvana is of character type, and this element true is of logical type. So we see that all of these 3 elements retain their original identity or their original classes. So this is how a list functions. Next in line is a matrix. So matrix is a homogeneous collection of elements in 2-dimensional space. So over here, all of the elements belong to the same category, namely fruits, and they are arranged in the form of rows and columns. So now let me go ahead and implement matrix in R. Alright, so to create a matrix, what I'll do is I'll actually be using the same vector first. So let me have a glance at this. Right, so now I'll be inserting all of these elements into our matrix. Right, and to create a matrix, I will type matrix. So the first parameter is the data. So for the data, I am giving the numbers vector. After giving the numbers vector, we have 2 other parameters where we specify the number of rows and the number of columns that we want. So let's say since we have 9 numbers in total, I would want this to be a 3 cross 3 matrix. That is, n row is equal to 3, or number of rows is 3. And similarly, n col is 3, or in other words, number of columns is 3. And I will store this in mat1. So let me print mat1 now. Right, so this is our matrix over here, where all of these of same type 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are all integers and I'm storing them in the form of rows and columns. And what you see over here is these elements are arranged column wise. So if I want to arrange these by row, then what I'll do is we have the by row attribute and I'll just set it to be true. Right, and I'll print mat1 now. You see the difference over here. So now the elements are arranged by row 1, 2, 3, 4, 5, 6, 7, 8, 9. Initially they were arranged with respect to column. Now they are arranged with respect to row. Right. So now I'll create a character matrix. So what I'll do is I'll create a character vector first and list down some characters. So let's say I will give the first 6 alphabets. So A, B, C, D, E, and F. Right. So I have created a character vector naming alpha, and this consists of 6 elements. All right. Now I'll take this vector and create a matrix. Matrix. The data is coming from alpha vector. Now, since there are 6 elements in total, I want this to be a 2 cross 3 matrix. Right, so number of rows is 2 and number of columns is 3. And I will store this in, let's say, mat underscore alpha. Let me print this now, mat underscore alpha. All right, so this is a matrix over here. So 2 rows and 3 columns. Now again, if I want to arrange this with respect to row, all I need to do is set by row to be true. Now again, I'll be printing mat alpha. Right. So this was with respect to columns. This is with respect to rows A, B, C, D, E, F. Right. So we have also created the matrix. Now, what if you wanted to access the individual elements of the matrix? So this is how we can do it. So let's say I would want to access this element over here. So all we have to do is set the index values. So this is present in the first row and second column. Right, so I'll give 1, comma, and we have successfully extracted this element over here.
Similarly, if you wanted to extract this element f over here, so this is present in second row and third column, right? So mat alpha 2, comma 3. And we have successfully extracted the element f from this matrix, right? So this was an implementation of matrix. And finally, we have arrays. So this is just an extension of matrix. That is, it is a homogeneous collection of elements in n-dimensional space. So let's actually go ahead and implement arrays in R. All right, so what I'll do is I'll create a new integer vector and give out values from 1 to 9, and I'll create a second integer vector, and in this I will give the value starting from 10 to 18. So we have created two numeric vectors over here, and we'll be using these two numeric vectors to create an array. So this is the syntax to create an array. I'll type array and I'll give out the data, right? So the data is coming from these two vectors. I'll use the combine function and give out these two vectors over here, num1 and num2, right? After this, I need to set the dimensions. That is the number of rows, the number of columns, and the number of dimensions, right? So the dim will be, so in total we have 18 elements. So we have 9 elements in num1 vector and 9 elements in num2 vector. So what I need is actually two matrices of 3 cross 3. So I will give 3, comma 3. So this is the number of rows and number of columns. And since I need two matrices of this type, so I'll type in 2. And I will store this in array 1. Now let me go ahead and print array 1. So this is our resultant array, right? So this is all of the elements from num1 vector which are stored in this part over here. And then we have all of the elements from the num2 vector which are stored in the second dimension over here. Right now, so how can we access individual elements from this? So let's say I would want to access this element number 15. So let's go ahead and access this. I will type array 1. Now let me check where is this present. So this is present in the third row and second column. So I'll type 3, comma 2. And after this, since this is present in the second matrix or the second dimension, I'll give in 2 over here. And let me check the result. And voila. So we have successfully extracted 15 from this. So similarly, if I wanted to extract this element 5, so let's go ahead and do that. So let me actually, yeah, I need this now. So I will type array 1. And this is present in second row and second column. So I'll type 2, comma 2. And since this is present in the first dimension itself, so I'll give out 1 over here. Right, and I have also extracted 5.
Just a quick info, guys. Test your knowledge of R programming by answering this question. R functionality is divided into a number of dash. A. Packages. B. Functions. C. Domains. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Let's understand what is statistics. Statistics is a branch of mathematics that deals with collection, analyzing, and interpreting large amounts of data. So we live in the world of data today. Data is everywhere, and you yourself are creating data merely by existing. Even if you're not interacting with any social media platforms, even if you don't have a phone, you're still creating data about yourself. Now, how is that? Your social numbers, such as your voter ID numbers, your Aadhaar card numbers, your employee ID numbers, they are data about you. They help to identify you or locate you in a specific context. What's more is your banking transactions, the things that you've bought online, your loans, your credit scores, all of that is also data about you. And they can help identify banks and companies and government to make important statistical analysis and inferences about you. Things such as whether you should be provided the next loan that you're applying for. This is what credit scores are there for. They help them decide whether or not you've taken loan previously and you were able to pay it off before or well before on or well before the expected date. Are you good for your money? All of these kinds of things that impact your daily life are predicted and calculated using statistics. It's not the only thing in your daily life. Statistics is being used all around you, all around the world, and we'll take a look at that one by one. But to understand what statistics is, it's a mathematical concept that allows you to derive information based on the data that you have about a specific topic. You can do this for yourself as well. You can take some data that you have collected about you, such as the daily expenses or monthly or yearly expenses that you have, and you can understand when does your expenses rise and when do they fall, what could be the reason behind that, and you can correct for them as well. So as you can see, it's a really important tool for anyone of any field to understand what statistics is. So why is statistics important? We've understood what it is and what can be done with it. But why is it important? What benefits does it provide to a normal person such as you and me? And is it really important for us to understand this? Let's take a look. So statistics allows us to derive knowledge from large data sets. As I've already discussed, data sets don't really need to be large, but if you have large data sets, then the knowledge that you have derived have higher chances of being accurate or reflecting the real world. And this knowledge can then be used to make predictions, decisions, and classifications. These decisions could impact your daily lives, and these decisions and predictions and classifications can be performed by you as well if you know these statistical concepts and if you have collected these data about yourself. So it's not just about yourself. You can compare your spending with other people by collecting the data that they spend, or collecting data about their spending or their expenditures as well. And you can also take a look at your career graph. You can take a look at salary hikes. You can compare whether you are getting the appropriate salary hikes that you should be getting depending on the kind of work hours that you've been putting in. There's a lot of things that you can do, and all of that could be performed using statistics. Now statistics is really important in the sense that it's being used in daily life uses. So even if you are not using statistics to do something about about the data that you have, many companies are doing it for you. If you're using Netflix, then many movie recommendation engines such as Netflix, Amazon Prime, and so on, they use statistical analysis to gather what kind of movies you like, what kind of movies do people of your age, your background like, and they recommend movies to you based on that. You can also make decisions based on that, such as whether you should take an umbrella outside or not, based on what the weather should be. Now, weather forecasting is also something that statistics is used for. You can also perform classifications. You can perform time series analysis. You can understand what would be the price of stock in coming days. Now, these are obviously not 100% accurate. Sometimes weather forecasts are wrong. Sometimes the decisions that you take about whether or not the weather is going to be like a particular thing that you have in mind, and it's not like that. Whether or not something is matching to the thing that you have, that's not really what statistics is about. It's about making a decision about a trend, understanding where things could go. It's not 100%, it's not exact science. You're not going to get 100% answer for everything, but it's a good indicator of what you should do based on the data that you have. Now, where is statistics used? You've heard me say countless times that statistics is being used in your daily life, whether you use it or someone else is using it for you. Let's take a look at that. So statistics is used in various fields. So let's take a look at some of them. Medical research. Medical research uses statistics extensively, mainly to form hypotheses and reject hypotheses about drugs. So if you've ever wondered, how does a medical professional comes to the understanding whether a drug is working or not? Let's say that they've created a new vaccine for a specific disease. Now they want to test whether that vaccine is working or not. How do they test it? If there's a person and they inject it with that vaccine, and if he recovers, does that mean that the vaccine is working? Because if it's so, then just one person is not enough. There are in a particular vaccine test, there are hundreds of people, and if you inject them with the vaccine, and if it's not working for everyone else but it's working for one person, do we reject the vaccine or do we accept the vaccine? If not, then what is the number of people that it should work on? What should be the profile of those people? Does the age of the person matter in this case? All of this is taken care of by statistics. So in medical research, statistics is used extensively. It's not just for understanding whether a particular vaccine or a tablet or chemical is working for a particular disease or not. There are many other things that statistics allows medical researchers to do, but this is by far one of the most important aspects that medical researchers use statistics for. Then comes stock market. Stock market is one of those fields where statistics is used extensively, and it's used especially by those who invest in stock markets, mainly because they want to predict whether investing in a particular stock is going to be helpful for them or not. Are they going to lose money, and if what is the risk of investing in a particular stock? Are they able to sustain themselves even after that risk fruitions? If the worst case scenario happens, would they be able to survive? And if the best case scenario happens, what would be the profit? All of this is taken care of by stock market. In stock market, the data about a particular company's financial records, about their credits, about their stock market scores, everything is available for people to take a look at. So if they want to make predictions using statistical analysis, they can do so very easily because the data is already available. They just need to do the brunt of the work to get knowledge out of the data that is available for them. Then comes sales projection. In case you've worked in a company before where sales is important, you'll understand that sales is by far the most important aspects of many companies. If they're selling a product, they need to project what would be the sale of a particular product at a particular month, or at the end of a particular month, or a particular time period, such as a quarter of a year, that is, for 3 months, and understand is the sale really up to the mark. So if a particular product that has been sold for the last 4 months, taking a look at the trend that it has shown, the trend of the sales that have shown, and we try to project it for the next 6 months, if it's not up to the mark, then that product is not doing well and it could either be taken off the sale, or you could understand how what are the concepts that what are the things that are not letting it be sold more, and you could correct for those mistakes. So a sales projection is what is used to understand, to project in future what would be the sales. Now of course, as I've already told you, it's not going to be 100% accurate. If you have predicted that 10 lakh units of a particular mobile phone will be sold in the month of September, it's not exactly the case that exactly 10 lakh units will be sold. But if in the previous months 7 lakh units were sold, and in the next month 10 lakh units will be sold, then you can understand that the trend is rising. So in 2 months, in one consecutive month, we are getting an increase of 3 lakh sales. What could be the reason for that? Maybe proper marketing and all that. So all of that is understandable by statistics. Many companies hire really good statistical and data science experts. They take a look at the sales projection, they try to isolate and identify the causes for it, and they try to replicate it more and more. This is what helps great companies survive. And then finally, weather forecasting. I think we all know what weather forecasting is. We all know weather forecasting uses statistics, but weather forecasting uses something called multivariate analysis. Multivariate analysis basically means there are several concepts or several factors that are influencing the weather on a daily basis. It could be the pressure, the air pressure, the wind flow, the direction of the wind. There could be a lot of things like the temperature and all that. And everything is important when you're trying to understand the weather forecasting. All of these things are taken into account, and then the weather is forecasted. Is it 100% accurate? Not really, but it tells you a general trend of what could happen. So it's more accurate than it's not. So that's what's important. So statistics is used in all of these fields. These are really small set of statistics and very well-known small sets of these statistics. We all know that these, or at least we know some of these concepts are using statistics in really in-depth analysis. So we understand that these departments are using statistics, medical researching, stock market, sales projection, weather forecasting, but there are many companies and they're using it for many other purposes. Now let's take a look at sampling. Sampling is the process through which we take a subset of our data from a larger set. So let's take a look at it. So sampling is the process of collecting data to perform analysis on it, or choosing a subset of data to perform analysis on it. Suppose you have 10 million records in your data set. Now, how do you choose a specific subset of data to perform analysis on it? Now you might be wondering, why is this important? We can just select any random 10 points if you want to perform data on 10 points, or perform statistical analysis on 10 points, and then we do that. Or you might be wondering, why do we actually need to sample our data? Why can't we just perform statistical analysis on those 10 million records? Well, first thing to understand is that statistical analysis, although very important, is very time consuming. Even for a computer, it has to churn through a lot of data, perform a lot of complicated calculations, a lot of arithmetic, a lot of number churning is required for getting accurate results. So instead of doing it for the entire data set, we do it for a subset. Suppose that you have a data set of all this information about all the 7 billion people across the world. It's a hypothetical situation. You are not going to have information about that, but let's say that you have that. Now if you want to perform a statistical analysis on that, you want to check whether whether something is true for everyone across the globe. You can, for instance, instead of choosing all the 7 billion people and then performing the statistical analysis and the numerical calculations on the entire 7 billion people, you can choose a specific subset of it. Now, how you choose the subset is really important, because you don't want to choose a data set in which you only include people from a particular country but not from the other country. That would, in some cases, lead to a biased data set, a data set that contains only a specific subset of people. So that's important. Similarly, if you're trying to perform an organization-wide statistical analysis, let's say that you are working in a multinational company and you want to perform some statistical analysis on an organization's employees, and there are, let's say, 25,000 employees. Now, for you to perform statistical analysis on 25,000 employees is not really viable. So what you can do is you can choose a specific subset or small subset of that data, make sure that it accurately represents, or make sure that you've selected in a way that every record in that 25,000 records had equal likelihood of getting selected, and then you selected them in that basis. So that's one way of doing it. So this is why we perform sampling, to get a small subset and perform statistical analysis on this. A small subset that accurately represents, or more or less represents it approximately well, so that could be performed, we could perform statistical analysis on it. The sample should represent a large subset. So that's what's important here. And before we begin, we should understand what is sample and what is population, because this is terminology that you're going to come across many times. And if you're trying to learn statistics, you've come across this already. So population is the entire data set, and such as the whole population of a country. And sample is a subset of that data. Population is the entire data set, and sample is the subset of that population which we are going to analyze to gain knowledge from. So suppose you're trying to perform some sort of an analysis on the people of a particular country, let's say India. Now there are 1.3 billion people in India. Now trying to perform statistical analysis on that big of a data set is going to be really challenging. So in order to reduce our burden and computational intensity, what we're trying to do is we're trying to choose a small subset of our data that is somewhat representative of the larger subset. So we try to gather data, try to choose around 20,000 people from 1.3 billion people that accurately represents the entire 1.3 billion people demographic. Now it's not necessary that we choose 1.3 billion. Let's say that we're trying to perform statistical analysis on people of India who are senior citizens, who are above the age of 60. Now, then that is our entire population. Everyone in 1.3 billion people who are above the age of 60 is the population, not the entire country's population, but just the subset that we're interested in. And if the size of that data set is really large, then we choose a small sample of it and we try to make it as fair as possible, so that any person could have been randomly given a randomly chosen list. We choose someone randomly in that list. So that's the point. Population is the entire data set that we are interested in, not the entire data set that represents a particular group. And sample is the small subset of that population. If you're trying to perform statistical analysis on an organization, but only the senior members of the organization, then you have a smaller population. And from that smaller population, you can choose even a smaller sample. That's what's important here. Let's understand sample frame. So sample frame, or sampling frame as it's also commonly known, is a list from which a sample is selected. So this list could be anything. When I'm using the word list here loosely, List doesn't necessarily mean a physical list that you need to create, although it could be a physical list. It's just collection of data points. That's a list. So for instance, the citizen register for a country. So if you're part of a country and you're taking a look at their population register and you're trying to understand the amount of people, their age, nationality, their income, family, number of people in the family, so on and so forth. So that's the sample frame. On the other hand, if you're trying to perform statistical analysis on an employee, on all the employees of a company, then that's your sampling frame. That is the data set from which you can choose your sample. So again, it's the same paradox that we had earlier. We need to just understand what is it that we're trying to perform the analysis on. If you're trying to perform analysis on every employee ranging from an intern to the CEO, then we use the entire company's list. Otherwise, we choose a specific subset. Let's say that we want to perform statistical analysis on the high paying side of the company. So we want only the senior members, people who earn above a specific threshold or per annum, and we perform statistical analysis on that. So that is what's important here. We're trying to choose a sampling frame is basically a list from which you choose a subset to perform statistical analysis on. Let's take a look at sampling error. So a sampling error is something that leads to a sample not being accurately represented in a population. Now, instead of me explaining to you theoretically, let us take a look at what that would mean. So I have this Excel sheet. I have bumped up the font size so that you can see what I'm trying to do. Now, let's say that I'm trying to take a look at a list of employees. So EMPLOYEE ID. Let me just expand the column. So let's say that the employees are, okay, there are 10 employees, and let's give them a name, AB.
Just a quick info, guys. Intellipaat provides online data science master's program in partnership with IBM. The course link of which is given in the description below. Now, let's continue with the session.
So these are all the employees we have. These are just a sample list of employees. We have 10 employees. They have an employee ID ranging from 1 to 10. And we have employees with the name of A to J. Now, let's say that this is just for an example. Let's say that it's not 10, it's 10,000. So now I want you to select a subset of this employee. So how do you go about doing it? And the method you choose is incredibly important here, because if you choose, let's say, the first 5 employees, let's say that your threshold is that you want 5 employees, or you want to reduce this list by 50%. So you choose the first 5 employees. Now the problem is, let's take a look at that gender. So if the first 5 are all male.
Just a quick info, guys. Test your knowledge of R programming by answering this question. R functionality is divided into a number of dash. A. Packages. B. Functions. C. Domains. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
And the last 5 are all female. And if you choose the first 5 employees to perform your statistical analysis on, then you have chosen a you have chosen a subset of your data, or you've chosen a sample that's biased. That's an error in your data. Now, everything that you perform is not going to represent the 50-50 gender ratio that this company has. So if you're trying to perform statistical analysis on what kind of products that does a company's senior level executives like, then you have only taken the male perspective into account and not the female perspective. So that could be a problem. Let's say that you don't do that first 5, you choose the last 5. You're running into the same problem again. You're choosing only females. And let's say that you choose this, then you are only getting 1 female out of all the females. And if you're choosing it like this, then these records, the first record and the last 4 records, they have no chance of being selected. So this is not an accurate way of doing it, or a correct way of doing it. There are many other ways that you can get errors like this. Let's say that there's age involved. Let's say that there's salary involved, and the subset that you're interested in is based on age. and then you're getting an error, then you don't have if you don't use it correctly, then you're not accurately representing or reflecting the entire population in your sample. So that is an important error to take a look at. There's also non-sampling error. So non-sampling error occurs even if you perform all this sampling correctly, even if you try to do it with all good intentions and do it with as much accuracy and as much good intentions as you can, there's still reasons that you get a biased data set. Let's take a look at why. Suppose that this is the information that I have. Now, non-sampling error mainly occurs because of you not getting you're not getting proper data or properly collected data. Instead of this, let's say that I got a data set to select from, in which I have 8 male employees and 2 female employees. Now, even though the company has 50-50 gender ratio, I've only gotten the data set that I've gotten is not accurately represented. So no matter how I choose it, even if I choose it like this, I'm still not going to get if I choose it like this, I'm still not going to get correct representation. Now that is a problem, and that means that our data set is not correct. Our data set is biased. On the other hand, if we get only the list of employees of young employees who were hired after 2010, then that is also a problem, because we want a wide spectrum of opinions. So we need people who have been hired before that as well. Now, it's not always the fault that you are getting incomplete data set. Sometimes what happens is the data was not collected. So let's say in the case of age of or the experience of a person, let's say the maximum experience that we're getting is 10 years of experience of a person, even though there are people in the company available who have had 25 years of experience. Now that could be that before the 10 years, they've only started keeping record of their employees since the last 10 years and not before that. Everything else is not in the list that you're taking a look at. So that could be a problem. So these are the kind of errors that you need to take care of. These are called non-sampling errors. Now, if you take a look at the company and you don't get the accurate representation, then that is the problem that you're facing. And even though you try to perform good sampling analysis from that, you can still run into some great errors and incorrect or incorrect measurement or bias. So to understand incorrect measurement, let me just show you. Let's say that you're also calculating the temperature. Let's say that this is not the list that you're trying to do. Let's say that you're trying to calculate some statistical weather forecasting. You're interested in the temperature of the particular place. Let's say that the temperature ranges from 50 degrees to from 30 degrees to 40 degrees. Now, depending on how the temperature is taken and how long the period was, this is going to be a problem. Let's say that for some of the years, the temperature has been taken in Fahrenheit. In others, it was taken in Kelvin. And in others, it was taken in Celsius. It could be that the company who was taking the measurement was going back and forth between what measurements to take care of. Now, if this is not mentioned and we are only given numerical details, like 87 degrees Celsius, 84 degrees Celsius, 104 degrees Celsius, 107 degree Fahrenheit. Now let's say Kelvin is 275, 321, 320, and for degrees Celsius you're getting 27, 26, 31, 32, and 30. Now when you take a look at the data set, it's extremely varied. And this is not an information that you're getting. This is just for your reference. Let's say that this is the information that you're getting. Now the problem is that you have no idea why some temperatures are 276 degrees while others are 87 degrees, because if you take a look at it, you can't understand whether it's degree Celsius, degree Fahrenheit, degree Kelvin, and that could really lead into some errors. So this could be because of inaccurate measurements as well. Just delete that and let's move ahead. So when the data is being collected, that's also important. This is why we need to take care of that as well. Suppose we have census data from people from a country or a particular state or particular district. There also we could have incorrect samples. There also we could have problems. So we need to first analyze the data that we're getting the sample from, so that we don't introduce a non-sampling error. Then we need to perform our sampling as accurately as possible. And let's take a look at some of the methods through which we can do that. The first is random sampling. So as the name suggests, random sampling is the process of selecting a subset or the sample from a population in such a way that every data point is equally likely to be included in the sample. So every data point has a fair chance of getting included in the sample that we're selecting from the population that we're selecting from. So again, to give you an example, let's say that now it's representing properly. Now I have 5 males and 5 females. Randomly selecting them is going to be a little difficult. So let's say that it's not going to be very difficult, but it's easy to understand. Just make sure that you're putting your head in the right place. So if your thought process in the right aligns, we want to make sure that these 5 female employees and these 5 male employees are equally likely to be selected if we select randomly. So to do that, what we can do is, firstly, as we have already done, we have taken 10 employees. So we know that the employee IDs go from 1 to 10. If this is not the case, then we can take a look at some other measure. But here we have an employee and we have a list of employees. We are given a list index assigned to the employees. Now, if I want to select employees, what I can do is, firstly, I can decide the size of my sample. So let's say that I want to reduce it by 50%. So for that, I need to select 5 people from this list of 10 people. To do that, let's say that I just randomly select 5 employees. Randomly, that means from the range of 10. So I select 1, I select 5, I select 8, I select 10, I select 3, right? So these are all randomly selected people. Now I have 1, 2, 3 male employees and 2 female employees. So again, the sample is not going to be extremely accurate representation, but we're getting 60-40 representation, which is to say that we're getting around 50%, which is quite accurate of the one that we already have. Now the thing we need to understand is that since we have selected them, one potential issue that you can run into is that when you're selecting these samples, you are selecting them in and then reselecting the index. So let's say that I come up with 10 random numbers from 1 to 10 as 1, 2, 7, 2, 5, 4. Let's say 7, 2. Now the problem is that I've selected the index 2 twice. So make sure that you understand this. Many people just discard the next number to be something that other than what has already been selected. So that's one way of doing it. So just make sure that you're doing it correctly. The reason why random sampling works so well is because we are just randomly selecting any record that we can. And sometimes that's not always correct, because sometimes you get, if you're randomly selecting, you could put, if you have a large data set, then you could have 4 of male employees and 1 of female employee. So it's good technique, but it's not perfect. If you have a really large data set and you have accurate representation, then it's random sampling works really well in that scenario. But how do you correct for mistakes like this? That is for our next sampling method will tell us. So we understand random sampling. We just choose randomly out of a list of all the people from the population. We randomly select just a few people. So with that in mind, we run into an error in which if our data set is not really large, then the problem occurs that we might end up selecting data that's not accurately representational. Even though we might not be selecting it in a way that is completely malicious, we are not trying to select the people from a specific gender in our data set. We're just doing it randomly, but still there could be issues. So to overcome that, we come to stratified sampling. So stratified sampling is the process of dividing your samples into layers or groups and then performing random sampling on each group. So let me give you an example. Let's say that instead of 10, we have 12 employees. 11, 12. And yeah. So now let's say that I want to perform stratified sampling and the sample size is 12 and I want 50% of it. That is 6 employees. So to select that, firstly I take a look at the deciding factor. So I'm selecting them on the basis of gender. I want them to be accurately representative of the gender. So to do that, what I can do is I can firstly perform my stratified sampling in this group. It's an entirely male list. It contains only one portion of the entire group, and the other portion is contained in the list below. So let's say I wanted to select 6 people. There are 2 genders. So that means I want 3 out of each, right? That would be an accurate representation of the list that we have. Now, in case we have 40, 60, then we could select it in a different basis. So now what we can do, in this, I select 3 people randomly. Let's say I select 1, I select 2, I select 5. These are randomly selected. Let me just give them a color to tell you. And then in the other group, I select 3 people randomly again, 7, 8, 9, and 10. And you have a randomly selected list. It's accurately representing the population that we have. We have 3 females and 3 males out of 5 females and 5 males. So this is what stratified sampling does. The word stratified comes from the word strata, which basically means a layer. So we divide them into groups, or we divide them into layers, as many people would call it, and then we choose a specific subset of that layer or of that group to get an accurate representation of the entire population. That's one way of doing it. Random sampling is good when you just have people that you want to select and there's no need for accurate representation of a particular group. On the other hand, stratified sampling is good when you want to perform random sampling, but you have to take into account certain divisions in your data set, such as a group or division based on specific gender, specific age groups, anything like that. Now we come to systematic sampling. One major issue with the previous examples is that you need to have the entire list with you in order to perform the sampling. Let's say that I am working in some department in which data is coming in regularly. So I can't select data on this because I can't select data, or I can't select the data points that are going to be included in my subset or in my sample if I don't have the entire list. If I have 3 people, then I can only select out of 3 people. In the next day, if I get 3 people more, then I can only select out of 3 people, and that is going to be a problem. And if the next day I get 7 people, then it's going to be incredibly difficult to make sure that I'm selecting them accurately. So I need to get the entire data set beforehand. Now, that's not always the case. It's not the ideal situation. Sometimes you can run into issues that are not based on that. So how do you correct for them? You come to systematic sampling. Systematic sampling is the process of selecting your samples by picking every kth element in your population. Now, k could be any number that you want, from range going from 1 till the number of people that you get. And you don't need a list for this. That's the extreme advantage of systematic sampling. Let's take a look at how to perform this. So let me just write the date on which these data points are collected. Let's say that's collected first of a particular month of a particular year. These are collected on the 2nd, and these are collected on the 3rd. Now, let's say that the k I choose is 2. That means I will select every second data point. This person comes in, I don't choose them. This person comes in, this is the second point, so I choose this. I move ahead. This person comes in, I don't choose it. The next day I keep the index and I choose this because it's the second person. Even though they have not, we have not seen them previously, they're still, the list is still going on and the calculation is still going on. Second person gets selected, second person gets selected, second person gets selected. As you can see that we are excluding the first person and including the second person. So that's how you can take advantage of the k sampling. K could be anything that you want. Make sure it's not really big. Make sure that if you're only getting at max 3 people or 4 people in a day and you select 15, then you're never going to get the accurate representation or never going to select anyone that you want. So with that in mind, understand that this is going on. But one issue that you could run into is that this is not for every scenario. Let's say that I have a sample in which first person is male, second person is female, first person is male, second person is female, and this is the sample I have. If I choose k is equals to 2, then I only get female employees in my company to be taken as the subset or the sample of a population. That is going to be not indicative of the kind of problem that I'm trying to solve. So I'm not going to do that. So take a look at the data set. If your data set is arranged in a particular kind of group or a particular kind of pattern, that such as first employee is male, second is female, first is male, second is female, then kth employee is not going to, kth or systematic sampling is not going to make sense for you. But if you have data set in which people are coming in regularly, this is for clinical studies or for test studies. If you've seen this, many people who go into a clinic to consult a doctor, the receptionists or people there sometimes give some of them a list or a questionnaire to fill out. That is to judge the performance of the clinic or some other problem that they might have, or maybe some medical survey to fill out. This is done using the systematic sampling because you have no idea how many people are going to visit your clinic in a particular day, in a particular shift of a person. So this is why systematic sampling is useful. You just take a look at the name of the person, and mention them in a register, and then give them a number from, give them an incrementing number from the previous number. So the previous person was 1, then you give 2, 3, 4, and you select the kth employee for the scenario. And this is how that would work. So hopefully you've understood this. Now let's take a look at central tendencies. So central tendencies, as we've already discussed, take a look at the definition, is used to indicate where does the middle or the center of the distribution of a data lies. So central tendency basically is used to find out where does the most amount of values that our dataset contains cluster into. What is the range in which our dataset clusters into? So if we have a data set in which majority of the values are between the values of 4 and 10, then we have our central tendencies lying there. We have different ways of calculating different central tendencies, and they tell us different things about our data. So we have mean, we have mode, and we have median. So these are different metrics that all come under the umbrella term of central tendency. Central tendencies contain mean, median, and mode. These are different measurements of our data, and they tell us different things about the data that we have. Some are more important than others, and some have some categories as well, and we'll take a look at them one by one. The important thing to understand is the concept of central tendency tells us where does the majority of our data lie. What is the range in which the majority of our data lies? What does that tell us? And then when we go into detail, we try to understand what does this range of the data tell us, and what can we extract of value out of this information. Let's take a look at mode first. Mode is used to indicate the most frequent data point, or in other words, the one which occurs the most number of times. So if we have a data set in which we are trying to calculate the most frequent or the most popular choice, this is where mode comes in. Let's take a look at that. This is what we have from previous data sets. Let me just remove it. Now let me just show you. Let's say that you are trying to perform a survey between 3 products. Let's say the products are P1, which is the first product, P2, which is the second product, P3, which is the third product. Given a choice, a customer is given a choice to buy one of these 3 products, or considering all of them are of the same price and everything else is the same, and they are being judged on their quality of aspects. Then which product will the customer buy? This is something that a customer will choose out of the 3. So let's say that you perform this for 10 people, and let me just remove this. So these are our choices, and the first person chooses P1, second chooses P2, third chooses P1, fourth chooses P1, fifth chooses P1, and then the other one chooses P3, then chooses P2, then P2, P1, P3, and P1. Now if I were to just calculate the number of people that chose P1, it's 1, 2, 3, 4, 5, 6. So 6 people chose P1. Then we have P2, and 1 and 2 people chose P2. And you can probably guess the 2 people chose P3. So if I were to ask you, okay, what is the mode of this data set? You're probably going to, I think the question is quite clear. Mode of the data set is the value that is the most frequent, or the occurs the most number of time. P1 is the most frequent choice, so P1 is the mode of our data set. So what does mode tell us? Well, not much other than the fact that P1 is the most popular choice among people. This kind of statistical analysis is useful when you're trying to perform some sort of an analysis of whether or not a particular product is popular among a particular group of people. Let's say that this was the result that we got from people of the age of 18 to 25. So a particularly young demographic likes the product P1 more. Now, if we were to, let's say, go the other way and ask senior citizens, let's say people over the age of 60, and if we were to ask them the same question, and let's say that the answer we get is, instead of me writing it out, we get P1 was selected by 2 people, P2 was selected, P2 was selected by 3 people, and P3 was selected by 5 people. Now, the most common answer in this scenario is P3. So this is what we try to understand using mode, which is the most popular. So if you're trying to figure out which product is more popular, what movie is the most popular among your friends, what kind of movies are most popular among your friends, what kinds of songs do a people of a particular country like, what kind of movies, songs, what kind of people, what kind of things, what kind of food, what kind of cuisine. These are the kind of things that mode helps us answer. So mode is very useful when you're trying to figure out most popular among a data set. Let's move on. So now that we know mode, the next thing we need to understand is median. So median is the middle of the data. So when I say middle, I mean if we are to lay out the entire result that we have in ascending order, median is the middle of our data. What does the middle or the value at the dead center tell us? So if the data is arranged in ascending order, then the data element that occurs right at the center is the median. So let me just show you. Let's say that instead of this, I have a particular group of people, right? And I want to calculate these people are arranged in the number of years of experience. So let me just try it, years of experience. And let's say that we have a data set that looks like this, 9 and 10. This is what we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the years of experience of people. 10 employees, all of them ranging from 1 to first employee has 1 years of experience, second 2, 3, 4. This is all arranged in ascending order. If you don't have that in ascending order, you can arrange it yourself. It's perfectly reasonable. It's like sorting a list. It's easy to do. And now let's say that I want to find the median of the data. To find the median of the data, what I can do is I can, for instance, take the middle value. So there are 10 values. I need to take the fifth value. But since this is an even number of results, I can't just take the fifth value, because if I take the fifth value, which is this one, there are 4 values on top and 5 values, 1, 2, 3, 4. Oh yeah, so that would be a problem. So for me to do that, 1, 2, 3, 4, 5 values at the bottom, that would not be an accurate mean. The accurate mean would be the average of the 2 values. Now if I take the average of 5 and 6, I will have to do 5 plus 6 divided by 2, which is 11 by 2, which is 5.5. And that is our median. That's the median that we get by choosing these 2 values. So we have 4 values above the median, 4 values below the median, and this average is 5.5. Now if I didn't have that, if I only had odd number of values, that is 9, 7, 3, something like this, then I can easily take the middle value, which is the fifth value. 4 values on top, 4 values on bottom. So that way we can distribute our data and understand what is the median of the data. Now, as you already know, that mode is useful for, yeah, so we're trying to find out the most popular thing in our data set. So median is used to, it's not extremely useful, but it's useful in very specific use cases. When we're trying to find out the middle value of, we're trying to find out the median or the middle value in a group of things. So here it tells us that the median, you've heard of median salary, you've heard of median household prices. So these are the kind of things that we calculate using median. So median tells us the middle value. Now we can compare them and contrast them to the end values and find out what is the how the distribution is. So to give you an example, let's say that I have 2, 3, 4, 5, and then that's 10, 15, 18, 25. Now the median value is 5 and the value at the end is 25. So we can compare and contrast that there are some people that there's a disparity between the number of people that have particular years of experience, and this is the kind of thing that median is useful for. Now, median isn't extremely useful. We don't use it for a lot of things. As you can see, it has a very niche use case, very particular use case. So we don't use median that much. And then comes something that we use a lot of times, mean. Mean is something that you must have all come across. It's a very popular statistical analysis tool. We all use mean in our daily life, even if we don't call it mean. So mean is basically the average of the data, or in simpler terms, it's the sum of all the values divided by the total number of values it's presented, and it's called the Greek letter sigma is used to represent the summation of all that. So let me tell you how to do this. Let's say we have this, and I wanted to calculate the mean of the value, right? So I had 2, 2, 3, 4, 5, 6, 4, 2. So this is what we have. Now I don't need to arrange it in ascending order to calculate the mean. Let's say that this is the years of experience in a new startup. So I get 2 plus 2 is 4 plus 3 is 5 plus 4 is 9 plus 5 is 14 plus 6 20 plus 4 24, and finally 26. So we have the cumulative sum is 26. Now we have 8 values. So if I wanted to calculate what does the mean of my data is, I need to firstly calculate the sum of the entire data set, which I have calculated to be 26, and the number of records I have is 8. So 26 divided by 8 is 3.25. So I get the mean of my data is 26 divided by 8, which is equals to 3.25. Mean is the average. We calculate average on a daily basis. We calculate the average income of a particular group of people, the average income in our household.
Just a quick info, guys. Test your knowledge of R programming by answering this question. Which of the following is used for statistical analysis in R language? A. Studio, B. R Studio, C. Heck. Comment down your answer in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
The average incentive we get, the average tip we leave, there's the average annual income of a particular substrata of a person, of a group in a country. We calculate averages on a daily basis. What is our average expenditure? How much do we spend in our entire month? So to give you an example, let's say this is the most common thing you can understand. Let's say that you spend this many thousands of rupees per month. Let's say 12, 14, 15, 18, 10, 8, 5, 18, 15, 14, 12, 10. Let's say that these are the expenditures of yours on a monthly basis in thousands. So you get 12 plus 14 would be 26, plus 15 would be 26, plus 10 is 36, 36 plus 5 is 41, plus 18 would be 41, 51, 61, 59. Then plus 10 is 69, plus 8 would be 78, plus 5 would be 83, plus 18 would be, let's say that the calculation of all of this is done and the average is coming across 150, right? Let's just skip the calculation for now. We get 150, and now we want to calculate the average that you spend on a monthly basis. So what you can do is you can just divide it by 12. So what we're trying to do is we're trying to calculate the average. So we divide 150 by 12, and what we get is 12.5. So the answer would be you spend 12.5 thousand per month on an average. And then you can take a look at the data and you can understand, okay, so this is fine, this is fine, this is fine. In the 4th month of April, you spent way more than your average. In the other months, you're spending somewhere across it. In the 6th and 7th month, you spent really less, and then you can take a look at the influences that month had. Maybe it was some party, maybe it was your birthday, and you spent a lot of money. So you can do these kinds of statistical analysis to understand where how do you spend the money, how does your expenditure goes, which month influences the majority of your expenses, which month influences the least of your expenses, and why is it so low in particular month and not in some other month. So it's very useful in those scenarios. Now, mean are of two types. First is the trimmed mean, second is the weighted mean. We'll take a look at them one by one. Let's take a look at trimmed mean. So trimmed mean is used to deal with outliers, data that is so far from what you do, one particular data that is really has a really high value that is influencing the mean of your data. So let's take a look at that. So to understand what trimmed mean is, firstly we remove some data from both the ends to get rid of the outliers. So let's take a look at that. Here we have our data set. Let's say that we get the same data set back, but let's say in the last 2 months, instead of 12 and 10, let me just get a new data set. So let's say that you spend less, you spend 5, 6, 7, 5, 5, 5, 6, 7, 9, and in the 6, 7, and the last 2 months you spend really high, let's say 20 and 25. Now if I were to calculate the mean, let us just calculate it one by one. 5 plus 6 is 11, plus 7 is 18, plus 5 is 23, plus 5 is 28, plus 5 is 33, plus 6 is 39, plus 7 is 46, plus 9 is 55, 61, and now we add 20 to it, we get 81. Now we add 25 to it, so we get 106. If we calculate the average or the mean of this, we would have to calculate it by 106 divided by 12, which is 8.83. So 106 divided by 12, which is equal to 8.83. Now that's the mean, but as you can see that the last two values, they are really high. Maybe this was just some sort of an anomaly that day, these months you needed to spend really more because you were traveling some other places, or you needed to shift your house from one location to another, and that's why it cost you so much. So let's say that this is just one time anomaly and this is not happening again and again. So but this is a large data set and you don't know whether that's the case, and this is influencing your data really badly. So to get the mean, what you can do is you can take off the first two values and take off the last two values as well, and you get only this data. So if I were to take this here and then calculate it, 7 plus 5, what is 7 plus 5? It is 12, plus 5, 17, plus 5, 22, plus 6, 28, plus 7 would be 35, plus 9 would be 44, and plus 6 would be 50. So here when you take a look at the average, it's 50 divided by, and what we have here is 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 values, and the calculation when we do it, we have 50, which is the sum. So 50 divided by 8 is going to be equal to 6.25. So that's the mean that we're supposed to have. The reason that we are getting 8.83 is because some expenditures are really high. So instead of it being 6.25, we are getting 2 point some value more than this, 2.5 thousand more than this, which is really high. So why did we scrape off the first two and the last two values here? Now this is a little difficult to understand. So what we're doing is we're getting the first two values, we're getting the last two values, and we're scraping it off mainly because the outliers don't need to be right at the bottom. They could also be at the top, and we want to just make sure that we're getting the center of our data. So let's say that instead of 5,000, it was 1 and it was 1. Now this could also negatively impact your data. So in order to get rid of that, what we do is we remove this, and what we get is 6.25, which is the correct value. Let me just remove all of this. Hopefully this was easy to understand, and let's move on to the next one, which is weighted mean. Now weighted mean is used to calculate mean of certain values where a certain value is supposed to have more importance or more value or more weight. Now it's used to calculate certain values that are supposed to count more in some context. Let's say that we're calculating the average of a grade of a student. based on the grade distribution. Now this is something that is done using weighted mean. Let me give you an example. So I prepared an example before so that I don't mess it up. Let's say that you have 3 quizzes in your entire academic year. The first quiz covers 10% of the syllabus, the second quiz covers 20% of the syllabus, and the third quiz covers 70% of the syllabus. Now, and then there's the final quiz, that's the final exam, we're not calculating that. Now what we're doing is we're getting these 3 values. Let's say that the weight of, you get whatever marks you get for the first quiz, you get the 10% of that mark. Whatever marks you get for 20% in your final grade, it would count as the 20% of your final grade. And whatever marks you get in the third quiz, the 70% of it would be calculated for your final grade. So if you were to get these marks out of 5, or let's say out of 4 or whatever, out of 5 of your average grade, then you will be getting 3.5 divided by 3 plus 3.5 plus 4, and 7 plus 3.5 divided by 3, which will get around 3.5, which is considered to be your average grade. Now we know that that is not the case because we have not taken these weights into account. We have not taken 10%, 20%, and 70% into account. So if we were to do 10% here, what we do is we take 10, we divide it by 100, which is the 10%, and then we multiply it by 4, we get 0.4. So out of 1 you got 0.4. So then you get 3.5, and then you get 3, and out of that you got 3.2. That's your average grade, not 3.5. So this is where weighted mean comes into play. This is not the only case that this is there. We can also take a look at other things like calculating the increment of a person based on the years of experience they have and many other factors. Many other variables come into place when we try to understand the averages of particular groups. So this is where weighted means come into play. And again, these have really specific use cases. So you need to take care of whether you to use weighted mean, to use trimmed mean, or very mean, mode, or median, depending on what you're trying to get. Mean is useful for calculating simpler means. If you have outliers in your data, you can use trimmed means. And if you want to calculate mean by giving certain values, certain more value, if there are certain data points that are more valuable than others, then you use weighted mean. So now let's take a look at variation, or variation in our data, to be more specific. So what is variation? Well, variation in statistics is used to show how data is dispersed or spread out in our data set. So several measures of variations are used in statistics, but variation is mostly used to calculate if we have a center of our data, if we have calculated the central tendencies, the mean, mode, and median, then how far away is our data points from the one that we have? How much is the variation? For instance, if we have a data set that most of its values are 4, then the variation is not that much because most of the data is 4 and the other values that we have are 3 and 5. So the data is quite compressed. So it's not extremely spread out if we consider it on a number line. On the other hand, if we have data set from 1 to 10,000 and every number has a value of 1, 5, 7, 4, 3, then it's very, very spread out. There's an extreme amount of variation. It's difficult to get sense of data like this. However, we don't get a data set which has that massive of a variation. We usually get data set that's a little more compressed. So let's take a look at how or what are the kinds of measures that we can take to understand the variation in our data set. So we have range, we have quartiles, and we have variance. Range, quartiles, and variance are a few of the ways that we can take a look at to understand the variation in our data. So quartiles are also known as quantiles. So if you come across this terminology, then don't be confused. They mean the same thing. We have range and we have variance. Let's take a look at them one by one. These are important concepts to understand once you're trying to interpret the data and understand how dispersed the data is, how different the data is, what's the variation, what's the variance, how much different is it from the mean that we have, how far away is one data point, or how likely one data point is to be far away from the mean of the data or the center of the data. Let's take a look at range first. Range, as the name suggests, is quite easy to understand. Range is the difference between the highest and the lowest value in our dataset. Range tells us the difference between the lowest and the highest value in our dataset. So let's take a look at that, because sometimes people get confused with what range means. Let's say this is the data and we have 5, 10, 12, 11, 2, 5, 1. Let's say it's 10, 11, and 15. So this is the data that we have. Now to do that, firstly we have to calculate the minimum and the maximum value. This is easy enough. You just go from top to bottom calculating the minimum and the maximum. Right now both are 5. Maximum is 10, minimum is 5. You keep going and you find minimum is 5 and maximum is 10. So when I ask people, sorry, maximum is 15. So when I ask people what the range of this data set is, many people get confused and they tell us the range is from 5 to 15. Now, if you are taking the word range quite literally, then this is exactly what it means. 5 to 15 ranges between the values of 5 to 15. However, in statistical sense, this does not make a lot of sense. So in statistical analysis, the way we do it is we go 15 minus 5, maximum minus minimum, highest value minus the lowest value, and we get 10. So this is the data that we have, and this is the range that we have, 10. So this is what we have. This is the range of our data. Now, as you can see, range isn't the most optimum way of doing it, or finding the deviation, or finding the spread out disperseness of our data, mainly because if the data has outliers, then range gets skewed quite easily. We have 15. Now, if I want to calculate the range of a data set that has 95, now the range of our data is, it looks like 5 minus 95, which is 90. So you would think that the data, whatever the starting point of the data is, it would have values ranging from the starting point plus 90. So if starting point is 5, which is the lowest value, plus 90 is 95. However, majority of our data lies between 0 and 12, 0 to 15, let's say. And only one data point, which is the outlier, is 95. So this could negatively impact our data really, really badly. So this is why range is useful, but once we make sure that the outliers are not there and the data is completely standardized, which is a little difficult to do. However, range is still useful for smaller data sets like the one we are seeing here. Now the question comes that what does range tell us? Well, it tells us the width of our data. It tells us quite literally the range, the width of our data, how many, what is the range, what is the disperseness of our data. So if we have a data set that has higher number of variations, let's say that I have 1 million records, but all the values range from 5 to 25. Yeah, Excel is causing some issues here, never mind. So you get 5 to 25, right? 5 to 25, I don't think it was, yeah. So let's say that this is the range that I get. So 10 million records, 10,000, let's say 10,000 records, and the range is from 5 to 25. So you can easily understand that this data set is really concise, it's really clustered. So the range is quite small, range is 20, 25 minus 5 is 20. Now again, if we had the same thing, but the range was not from 5 to 25, it was from 5 to 5,500. This is a problematic thing because now our range becomes from 5,495. This is our range now.
Just a quick info, guys. Intellipaat provides online data science master's program in partnership with IBM. The course link of which is given in the description below. Now let's continue with the session.
So as you can see, here the data set is quite dispersed. Assuming that these are not outliers, 5 to 55,000 are normal range of numbers, and numbers are equally distributed across this range. Then we have a really wide variety of data set, and it's got a really large set of variation. But here we only have 20 value. We have only the width of 20. Here we have massive width. It's 10, even more than 20 or 20 times more than what we have here. That's a problem. So we need to understand why we use something like this. It's because we needed to take a look at what's the variation, and this is only good. This is a really simplistic measure, but it guides us in the right direction. So that's why we use it. So let's move it to the next direction. We look at percentiles. Now, to be quite honest, percentiles are not really something that we use to calculate the range of the data, but when we are moving on to quantiles or quartiles, there we use percentiles. So it's important to explore what percentiles mean. If you're studying in a university, if you've studied in any sort of university, you've gotten a percentile score sooner or later. You come across this score in your schools as well, or especially in colleges and universities, the percentiles are used. Or if you want to take a look at percentiles used at other competitive exams as well, so that's where they are used. Now, percentiles are scores that are used to describe the value below which some observations fall. Now, that's a very vague definition, but it's quite accurate. I'll explain to you in a moment using an example, but to understand it right now, just take a look at the example that we have in the text format. If X is the 70th percentile, let's say that you are a person who's gotten a result, and at the bottom of your result, it says, congratulations, you've achieved the 70th percentile. That means that 70% of the other data points, you could think of it as 70% of the other students who took the same test that you did were below you. So you are above 70% of all the people that you took the test with. So to give you an example, let's say out of 100 you scored 95. Now, when you hear the word out of 100, many people think that out of 100 I scored 95. That means I got 95%, which is correct. But then they think they got 95th percentile as well. Now, that is incorrect, mainly because it doesn't matter what the score is or how much you got it from. What we're trying to calculate here is not what the percentage is. That's what we use the percentage for. In the percentile, we're taking a look at how many people you've gotten more numbers from. So let's say that there are 100 students in your class and you got the 5th rank. That means, or you can say you got the 4th rank. That means from rank 1 to 95 are below you. So you've got the 96th percentile. 95 people are below you. That's what percentiles mean. Percentiles are used to calculate how better are you compared to the rest of the people in the sample. Rest of the data points in the sample is you, or rest of people, depending on what the data is all about. If you have a drug or you have a potential vaccine, and we take a look at how many people have, let's say there are 5 vaccines, and since there are 5 vaccines and you have one vaccine that scored the 4th highest, so if you take a look at it, that means that you are 80% in the 80th percentile. 5 people, or 80% of other records are below you. So that's what this means. Depending on what data that you have, you can take a look at percentiles, you can understand what that means, but this is what percentiles are useful for. Now, why are we learning percentiles if they're not a part of calculating the variation or variance in the data? Mainly because it's not just percentiles that are useful, but we use quartiles. Quartiles are extremely useful. Ask any statistician that you can come across. Quartiles are used on a daily basis. So let's try and understand what quartiles are, and we'll take a look at a few examples along the way as well. So quartiles are used to break the data into 4 parts, so as to better find the spread of the data in a way that is not that influenced by outliers. So if you have some data and you're afraid that outliers might skew your data, what you can do is you can choose a quartile method that will tell you approximate answers. And you've already calculated one of the 3 quartiles that we calculate, and I'll show you what that means in a moment. Let's take a look at that. So quartiles are used to calculate the, firstly, there are 3 quartiles. Q1 is the first quartile, Q2 is the second quartile, Q3 is the third quartile. Quartile 2 or Q2 is the 50th percentile. Just calculate it. The quartile 3 is the 75th percentile, and quartile 1 or Q1 is the 25th percentile, right? So now the question comes, what does that mean? Let me show you with an example. Let's say that we are calculating height of people in centimeters, right? So we are arranging that in a format. So let me just take it away from here, paste it here. This is just for our reference. Let's say 144, 155, 156, 157, 158, 159, 160, 167, 170, 171, 172, Let me just remove these two. So let's say that there are 9 records and we want the 50th percentile. 50th percentile would mean that 50% of the data is above and below it, and we're right there. So in this scenario, 50th percentile, as you can, if you try to think about it, it's the median of the data. This is what I meant when I said that you have already calculated the one of the quartiles. So when we're trying to calculate the 50th quartile, what we're trying to do is, firstly, we have arranged it in ascending order. We take all the records, we take a look at the number of records, we have 9. Right in the middle would be this, and this is the 50th percentile. So Q2 lies here. Now, as you can see, we have 4 records below, which is approximately 50% of the records below our percentile. So that's what this means. So this is what Q2 is. Q2 is the second quartile. Now, how do you calculate the first and the second quartile? We can do it like this. Now, let's take a look at this. Don't think about this range. Just think that this is removed like this. And we're trying to calculate the quartile in this range. Okay, so in the range from 0 to 4 above the first quartile, the way we calculate it is we take a look at the number of records. It's an even number of record, which is 4. 4 divided by 2 is 2. These are the 2 records that are in the middle. Now we can't just choose one for the quartile. Instead of calculating the median, the quartile is considered to be between these two. So these two values are considered to be a part of the first quartile, not the third quartile, but the first quartile. Similarly, these two are considered to be part of the third quartile. So the third quartile lies here, second quartile lies here, first quartile lies here. So now if we are to understand what quartiles are, they are a way for us to understand our data you can think of it as range, but a little more subservient to outliers. So we don't have to worry about outliers that much. This is the third quartile, this is the second quartile, and this is the third quartile. We get 3 data points and we understand which one is used for what. Now the question becomes, what happens if we have an even number of data? So let's say I will paste this here. Let me just remove the quartiles. And now we have to calculate the second quartile. So we have 2, 3, 4, 5. So these two will be part of our second quartiles now, because we have even number of data. And this is, if you want to calculate the median, then sum them up and then divide them by 2, it would be 159.5. So this is the second quartile. The first quartile would be 1, 2, 3, 4, 5, and so first quartile would be here, and the third quartile would be here. We just take a look at the numbers between them and find its median. We find the numbers above the second quartile, we find its median. That's the first quartile, that's the third quartile. That's what we mean by quartiles. So that's how quartiles are calculated. They are easy to calculate. They give us a better indication of how our data is spread out. Much better than range. They are less prone to outliers. Unless your data is so dispersed that outliers are really easy to catch, then that's a problem. Now that we're done with quartiles, now quartiles are expressed in percentiles. So first quartile is the 25th percentile, which we have already seen. Second quartile is the 50th percentile, which is also the median, which we just saw, and the third quartile is the 75th percentile. So again, let's take a look at the data to make sure that we understand it correctly. 75% of the data is above this, 50% of the data is below this, 50% of the data is above this, and 75% of the data, or 25% of the data is above this. So that's how we calculate quartiles, and that's why percentiles are useful when understanding quartiles. Now let's take a look at interquartile range. So we had range before, but it was very easy to get influenced with by outliers. So the range was very much influenced by the outliers, but interquartile range is a little different. Let's take a look. Interquartile range is the difference between the lower and the upper quartile, that is Q3 minus Q1. This gives us a better idea of the range of the data. So this helps us understand how our data is spread out, and it's not that influenced by the outliers. So if we have this, we get this. Now we have 170 as the third quartile, we have 156 as the first quartile. So if I had to calculate the interquartile range, I would just do 170 minus 156. So 166 and 4, 14, and we have 14 as our interquartile range. So this is how much our data is spread out between our quartiles. If this is a massive difference, then our data is really spread out, and if it's not a massive difference, then it's not that massively spread out. That's the first thing. Now, many people think that median could be used to do the same thing. That's not really the case. We're trying to look at the extreme ends of our quartiles and find the distance between them. That's what tells us how spread out our data is. If this was a large data set and the quartile was 140, then we could probably understand that our data set is very widely spread out, or more widely spread out than it was when it had 14 as its interquartile range. So it's a really good measurement, but it's less influenced by outliers. Outliers are really the things that we need to watch out for when we're trying to calculate range of any sort, whether it's the interquartile range or the simple range. This is why we use percentiles, because percentiles are not that influenced by interquartile ranges. They help us understand what we're trying to do, and they give us a more accurate representation of the data that we have at our hand. If we were not using percentiles, then our range would be 144 minus 170, and since there are no outliers, it's fine. But let's say the outlier was 198, or even not 198, 222, or let's say some crazy number, 568. Now, even though there's an outlier, my range is perfectly fine. Let's say that the outlier here was 14. So it could be because of incorrect measurement. It could be that generally is an exceptional case in our data set. So that could be it. That's our data set. That's what interquartile ranges are all about. Let me just delete that for you. And let's take a look at something else. So now let's take a look at standard variance and standard deviation. So this would be the first time we'll be using a mathematical formula to calculate something, and it won't be very difficult. We'll take a look at what that means and how to calculate it and what that signifies in a moment. Firstly, let's understand what is standard variance, what is deviation, and why are we taking a look at them simultaneously? Why not one by one? Well, standard variance measures how far a set of number is spread out from their average. Standard deviation is used to express.
Just a quick info, guys. Test your knowledge of R programming by answering this question. R functionality is divided into a number of dash A. Packages, B. Functions, C. Domains. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
The magnitude by which the number of a group differs from the mean for the group. Now, it's a little difficult to understand, but when you take a look at the formula, you can understand why we are using them one by one. They're the exact same formula. The only difference is that standard deviation is the square root of standard variance. So when we calculate standard variance, when you take the square root of standard variance of a particular data set, you get standard deviation. So the way we are calculating it is, first of all, standard variance is denoted by S square, which is the square of standard deviation. So what we do is, firstly, we calculate the mean, which is recognized by X bar. So let me just show you. When you take a look at this, so this is what is called X bar. X bar is the mean of the data. So we calculate the mean of that data. We calculate the difference between the mean and one particular row of data. We calculate their square, and then we sum it up. So when you see this symbol, which looks like a perpendicular M, or M that's rotated 90 degrees, it's called sigma. It's used to calculate the sum of a particular group of data. And n minus 1 means whatever number of records we have minus 1 from them. So that's what it means. Now now standard deviation is exactly the same thing. As you can see, we have sigma, which is the summation, we have x, we have negative or minus symbol, we have X bar, which is the mean, we calculate the square, we calculate the difference, we square it up, we sum it up, we divide it by the number of values minus 1, and then we take the under root. That's the only difference. So when we take a look at the standard deviation and standard variance, the only correlation or relation between them we find is the, you can take a look at the square root. Now, one thing to understand is that standard deviation and standard variance are quite useful because they are one of the most used tools to understand how varied our data set is. This is why we use standard deviation and we use standard variance. So as you can see, this is for, as you can see, the formula says sample variance and also says sample standard deviation. So what does the word sample represent here? If you think about it, we have already discussed sampling our data and getting a small sample out of a large population. Now, for various statistical reasons, people have started to use n-1 for sample variance, and for population variance, when you're calculating the variance in the entire list that you have from which you selected the sample, you don't use n-1 as the denominator, but you use n, simply n. Now, it's not going to be a huge difference, but since we're taking a small part of it, we correct for it by reducing the number of samples. So that's what it means. Now, if you're using standard deviation, standard variance for a population, then you use not n-1 as the denominator, but n as the denominator. Other than that, it's the exact same thing. So with that in mind, let's take a look at an example. I have already created some data and we'll take a look at them one by one. So this is the data that we have. First thing we have to calculate, if we take a look at the formula once again, is we have to, we're calculating the mean of the data first. So to do that, let's just calculate the mean. Mean would be, and to calculate the mean, we first need to sum it up. So let's take the sum of the data. 5, let me just move this a little aside so that I can do a cumulative sum and understand what the data is. 5 plus 7 is 12, plus 4 is 16, plus 4 is 20, 28, 36, 45, 45 plus 7 would be 52, and plus 8 is 60. So this is our sum. We get 60 as our sum, and mean would be 6. Since we have 10 data elements, the mean would be 60 divided by 10, which is 6. So we've gotten 6 as our mean. So now we need to calculate x minus mean. Let me just remove this. This was just for our convenience. Cut this, paste it here. Here we have what we have. So x minus mean would be 5 minus 6, which is negative 1. 7 minus 6, which is 1. 4 minus 6, negative 2, negative 2. 8 minus 6 would be 2, it would 9 minus 6 would be 3, 7 minus 6 would be 1, 8 minus 6 would be 2. So now we need to calculate the square of it. Square of 1 is 1, square of 1 is 1, square of 2, negative 2 is 4, square of negative 2 is 4, square of negative, so square of 2 is 4, same as negative 2, 9, it's 1. Now for some reason Excel is giving me some error, so I'll just write 1 like this, and 4. This is what we have. Now what we need to do when we take a look at the formula again is we have this symbol called sigma. We've calculated the mean, we have calculated the difference, we have calculated the square of the difference. Now we need to move a step out and we need to sum it all up. Let's do the summation. To sum it all up, we just need to go from the top. 1 plus 1 is 2, 2 plus 4 is 6, plus 4 is 10, plus 4 is 14, 18, 28, plus 4 is 32. So this is what we have, and finally what we need to do to calculate this standard variance is n minus 1. So n in our case is 10. Variance would be 32 divided by 10 minus 1, which is 9. So to calculate the sample variance, all we have to do is we need to just calculate 32 divided by 9, and we get 3.5 as the result. 3.56 is actually the result, but let's just call it 3.56. So that's the result that we have as of now. Now, if this was the entire population that we were calculating the result from, then we would go 3 by 32 divided by 10, which would be 3.2. But as of now, we are calculating the sample one, and mostly this is the one you'll use to calculate the sample deviation. After that, all you have to do, we have calculated the variance. Now the deviation would be the square root of 3.56. So to calculate this, all we have to do is calculate the square root of 3.56, which is 1.8867. So we could calculate 1.89. And there you have it. You have 1.89 as the standard. Let me just write it. Standard variance and standard deviation. So this is how you calculate standard variance and standard deviation. In case your data was really spread out, then this would not be the number. You will get some large number like 12.5 or something like this. So if you wanted to calculate the variance of two data sets, then you can calculate it using this. Now, why is it useful? Let me just remove it all. In case you wanted to take a look at it again, you can just take a look at it now. I'll be removing it now. So why is it useful? Because it helps us understand our data more. Let's say that I have data that has 5 records. All of them are 5. The mean of this would be 5. Another data set that I have, let's say here I have 4, 4, 5, 6, 6. Calculate the mean of this. 6 plus 6 is 12, plus 8 is 20, plus 5 is 25, divided by 5 is 5. Now the mean is the same thing, but the data is not the same because we have difference in data. Now this is a really small difference, so that doesn't really matter, but this is what it means. To calculate a standard deviation of this, we'll get 0, and for this we'll get something along the lines of 1 or something like this. So as you can see, standard deviation tells us the missing part of the story that the mean could not tell us. It tells us that how the data is spread out across the mean. So if it's just everything in the data is just as same as mean, then you get a standard deviation of 0. Else you get a standard deviation greater than 0, standard variance greater than 0, and you can just calculate the under roots and all that to calculate the variances and deviations from the standard data set that we have. Okay, so now that hopefully you've understood what standard deviation and standard variance is. For most cases, we calculate the n minus 1 using the sample variance formula, not the population variance formula. We use the n minus 1 as the denominator. And to calculate the deviation, we simply calculate the square root of sample variance. Now, if you have standard deviation and you want to calculate the sample variance, just square it and you'll get the same result. So that's what that means. Now let's take a look at correlation. So correlation is something that you might have come across many times in your life. Correlation is a term that is used to measure the strength of a linear relationship between two quantitative variables. Now, this is a very jargonistic definition, so let me break it down for you. Suppose you're trying to calculate, suppose you have a data set in which you have your height and your age. So as your age increases, your height is also going to increase. So that is what is known as a positive correlation. So this is what we're trying to calculate. Correlation is calculated as in terms of correlation coefficient, which is basically a number from -1 to +1. And we'll take a look at what that means, but this is what the formula looks like, as you can see down here. Let me just, yeah. So this is what the formula looks like. Now, some of it might look familiar to you, some of it might not. So let me just show you what that means. So this is the summation symbol, the sigma symbol that we have already seen. It means sum up whatever I have on the right of me. So what we have is x minus x bar. X bar is the mean of x. We're trying to calculate the correlation between x and y. These are the two variables. This is why we get this correlation coefficient r and subscriptive x and y. So the correlation of x and y is equal to summation of x minus x bar, which means just as we calculated standard deviation, what we need is the mean of x, and we want the difference between each individual observation and the mean. So we do that and we calculate the sum of that. We calculate y minus y bar, which is each individual observation for y and difference between its mean, and we take the product of those numbers and then we sum them up. How does that work? We'll take a look at that in the example that we have, but as of now you need to understand that this is what is happening. Then underneath it, we're doing quite similar thing. We sum up the x minus x bar whole square. So we take the difference between the mean and individual observation, we square them, and then we sum them up. We do the same thing for y, and then we calculate the under root of that or square root of that. So this summation of x minus x bar whole square looks like the standard deviation of x, and similarly standard deviation of y. So this is what we're trying to do here. Now, the formula is quite simple, but the idea that correlation is trying to get across here is not that what the formula is trying to say. The idea that we're trying to get across here is what is correlation and why we use it. So correlation basically allows us to check whether one variable has any influence on the other variable. Does increase in one variable lead to an increase in other variable? And if so, then how strong is this correlation? If it's really strong, that if I increase one variable by some degree, the other variable will be increased by that degree as well. If it's negative, then it will be decreased, and we'll take a look at what that means and why that's useful here as well. As of now, let's take a look at the example. One other thing that I'd like to mention is that it's a linear relationship. That means linear basically means a straight line. So basically what it means is that if I were to create a scatter plot out of this, and if I were to draw a straight line from right between the scatter plot, then that would show if the scatter plot is following that line, that means there's a strong correlation. So we can also take a look at that as well. So let's take a look at the formula and let's try and implement correlation here. And this is the data that we have. Now it is a little overwhelming to take a look at. I've done most of the calculation for you so that you don't have to see me do these calculations by hand all by one. So let me just explain what this means. Let's say that we're trying to calculate the temperature and price of a product. So temperature is the temperature outside, and price is the product that the amount of product that was sold at a particular temperature. Instead of it being price, let me just call it amount. Now it makes sense, and let me just expand this column so that it makes sense. Now temperature is x and amount is y. We're trying to calculate as does increase or decrease in temperature have an effect on the amount of items sold at a particular day. So these are the temperatures. These are the amount of prices that we have sold. So if I have a higher temperature, does that mean that more of this product is going to be sold? Is going to be sold? Let's take a look at that. First things first, we need to calculate the mean of x and y, which we have already done. So the mean would be if we sum it all up and then divide it by, in this case, 12. Similarly, if we sum it all up and then we divide it, let me just do it, and then we divide it by 12. The mean of x, which is x bar, is 18.7, and mean of y, which is y bar, is 402. So hopefully mean is easier to you to understand. It's the average of the data that we have for each point. So for x, or for the temperature, 18.7 is the average temperature. For y, or for amount, 402 is the average amount that's sold across the entire data set. Now what we do is we calculate x minus x bar. Here, instead of writing x bar, I've written mean of x because it's more easier to understand. So what we're doing is we are taking x, which is 14.2, and subtracting the mean, which is 18.7. So 14 minus 18.7, 14.2 minus 18.7, as 14.2 is smaller, we get negative 4.5. Similarly, 16.4 minus 18.7, we get negative 2.3. And you keep going down and you see, since 11.9 is small, we get negative 6.8, negative 3.5, negative 0.2, since it's just 0.2 away from the mean, which is 18.7. And then we come on to the positive side. So since 22.1 is greater than 18.7, we get 3.4, 0.7, 6.4, 4.7, negative 0.6 because 18.1 is smaller than 18.7, 3.9, and negative 1.5 again because 17.2 is smaller. Now we will take care of the negative part of it, but firstly we need to calculate all of this. This is calculated for the temperature. Now let's calculate it for the amount, which is y, which is calculated in this column. So the mean is 402, and if we subtract 215 from 402, we get negative 187. Similarly, negative 77 for 325, negative 270, negative 70, and finally 406 is just 4 more than the mean, which is the difference that we were looking for. Then 120, 10, 212, 142, 19, 43, and 6. So these are the observations minus the mean of the data that we have. We don't need to sum them up as of now because that won't be necessary. If we take a look at our formula again, We don't need the sum of individual columns subtraction from the mean. We need the sum of that product. So now we calculate the product. We go on this side, x minus mean of x, which is this column, multiplied by y minus y of mean of y, which is this column. So we multiply negative 4.5 by negative 187. Let me just show you that that's entirely what we have done. Okay, let me just open up calculator. We have negative 4.5 multiplied by let me just take a look at the scientific calculator, because in Windows for some reason this does not work. So 0 minus 4.5, which will be negative 4.5, multiplied by 0 minus, and we have 187, so 187, and we have 841.5, and we just round it up to be 842. I have unfortunately opened up something. I need to close it. Okay, now that is done, here we have it. So we have calculated this. It's 842. When both of them are negative, then we get a positive result. If one of them is negative, then we get a negative result, and if both of them are positive, then also we get a positive result. So we have 842, 177, 1476, 245, negative 1, 4087, 1357, 667, negative 11, 168, and negative 9. So all of these values are calculated using this. As you can see, 6 multiplied by 1.5 is 9, and it's one of them is negative, so we get negative 9. We do need the sum of this, because as we look at the formula, we have summation of x minus x bar multiplied by y minus y bar. This is how the formula gets interpreted and expressed. We calculate each individual term, and then we move outwards. We calculate x minus x bar, we calculate y minus y bar, we multiply them, and then we move outward and sum it up. So this is 5325. Then we move on to square them. So why are we squaring them? Mainly because in the denominator we need the square and the under root of the square. So we go there, square it up. Again, squaring anything, whether it's negative, whether it's positive, all of that is going to lead us to a positive result. So we do that. X minus a mean of x will be the thing that's squared, which is this one. So negative 4.5 is squared. We get 20.3. We get 5.3, 46.2, 12.3, and it's negative 0.2. If we square it, we get 0.04, which is approximately 0, so we take it as 0. 3.4 square is 11.6, 0.7 is 0.49, which is approximately equal to 0.5, so we take it as that. 41, 22.1, 0.4, 15.2, and 2.3. So all of that is done. Now we do the same thing for y minus mean of y, or y minus y bar. Again, taking a look at the formula, we see we need to calculate y minus y bar whole square sum as well. So for that, we need to calculate y minus y bar. And we calculate it. We get this huge number, 34,969, which is approximately equal to 35,000, but for the sake of clarity, we're keeping it precise. 5,929, and these are the whole large numbers that we get by squaring these numbers. And as you can see, these numbers are pretty large, so when we square them, you are going to get huge numbers like that. And finally, square of 6 is 6. We get that, and we sum them all up again. Sum of x minus x bar whole square would be 177. Sum of y minus y bar whole square is 1,74,557, or 174,757, depending on where you are. So now what we need to do, we need to calculate the entirety. Here's what we have. We need to divide x minus x bar and y minus y bar whole y minus y bar sum, which is this. We need to divide 5,325 by the under or square root of the product of 177 and 1,74,757. Why is that? When we take a look at the formula, summation of x minus x bar whole square, summation of y minus y bar whole square, we need to multiply both of these values, and then we need to take a look at the under root, and then we need to divide it by this. So let's take a look at that. Let me do this in this format. We have 5325 divided by the under root of, okay, so this is not working. Let's just under root the summation. So 177 multiplied by 1,74,757. This is going to be a big number, and this is what we get. We take the under root of it. It's somewhere close to what we have already, so we can see the number is going to be somewhere around 1, and we take 5,325 and then we divide it by it, and we get 0.957. So the correlation we're getting is 0.957. So this is our correlation, and yeah, this is our correlation. We're getting it by dividing this. Let me just write it out. 5,325 divided by 177 multiplied by 1,74,757. So this is the calculation. This has led to this result, which is our correlation. And here we are. So as you can see, this is a really mathematically intensive computation. We had to calculate a lot of things based on these two values. So suppose we have a really large data set, then that would be really difficult for us to calculate. This is precisely the reason why we don't use these the entire population, and we take a look at a small subset, which is called the sample, and then we calculate the statistical analysis using the sample of the data. So this is what it means. As you can take a look at it, it's pretty easy to understand. It's not that difficult. We have again, let me just reiterate what we did, because it could be a little confusing. We have temperature, we have the amount. We want to calculate whether or not this influences this, and for the result that we've gotten, it strongly positively correlates with the temperature. So if the temperature rises, the amount of the item sold would be rising as well. If the temperature decreases, then the amount of product being sold will decrease as well. If this was negative 0.957, then that would be opposite. As the temperature increases, the amount of product sold would be decreasing, and as the temperature decreases, the amount of products sold would be increasing. So now let's take a look at what we did. Just to reiterate so that you can understand, what we do is we take these values. This is x, this is y. We need to calculate the correlation between x and y. Now calculate the mean of x, calculate the mean of y, because in the formula it states that we need to calculate the mean of y and mean of x so that we can calculate the other values. Now calculate another column in which we take a look at the observation magnitude of a single observation minus the mean of that column. So here we get these values. Similarly for y, we do the same thing and we get these values. We don't need to sum them up. We move along, and then we need to multiply these two values to get the final value that we need, and then we sum it up. Here is what we have. Then we move along and we get the square the mean of the observation minus the mean of the observation, mean of the entire column, and this is what we get. For that, we calculate the sum of that. We do the same thing for y. We calculate the sum, and finally what we do is we plug all the values that we have calculated so tirelessly, and we plug them into the formula, and here's the number we get. To reiterate, the number is going to range from -1 to +1. This is what we'll be getting at. So this is -1 to +1 is what we'll be getting. Do you want so this is what we'll be getting. I think Excel was having some issues there. So this is the numbers that we'll be getting. No correlation coefficient will go beyond -1. No correlation coefficient will go beyond +1. To get complete one correlation is you want to correlate one column with itself. So if I had a column that had three values, 10, 12, 14, another column it had the same values, 10, 12, 14, and if I have to find the correlation of these two, this would be +1. So this is what it means. Okay, So we find the correlation. If it's somewhere close to 1, then it's highly positive correlation. If it's somewhere close to -1, it's highly negatively correlated, and so on and so forth. And we'll take a look at what that means in a moment. So this is how you calculate these things. This is how you interpret it. It's a lengthy calculation, I will admit, but it's easy to do with calculators, or sometimes a program will do it for you. But for a large data set, doing this is going to be a little difficult. So with that in mind, let's move ahead and see what else we have. So now that we have done correlation, let's take a look at positive correlation. So positive correlation is a term that is used to describe a positive linear relationship between two quantitative variables. So we have positive, negative, and no correlation. These are the three kinds of correlation that we have. Positive correlation is used to describe a relationship that we just saw. As the temperature increases, the amount of the product sold increases. Let's say that the product is ice cream or some sort of cola, some sort of soft drink. So things like these increase their sales when the temperatures increase. Similarly, their sale decreases when the temperature decreases. So this is how you calculate that. This is what positive correlation actually means, that it increase in one aspect is going to lead to an increase in the other aspect of your application. So with that in mind, let's take a look at no correlation. So no correlation describes no linear relationship between the two quantitative variables. So suppose we find the correlation between them to be 0.1, negative 0.1, 0.2, negative 0.2. This is really low correlation. And for us to, we don't really have to think about that kind of correlation. That's not really significant correlation. So we can term it as no correlation. That is to say that this has no impact on X has no impact on Y, or Y has no impact on S. To give an example, let's say the height of a person, does it have a correlation with the mood of a person? How does a person feel? Well, there's no significant interpretation that could lead us to believe that yes, this does happen. So that's no correlation between X and Y. If X was the height and Y was the mood, or X was the height and Y was the income, then that would be no correlation. So similarly, we have negative correlation. So
Just a quick info, guys. Test your knowledge of R programming by answering this question. Which of the following is used for statistical analysis in R language? A. Studio, B. RStudio, C. Heck. Comment down your answer in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
in negative correlation, what we have is we take a look at the negative linear relationship between the two quantitative variables. So to give you an example, as the age of a person increases, their bone density decreases. So this is what is known as a negative correlation. Increase in one quantity is leading to decrease in another quantity. When we find the correlation coefficient for these two variables or these two values, it's going to be somewhere around negative 0.7, negative 0.8, negative 0.9. Above negative 0.5, it could be considered strong, and as close as it gets to negative 1.0, it's considered to be that strong of negative correlation. If it's really strong negative correlation, that means slight increase in one would lead to slight increase in the other. It would be proportional in inversely proportional relationship, if you can think about that in that manner. Now we've understood this, but one other concept that I'd like to introduce to you before we move on from correlation is the topic of causation. So I'm just opening this up so that you can take a look at something else. Correlation is not equal to causation. That's a really important aspect to understand. Just because we randomly select two values, we calculate the correlation, and that means that and they have really strong correlation between them. That doesn't mean that increase in one is the exact thing that's leading to increase in other thing. That could be purely coincidental as well. So we need to understand this. We need to take this into account when we're trying to deal with negative and positive correlation. So to give you an example, let's say that you're trying to, let me just go down here. Let's say that you're trying to calculate the correlation between.
Just a quick info, guys. Intellipaat provides online data science master's program in partnership with IBM. the course link of which is given in the description below. Now, let's continue with the session.
Temperature and stocks. STMCKS. Sorry, I misspelled it. Now, if I'm trying to calculate the correlation that temperature and stocks have, let's say that the correlation comes out to be 0.7879, right? That's a strong positive correlation. But does that mean that increase in temperature is leading to increase in stocks? No, of course not. That would not be a substantial evidence for any kind of thinking. So even though you get positive correlation out of two variables, that doesn't necessarily mean that you're going to get that means that one variable has strong influence over the other. If it's in a controlled environment, you need to take a look at a lot of things. You need to firstly take a look at the variables. You need to take a look at what they mean, how they go, how might they influence each other. If they do have positive correlation, then you take a look at whether or not that positive correlation indicates some sort of influence of one over the other or something else. So all of that is taken care of by correlation. That's why we need to understand correlation. That's why we need to use correlation in a way that makes most sense. So if this was negative 0.79, it would be the same thing, mainly because we don't know, because even though it indicates strong negative correlation, that doesn't mean that it's equal to causation. That's the reason that it's causing the stock markets to decrease or increase. So with that in mind, let's take a look at what else we have. Just move it up. So we've taken a look at positive correlation, we've taken a look at negative correlation, and we've taken a look at no correlation. Positive correlation means increase in one value is leading to increase in another value. No correlation means increase on one value or decrease in one value has no impact on the other value. And negative correlation means increase in one value is leading decrease in other value. Correlation ranges from -1 to +1. And one other thing that I forgot to mention is that this the correlation coefficient that we're trying to calculate has a special name. It's called Karl-Pearson correlation coefficient. So it's called Karl-Pearson's correlation coefficient. There are other correlation coefficients as well. There's something called Spearman's rank correlation, in which you try to find the correlation between the ranks of particular things. If you rank it from 1 to 10 based on their magnitude and so on. So if you're trying to find correlation between these kinds of things, then take a look at Spearman's rank correlation. Let me just write it out. Spearman's rank correlation. I guess you can see it. Now that's why we use that. And this one was Karl-Pearson correlation. This is by far the most widely and commonly used one. So now let's take a look at normal distribution. Normal distribution is quite an important topic in statistics. If you're tried to study statistics before, you might have come across this topic as well. And this has to do with the distribution of the data that we already have, the shape of the distribution, and what does it tell us. So normal distribution is a term that is used to describe the distribution, which when plotted gives us the shape of a bell curve. So if you've ever taken a look at a bell, it looks like this. This is sort of like a dome shaped. This is what it means to have a bell curve. As you can see, the first image or the first sub image in the image is negatively skewed. It's not entirely a bell curve because it's tilted or skewed slightly towards the right. So that's a negative skew. And similarly, the third image is positively skewed because it's tilted or shifted to the left hand side. So it has a mean of 0 and standard deviation of 1. Now mean of 0 is a little difficult to understand. So mean of 0 is just an assumption that we make. It's not necessarily the case that the mean has to be 0. It's just the mean is in the center is what it's trying to say. And everything on the left is in negative and everything on the right is positive. That's also an assumption. But the standard deviation of 1 basically means that we can express our data more clearly. We'll take a look at what that means in a moment. Firstly, let's take a look at what it means. If you take a look at the images that we have right at the bottom, you can see that it's a distribution of frequency and data. So when you take a look at this in the normal distribution where there is no skew, both mean, mode, and median all fall on the same axis. That's also an assumption. It's not necessarily the case that they will fall on exactly the same axis, will be the exact same location. There would be slight deviations, but mostly they'll be very close. On the other hand, positively skewed mode is on the leftmost side, then there's median, and there's mean. And as you can see, most of the data is on the left hand side of the mean, and very less of the data is on the right hand side of the mean. And quite similarly, we have data in which we have everything on the left hand side, and on the 50% of the data is on the left hand side and 50% on the right hand side. That's the normal distribution. And with the same thing, very less of the data is on the left hand side and very much of the data is on the right hand side. That's why it's the negatively skewed data. So this is what normal distribution means. So that's what it means, but what does it matter how the data is skewed? Well, as it turns out, it matters quite a bit, because if your data is negative, if your data is distributed normally, then there's a lot of assumptions that you can make. There are a lot of formulas through which you can essentially calculate the probability of randomly choosing a data and getting it in some part of the distribution. So let's take a look at that. There's this what is known as the empirical rule. The empirical rule tells us the exact same thing that we just said. So let's take a look at what that means. Let's take a look at the empirical rule. So as you can see, it's the same image that we had for the normal distribution. Let me just show you. If you take a look at the normal distribution, it's completely bell curved, and mean, mode, and median are right at the center. We have the same thing here, but there are a few numbers right below it that describe -1, -2, -3, and 68.3, 95.4, and 99.7. So let me just explain what that means. So using empirical rule, so let me just explain. Empirical rule is used to remember the percentage of values that lie within a band around the mean of a normal distribution with a width of 2, 4, or 6 standard deviations. So let me just explain. Let's say that the standard deviation of our the mean of our data is 65, and let's say the mean is 50 and the standard deviation is 10. If I wanted to calculate if it's a normal distribution, then I can quite correctly say that approximately 68% of my data would lie somewhere around 50 plus minus negative plus minus the standard deviation. So it would be from 40 to 60, and my 68% of the data will lie here. Why? Because that's the way the normal distribution is spread out. That's the shape it makes, and when you calculate the area underneath the shape, this is what we get. So let me just show you. Okay, so here we have -1 standard deviation, here we have +1 standard deviation, and here we have 0 standard deviation. And mean is, let's say that mean is signified by mu, and it's equal to let's say it's 50. Similarly, we want to take a look at standard deviation. Let's say it's called S, and it's equal to 10. So our data is not really spread out, and it's somewhere clustered around the center. Now I wanted to check how much data does lie between my standard deviation plus minus 1. So we take a look at this. So 50 minus 1 times the standard deviation, which is our standard deviation is 10. So 50 minus 10 is equal to 40. So starting from 40 and then ranging till 60, because 50 plus 10 would be 60, which is this one. So we're getting 40 to 60, we are getting 68.3% of our data. Similarly, if we move, instead of 1 standard deviation, we go to 2 standard deviations, we get, let me just clear it all up, erase all link on the slide, and let me just show you once again. Yeah, so if it's 2 standard deviations, then we have 50 minus 20 to 50 plus 20, which is 30 to 70, and we from within those values we get 95.4% values, and 3 standard deviations we get 99.7%. Now another thing to understand here is that if we have this, then what is the if we have the normal distribution and we can calculate this, then that makes it really easy for us to understand many other things about our data as well. We can confidently calculate how much data lies below a certain point, if it falls here. So let's take a look at that. Here, let's say that I have a data point. I have some data. I'm not going to show what the data is because that's not really relevant here. Let's say the mean is 65.5 and the standard deviation is 14.5. Now I want to calculate, let's say we have to calculate all the points. So mean times 0 standard deviation. So let's say SD. Yeah. So let me just expand this out. And we'll be calculating this for all. Let me just move this aside so that we can just calculate it, and we'll calculate it for all the points that we have. So in our presentation, we'll take a look at the image. We have -3 to +3 standard deviations because it explains most of our data. Yeah. So this is the formula that we have. 0 standard deviation, we will have 1 standard deviation, 2 standard deviation, 3 standard deviation, 1, 2, and we will have 3 standard deviations. We want -2, -1, and here would be the -3. Similarly, -1. Paste it here. -1. Instead of it being -1, we need +1, +2, and +3. So what does this mean? Let me just take a look at this first. Yeah, now we have it completely. Let me just expand this out. And now if we plug in the value, which is 65.5, let me just open up the calculator. So it would be 65.5. We go up 65.5 multiplied by, and here we'll be taking a look at 2 standard deviations. It's not multiplied actually, it's addition. So we need to add 1 standard deviations, 2 standard deviations, 3 standard deviations, so on and so forth. Let me just correct this mistake of mine. Yeah. Now if we take a look at this, 14.5 multiplied by -2 multiplied by 14.5, and we have 29. So if we add 29 to 65.5, we get 36.5. So here's 36.5, and if we add 29 to 65, which is, let's say, 29 plus 65.5, we get 94.5. And similarly, we'll get the same thing here. If we calculate the standard deviation multiplied by 2 standard deviation, here is 14.5 as they've already calculated here. So we get 14.5 multiplied by 2, it's 29. Oh, so this is for this. Yeah. And now let's take a look at 65.5 minus 14. It's 51.5. And if we add 65.5 plus 14.5, we get 80. And finally, we just have to do the same thing. 14.5 multiplied by 3, 43.5, 43.5, 65.5 minus 43.5, and we get 22. So at the top it's 22, and at the bottom it's 65.5 plus 3 times, it's 45.5, right? 45.5 plus 65.5, and we have 111. So this is what the distribution looks like. And now all we have to do is we have to figure out what is the what does our data look like. So when we take a look at this, 68.3% of our data is spread across 1 standard deviations away from the mean, both front and back. So if we calculate this range, 68% of our data lies from 51.5% to 80%. This gives us a good understanding of what our data is. So if somebody says, what is the probability that if I randomly choose a value in your data, it would be between 51.5 to 80%, and it would be 68%. This is the kind of question that empirical rule lets us answer. So this is 68%. Similarly, if we take a look at two standard deviations, so if somebody says what is the probability that I randomly choose a data point in your data set, and I get a value between 36.5 and 94.4. So this would be in our data set. If I take a look at this correctly, this would be 95.4. And similarly, if it's 22 and 111, then we get 99.7. And if we take the entire data set ranging from the smallest to the largest value, then that's 100%. So that's how you calculate this. Now let's say that that was not the question. So it's 68.3%. At the mean, it would be 50%. 50% of our data is here. Then we go up and we go down. So we have 68.3% and we divide it by 2, we get 34.15. So all we have to do is we have to add 34.15 to 50 and 84.15%. And if we subtract 34.15, we get 15.15. If 15.85, sorry. 15.85. So if you want to check 84.15 minus 15.85, we get 68.3%. So this is what the distribution looks like. Similarly, we can go a little back as well. If we take a look at the data, so we have 65.5, and if we subtract 36. If we calculate that and that, we can get that as well. So if somebody says, what is the probability that I choose some data that's up to 65.5, that's 50%, because 50% of our data lies still here. Then if somebody says, what is the probability that I get data that is below 51.5%, that's 15.85%. And you can go along these lines and understand what is the probability of other things as well. Similarly, if somebody says, what is the probability of getting data that's below 84.15%, below 80, that's 84.15. And if somebody tries to find out data above this, then it's 84.15 minus 100%, so 15.85%, which is exactly this one. So this is how you can calculate the probability of people choosing some data point that is that falls within some purview of your data. Now the question becomes, when is it useful? Well, it's useful in statistical analysis when we try to figure out what is the probability of one person choosing some data that's here. Now you might be wondering that that's a bit easy to do, because we are only asking questions like the data point that we have, that's 1, 2, or 3 standard deviations away from our data set. So if we're checking what is the probability of getting 65.5, that's exactly our mean, and no one's going to ask that. So if that is your question, then there comes other things such as Z score and all that, which we'll take a look at now. But to understand this is what happens. We take a look at the mean, we take a look at the standard deviation, we add and subtract it. This is only applicable to the normal distribution. Empirical rule is only working on normal distribution. If you don't have a normal distribution, this is not going to work. So take a look at normal distribution. If it's not normal, then try to add more data, subtract more data, try to figure out whether it's normal or not, and then normalize your data there as well. Here it's 95.4% of data, and we have 68.3 from the middle. So if we calculate it, 95.4 minus 68.3, so the data is 27.1%, and if we divide it by 2, it's 13.5%. So we can just take a look at this. We can just go 13.5% minus 15.85%, and this is what we will get. And similarly, if we add 13.5%, then that is what we will get. So 13.55, 15.85 minus 13.55, we get 2.3%, and 84.15 plus 13.55, and we get 97.7%. This is the data point that we are getting. If I take a look at this now in a presentation, yeah, so 90, this is what we are supposed to get, and this is the data set that we get. So this is how you can calculate all of it. When you take a look at it, this is what it looks like. This is the if you take a look at the data that we have, then that's the percentages that we get. 95.4%, sorry, 95.4% is supposed to be. So wait, okay, yeah. So 50%, 84.1% is what we're getting, and then 84.1 plus 13.6. Similarly, we can go 18 minus 34.1 minus 13.6. So 50 minus 34.1 minus 13.6. And it's 2.3%. So we're getting it correctly here, and this is what we're getting here as well. And finally, if you want to take a look at the entire data set, then that would be 97.7%, 99.7%, and 0.03%. So that is it. That is what we get. And let me just add it here, 99.7 and 0.3. Okay. So now what we're trying to do is we're trying to find out what is the percentage of values that we get between that. So that allows us to find out the probability that a person will take in some data. So if somebody says, what is the probability of me choosing a value that's below 94.5 in your data set, that is a mean times 2 times the standard deviation, mean plus 2 times the standard deviation. I need to correct these as well. So this is what you get when you do this. You get 95.4% of your values are below this. So if somebody chooses or tries to choose data between this, then they're going to get 95.4% chance of choosing a value between 94.5. So this is what it means. And now let's take a look at, this is for a very standardized example, but if you were to expand it out, then what will it look like? So let's take a look at Z rule for this. That's what it means, the Z score. So now we'll take a look at Z-scores. Z-scores allow us to apply empirical rule to not just the cut points or the standard deviations or the data points that are just 1, 2, or 3 standard deviations away, but any data point that we want to. So firstly, let's take a look at what Z-score means. Z-score is a measure of how many standard deviations below or above the population mean a raw score is. A raw score is basically any data element, any value of X that we choose. So here's what we can do, and it can be placed on the normal distribution curve. Again, these scores only work for normal distribution. If it's not normal distribution, if it's skewed to the left or right, if it's positive or negatively skewed, then that is not going to work. Now, as you can take a look at this image and this image, you can see that they are positively correlated. So as you can see, these scores are exactly the same as here. There's 0, then there's -1, then there's -2, then -3. These are the Z-scores of the cut points. So any point that's -1 standard deviation away from the mean, that will have a Z-score of -1. Similarly, -2, similarly -3. But if you move ahead and see how can we calculate the Z-score of a particular value that doesn't fall on these points. So how do you calculate Z-score of something that falls here? So there's a formula for it, and then we have to take a look at a table called Z-score table. Let's take a look at the formula first. This is what the formula looks like, where the Z-score is calculated by subtracting that score from the mean and then dividing by the standard deviation. Let's take a look at this with the example that we had previously seen, empirical rule. So this is what the table looks like. We have mean, then we add standard deviation. Let me just correct them once and for all. We have to add it, add this, and add this. Now that we have that, we have to calculate the Z-score. So here I have just taken the liberty of calculating, just correcting these values to match the values that are here. These values in which we have 68.3% of data, 34.1 from the mean on the left side, 34.1 on the right side, and that's how this looks like. So that's what it means. And now let's take a look at this. So we have mean and we have standard deviation, and what we can do here, if let's say that I wanted, I can easily calculate what would be the probability of something that, if I want to take a look at the probability of getting something between 65 and 80. So if I want to calculate the probability that a person picks one value from our data set and the data set is between 65.5 and 80, the probability will be 34.1. Similarly, if somebody wants to pick between 80 and 51.5, so if we take a look at this, This would be 34.1 plus 34.1, which is 68.3. So that's how you can calculate that. Now, if we move ahead here, let's say that these are scores, and you say, okay, I want to choose a student between in your classroom, but what is the probability that I pick a student whose score is below 50? So let's say X is 50, right? So according to the formula that we had seen, let's take a look at this one. So again, yeah, so this is what the formula is. Z score will be calculated like this. I would have to go to here. Z score would be the score minus this mean, which is 65.5, and this would be divided by, let me just put this inside brackets, and this would be divided by 14.5, which is the standard deviation. So let's pull out our calculator to do this. Let's remove all other values. 50 minus 65.5, it's negative 15.5, and we divide it by 14.5, and we get 1.068. So this is the value that you will get if you want to take a look at the z-score, but that's not really the probability, that's just the z-score. So when you want to take a look at the probability of something, you just need to go to new window and go and Google search z table. You can download a PDF version of this as well if you're using it again and again, and there's a website called ztable.com. Open that website, and the score that we had gotten was negative 1.06. Let's call it negative 1.07. So we go down, and this is the table for the negative values. Right down is the value for positive value. So we take a look at the negative values. The value that we are interested in is negative 1.07. So here we go to negative 1.0, and 0.7 is, if you take a look at the table, 0.7 is the last third column. So negative 1.0, and then the last third column is 14.23. So this is the probability that we will calculate, that will get this 50, which is 14.3. Now similarly, if I had X is equals to 90, what would be the probability? Now we could very easily understand that if it's 90, then it's between 80 and 95, and so it's going to be between these two standard deviations. We take a look at the image that we had earlier just to calculate. This one was 50, 84.5, so it's going to be somewhere around 90, right? But how do you calculate it exactly? Just like we did before, we'll calculate it using the same formula, 90 minus 65.5 divided by 14.5. I'm not putting brackets here, but you can take a look at that. Let me just put it so that it's easier to understand. So now if we calculate this, 90 minus 65.5, this would definitely be positive, divided by 14.5, and we get 1.689. Let's call it 1.69, right? So we take a look at the table here, 1.69. What we have to do, we go to the positive table, 1.6 on the left hand side and 9 would be on the right hand side. So here 95.45%. So we're getting 95.45% for this. Where is it? Yeah, 1.69.
Just a quick info, guys. Test your knowledge of R programming by answering this question. R functionality is divided into a number of dash: A. Packages, B. Functions, C. Domains. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
95.45% or 0.9545 would be the probability, but if we were to convert it to percentage, then 95.45. That's how you calculate the empirical probability of something in a normal, selecting a particular value in a normal distribution using the z-score. So again, just to reiterate, firstly, we calculate the empirical score. That's only done using the standard deviations and the mean of the data, and that tells us how far away from the mean is a particular data point. So 2 standard deviations away, or 1 standard deviation removed from the mean and 1 standard deviation added from the mean, it covers around 68.3% of our data set. We go up, it's 95. We go 1 step up, it's 97.3. 7% of our data set, and we go one step up, then it's 100% of our data. So that's how you can calculate standard cut points on our data. But how do you calculate the probability of selecting something using the standard using the z-score? So we take z-score for this. Firstly, we take the mean, we take the standard deviation, we take the number as x. So we take the number as x to be 50, then we plug it into the formula that we have just taken a look at. Is the formula x minus mu divided by, say, standard deviation. Mu is the mean, so 50 minus 65.5 divided by 14.5, and we calculate this and we get the value. We take a look at that in the z table. So we open the z table, we go into the negative formats, and we take a look at that negative 1.07, negative 1.0, and 7 is 14.23, and that's what we calculate here. So that's how you do that. It's very easy to understand once you get the hang of it. And with that in mind, let's move on to the next topic. All right, so now let's take a look at linear regression. It's one of the most important topics that you can learn, and you can use it to make predictions on your own data. So let's get started. So linear regression is a commonly used technique in predictive analysis that allows us to make predictions based on the data that we already have. It is used to create a model that can predict dependent variable using an independent variable. So dependent variable would be the y-axis, the thing that you're trying to predict, and the independent variable is the x-axis, the thing that you're using to make the prediction. So to give you an example, let's say that you have a house or you want to predict the house price in a particular time. So to do that, you would first need to take the price of the house during a specific period of time, and you need to then use the house. You then need to use the area of the house as the x-axis, and y would be the price of the house. So how does it relate with the area of the house? So how, if the house has a large area, then we get to pay more price, and if it's smaller area, then we get to pay smaller price. But the thing is, how do you calculate what price should you pay, depending on what are all the houses and what are all their areas and what are all their prices? So this is where this comes into play. So the formula is quite simple when you take a look at it. It means that y, which is the house price, would be equal to the population y-intercept. Y-intercept would be, if you make a graph out of all the data that you have, the line that will be determining the price of your house, where would that line start? Where would we start drawing that line from the y-axis? That would be the y-intercept, and the population slope coefficient would be how tilted the line should be, in which direction should it be tilted. So that's what is called population slope coefficient. It's the independent variable is the thing that we're trying to predict. So in place of x, we'll be putting in the area of the house, and then finally there would be some error. So our data will not exactly match up to what we have. There would be some issues with the data, and we'll take a look at what that means. So here's the first thing. Simple linear regression is useful for finding relationships between two continuous variables. If you have two variables, you can find the relationship between them. One of the variables is called the predictor, and the other variable is called the response, or the dependent variable. So independent variables and dependent variables. Independent variable is the one that's on the x-axis. That's the one that we have with ourselves, and the y-axis is the thing that we're trying to make a prediction on. So as you can take a look at the examples down below, if we have some data point, we create a scatter plot out of it, and then if we pass a linear line through it, linear is the straight line, then does that in some way or the other may help us understand the data that we have? That's what's known as a linear relationship between the data components of x and y, or the independent and the dependent variables. So this is what it looks like. Let's take a look at this, the tenure and the monthly charges. So let's say that we were to graph it. This is what the scatter plot would look like, and this is what we get. Now, after we have created linear relationship, we can draw a straight line using that linear relationship. And now let's say that somebody says, I want to make a prediction of how much should be the price or monthly charges, given 45% or 45 would be the tenure. So to calculate that, let me just take out my pen. What we do is, firstly we take a look at the x-axis. Here is where, let's say 45 is here. We cast a straight line till here, I guess I couldn't pass a straight line, but here's where it will be, and then we pass a straight line till here. So it will be somewhere around 70. That's how you make predictions using linear regression. So with that, let me just remove it all once again. Erase all ink. And now let's move forward. So again, this is what the formula looks like. In general, the data doesn't fall exactly on the line, so the regression equation should include some implicit error term. Now the fitted values or the predicted values are typically denoted by y hat. So y would be our intercept, our coefficients, our value of x plus some error. This error would be the difference between the prediction that we made and the actual answer. And the predictions are basically just intercept plus slope multiplied by the x value that we have. So if the slope value that we get is greater than 0, then that's a positive relation. Or you can say that when x increases, y will also increase. Or you can also take a look at this as positive correlation. Similarly, if b is less than 0, then it's negative relation or the negative correlation. And here's where the error come into play. The error here is the difference between the predictions and the line that we draw. So let's say that this is the line that we draw between age and salary. We get this line, and now the predictions that we have made is the difference between the points on the scatter plot and the line that we have made. We calculate the distance, we sum it, we square it, we do a lot of things. Let's see what we do when we want to calculate it. Let's say these are the three lines that someone gives you and says, let's try and figure out which one is the best line for us to make a prediction of in a linear regression algorithm. So these are the three things. So how do you do it? Well, quite easily, you just calculate the actual minus the prediction and square it. Squaring it basically because even if the numbers are different, then negative numbers and positive numbers still equal. When we square a negative number, we get a positive number. So that's why we square it. The one that has the lowest value of the residual sum square, which is also known as RSS, which is the error here, is the one that's the best here. So in our case, the orange line, which is the middle one, is the best. Then that's the blue line. Then it's the green line. Now let's take a look at some example to understand how to do this. Okay, so this is what we have here. Let me just, yeah. Now, if I were to take a look at some example, here it is. I have some example. Let's say that this is X and this is Y. X could be the hours the person studied, and Y could be the score that they obtained or something like this. So it could be anything. This is just for an example. So the first thing that we have to do, let me just go back to the formula so that you can see. B0 plus B1 X1. So Xi. So to calculate it, I have to go here. Calculate the mean of X, which is 3, which is just 5 plus 4 plus 3 plus 2 plus 1 divided by 5. 15 divided by 5 is 3. Similarly, we divide this, which is 20 divided by 5 is 4, and we get the mean of X and Y. Now we calculate X minus mean of X. This is what we get. Y minus mean of Y. This is what we get here. And then we calculate the square of these X minus mean of X, and we get the sum of that value to be 10. So 2 multiplied by 2, negative 2 multiplied by negative 2 is 4, negative 1 multiplied by negative 1 is 1, 0 multiplied by 0 is 0, and similarly 1 and 2 multiplied by themselves is 1 and 4. So we calculate the sum of them and we get 10. And now we calculate the sum of multiplication of mean of X and mean of Y, X minus mean of X and Y minus mean of Y. So we get negative 2 multiplied by negative 2 is 4, 0 multiplied by negative 1 is 0, 0 multiplied by 1 is 0, 0 multiplied by 1 is 0, and 2 multiplied by 1 is 2. That is 6. And now what we have to do is we have to find out these things. So B1, which is the intercept, is going to be the mean divided by 10. 10 would be the number of values. So we do this. 10 is this, which is X minus mean of X raised to the power of 2. So what we do is we calculate the 6 and we divide it by 10 and we get this, which is this. Basically what we're doing is we're calculating this and we are dividing it by the X minus mean of X square. So this is what we're doing. It could be a little counterintuitive to understand, but once you do understand it, You will understand it quite easily. Let me just again copy and paste it. For some reason, Excel is not working correctly. Let me copy, paste. Yeah. So this is what we've calculated here. Let me just expand this here. And this gives us B1, which is the slope. So slope is 0.6. And since it's positive, that means that the line is going to be straight up. And now let's calculate the intercept using this formula. So one formula that helps us calculate intercept is mean is equals to the intercept plus the slope multiplied by the mean of x. So I mean of x here is, as we know, 3. So we take 3, we multiply it by the intercept that we calculated, which was 0.6. This would be 0.18. And this is when we plug it into the formula, we get this. So 4 equals to b naught plus negative 0.6 multiplied by 3. 4 is equals to b naught plus 1.8, and b naught is equals to 4 minus 1.8, which is 2.2. So this is the value that we get. So we have calculated both b naught and b1. Our calculations are done, and this is the equation that we come in when we plug it into the equation that we have. So this is the equation we have, b naught plus b1 multiplied by x of I. So when we go back to it, this is the equation that we've come up to, and when we plug all the values of x in this, these are the values that we get as predictions: 2.8, 3.4, 4, 4.6, and 5.2. Now, as you can see, they are not that same as the y we have. These are the values of y that are actual. These are the ones that are predicted. And now we need to calculate the error. To calculate the error, all we have to do is we firstly need to calculate the actual y minus the predicted y. So actual y here is 2. 2 minus 2.8 is negative 0.8. 4 minus 3.4 is 0.6. 5 minus 4 is 1. And 4 minus 4.6 is 0.6, and 5 minus 5.2 is 0.2. So as you can see, our predictions are quite close to what the actual values are, but they are not there. So now we square them so that this negative value doesn't cancel out the error. Even if the error is in the negative value, it's still an error. So we calculate the square of this 0.64, 0.36, 1.36, 0.4, and we get the error to be 2.4. So this is the entire error of our line, and we get the correct line here. Now, in case this was sometimes when we try and figure out instead of doing it this way, instead of calculating all the values, many computer algorithms, what they do is they randomly set these values of b0 and b1. They create a line, then they calculate the error, and they shift the values of b1 and b0 in such a way that the value of error changes. And if shifting it in one direction reduces the error, then they keep shifting it in that direction, and as soon as the error starts increasing, they start moving back. So that's how they do that.
Now let us talk about the apply functions. So this is a list of apply functions from the apply family in R. Okay, these are the list of apply functions. Now, just to mention one thing, this is something which is unique to R. Now, apply family of functions. Apply functions are actually unique to R. It is not available in many programming languages, but it might be available in, I heard that it is available in Java. It's also available in Python, but not for the same purpose. The purpose is completely different. So this apply function is very unique to R. Now, what is this apply function? If you read the definition, it consists of vectorized functions, which minimizes your need to explicitly create loops. So we have seen for loop and while loop, right? So these are alternative to for loop and while loop. Now, first question would come, why would you need this if you already have loops, for loop and while loop, right? So the first reason they quote people who vouch for apply functions is these are like easy in terms of syntax, easily understandable. You're getting? These are easy. However, I don't completely agree. I feel the regular for loop and while loop are easier to understand, and I'm used to it because in other programming languages as well, we have that for loop and while loop. Okay. Second argument is, or second important point is, these are faster than the regular for loops. That sounds to be I would say, a strong reason behind using apply functions in your practical application. Although I don't use it much, to be frank, because it's difficult for me to remember the syntax. all the time. But yeah, it is faster than the regular for loop and while loop. Okay. So you would see there are like 1, 2, you can see 1, 2, 3, 4, 5, 5 apply functions, right? However, I would say don't worry, don't get intimidated by all these like variety of apply functions. Even if you're able to understand the first one, apply, the vanilla or simple apply, that is more than enough. Because these work on data frames. And most of the times you'll be working on data frames. All right. So let us go to the first one, apply function. Okay. So let us go through this one by one and you'll get a good hold of the syntax. I know there are many, but I will give you an exercise only for the vanilla simple apply function. Others, maybe just look at the syntax. And if you can remember it. Otherwise, it's fine. It's fine to only remember one apply function. How many of these you want to remember?
Just a quick info, guys. Intellipaat provides online data science master's program in partnership with IBM. The course link of which is given in the description below. Now, let's continue with the session.
Okay, so let's go for the simple apply. Now, you guys are asking about the scripts and everything, right? So for example, see with this 1R into .r, if we just search apply, you can see here, all the apply function examples are over here. Okay, so let me show you a simple apply function. Just give me, yeah. So based on the definition of apply function, it can be applied on matrices and data frames, right? Matrix and data frame. So I create one matrix. And this is my matrix, 1, 2, 3, 4. Okay. And now there's just one line of code for apply function. If I don't see it, I'll type it myself. So I'm not going to search it now. Apply. What is my matrix name? Mat, comma. I'll explain what is this. Sum. So what this does is, if I run it for you, can you guess what is this doing? Apply mat1 sum. So it gives you row-wise sum, right? Row-wise sum. 1 plus 3 is 4. 2 plus 4 is 6. However, so this 1 here means you want to apply this function sum on this matrix mat, and 1 means you should do row-wise. You should do row-wise. Okay. Next, if I say apply mat to sum, if we do this, this is column-wise. 1 plus 2 is 3. 3 plus 4 is 7. Clear? L apply, as the name suggests, right, means it will work on a list. So let me show you one L apply example. So who was looking for the example? So this is my list. Now what is this list? If I click on L and show you here, we have a list of 3 elements and there are sub elements as well. So 1, 1, 2, 2, 3, 3, 7. This is a list. Okay. Now what we are going to do here is we are going to just run this function, and let me run it and hit enter multiple times so that it goes to the center. So L apply, L mean. L apply means, first of all, it will work on a list and it will run this custom function on every element of the list. So what is the meaning of mean? Mean is average, right? So if I scroll here, what's the average of first row? 1. What is the average of second row? 2. What's the average of the third major element? 6.5, is it? 7 plus 3, 10 plus 3, 13. 13 by 3, right? It should be 4.33, right? So that is what you see here. It loops over the whole list and gives you. Now, you might ask me now, will it work with mixed like data type? It will not work because this function itself works on numbers, right? So 1, 2, 4.33. I'll quickly show you S apply as well. Yeah, and I'll show you the difference. S apply is exactly same. Okay, I'll put it in the center. I'll put in the center. Now tell me, if you are focusing here, tell me what is the difference between the results of S apply and L apply? Is there a difference? So is there any difference between these two results, 1, 2, and 4.33? Only the presentation is different, right? Otherwise, the answer is same, exactly. Only the answer is, only the presentation, the way it is shown here, you can see 1, 2, 4.33, and then 1, 2, 4.33, okay? So let me keep it here, L apply underscore results. Let me store the results. I'll store the results of L apply and M apply in two different vectors. Let me first store it like this. And here I am storing S apply results. So you can see this is your L apply result and this is your S apply result. So result wise, there's no difference, only the format. So the idea is now we never use these apply functions. At least I never use it for any production code. L apply, it needs list as an input and it gives list as output. S apply, it takes list as an input and gives vector as an output. Getting? So if I do a class of L apply results, this is a list. See here. And if I do class of S apply results, it is a vector. Okay, clear? Class function is only to understand what is the output format, guys. What is the object type? Whether my result is in the form of list or data frame or what. That's it. So if I do class of S apply results, it tells me it's a numeric vector. If I do class of L apply results, it tells me it's list. So class is always important. I would recommend everyone to use class every time. Even on your previous exercise, right? And you were doing that summarize and group by everything. At every intermediate step, you should use class. And this will be clear later because in the machine learning case studies, you'll be seeing this class again and again. You'll get bored of this function. So don't worry, we'll cover that again and again. Okay, fine. Now I'll go to the next one. Next one is, what is this function? T apply. So let me quickly explain you what T apply is. Where were we? Yeah, summarize and group by. So summarize and group by is used for getting some kind of aggregate statistics, right? Like if you want to find out, let's say, average salary by city or average salary by state, right? So for that, you can use summarize group by. So T apply is actually an equivalent to that. So when dplyr package was not there, we could have used T apply as well. But because we have a beautiful package dplyr, we don't want to really rely on T apply. But because there's a function available, I definitely need to explain you, right? So let me try T apply. If I can run it, let me see first of all if I have the PD data frame with me. I don't have. So I'm just importing the PD data frame, guys. Just hold for a moment. I will import the Pfizer data frame, the regular data frame which we are using for all our exercises. So I have the PD data frame. Of course, I'll not show you how to import. All of you know how to import. So this is the Pfizer data frame. Okay. Now, what do we want? We want to use T apply. So let's try using T apply, and I'll just I'll borrow some syntax from here. X index function, okay, churn and partner. So what I'm trying to do, I'm trying to find out the average of total payments group by state. Okay, that's it. So T apply PD dollar total, PD dollar state mean. How do we interpret this function? This is average of total payments by state. Now, see, it's not as powerful as summarize. Summarize has a lot of other flexibility. You can do multiple group bys and things like that, right? You can do group by state and city and everything. Definitely, it's not that powerful. So you don't need to use it for production applications, but still, because you have a function, I'm sharing with you. I hope you understood. Now, do you also understand one more thing, guys? This is what? This is data frame dollar column, right? Data frame dollar column, right? Instead of this, you could also use two vectors here because every column of a data frame is a vector, right? So instead of this, you could have used two vectors as well. Of course, it should be of equal length. And if you're using mean, definitely this column first column has to be the numerical column, and second column has to be the some kind of categorical column. Now, last one is what? mapply. So you can think of mapply as an alternative to mutate. I'll show you how. So here, what I want is I want to create a new column, which is the sum of cash and other column. You can call it like cash underscore plus underscore other. I want this column, cash underscore plus underscore other. This new column should be created in PD. Can you give me the code, how it will be? Feel free to do a Google search if you don't remember the syntax. But using mutate, can you do it? Just give me the code. No need to try it out. Like theoretically, give me. Okay. So this is what you can do using apply. I can just say sum, comma, PD, dollar, cash, PD, dollar, other. So of course you have to assign it PD, dollar. I'll just say new column. I'm just giving it a new name. Okay. So if I do view PD, you can see new column got created. And for those who are not able to see because it is at the bottom of the screen, this is how you can do it. mapply, sum, PD dollar cash, PD dollar other. Now, again, this is not as flexible as mutate, guys. So I would rather say use mutate. Okay. How many types of joins are there? Let me see if I can show you the join syntax. Just give me a moment. I want to pick up one data, which is, yeah. So let me create these two data frames and show you what these data frames are all about. These are just test data frames, and you can see all I've done is data.frame, and I've added two, columns here, fine. And then you have other table with two more columns. Let us see these two tables, please. Let me just show these two tables. So look at these two tables. Meanwhile, I'll try to answer a few questions. So these two tables, first table has X and Y as the columns, and second table or second data frame has X and Z as the columns. Okay. Can see this table, D1 and D2. What do you observe? What do you observe in these two tables? What is your observation? So it has same number of columns, X, Y, and XZ. And there's one common column. There's one common column, X, right? So most likely we can do join on this column, right?
Just a quick info, guys. Test your knowledge of R programming by answering this question. Which of the following is used for statistical analysis in R language? A. Studio, B. RStudio, C. Heck. Comment down your answer in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
So you can observe, right? There are few records which are exclusive to data frame D1, and there are few records which are exclusive to data frame D2, and rest are common as well, like 1, 2, and 3 are common, right? And I'm only talking about based on this X column, which is the key column. Now let's run this one by one. What we are doing, let me show you. So let me do it. Let me try in a join if it works. Okay. So what have I done here? Simply put, it is inner underscore join, which is also called as equi-join. We are passing these two data frames, D1 and D2. Look at it carefully. Okay, D1, D2 by C equal to X equal to X. So what's happening? Because it's an inner join, what is your expectation? What is your expectation from an inner join or equi-join? Only common records, right? So 1, 2, and 3. 1, 2, and 3. Only common records. In Y column, we have 10, 11, 12, 10, 11, 12. In Z column, 20, 21, 22, 20, 21, 22. Which library should be installed to run this? So this is on the dplyr library. Dplyr. If you see this is the dplyr library. Dplyr library. Its primary application. So Vinith, good question. Yeah, it's a common column, Deepak. Yeah. primary application of join is in real world, you can imagine, right? You store, let's say, student details in one table. Okay, like student ID, student name, student address. And in the second table, you store student marks like this: student ID, student name, student address. Okay, and in the second table, you have student ID and student marks. So these two tables contain the same information, right? Contains the information from the same student, right? So if you want to combine them into one single table, like student ID, student name, student address, and student marks, everything, then you should join these two tables. Getting? Okay, so that's what we have done here. If you see, we have just done inner join D1, D2 y equal to Cx equal to x. It can take two common columns as well. There you have to pass these two common columns. I would request you to check, just search this. If you don't get the syntax, let me know. Just say that how do you pass two join columns in dplyr. If you don't get it, I will let you know. Okay. So more than two columns can also participate in the, more than one column can also participate in the join. Right. Like for example, first name may not be just unique. First name and last name combined will be unique. Right. Okay. Can I try left join? I'm putting left join here. I'll not run this. Are you able to see my code? Left join code. Okay. That's the rationale. Left all the records, and from the right all the matching records. Which is the left table? D1. So D1 I should expect all the records, and D2 only matching records. See here, this is the one. Perfect. Now let's jump to what is data visualization? Visually helpful, right? And you get insights much quicker than what you would see in the raw tables, right? So that's the reason data visualization becomes very important. In fact, Grafana and Kibana people, Vinith is using. So only like hardcore software engineers use that. I'm happy that you use it. Okay, fine. So you know how data visualization helps, right? Okay. So R-Shiny is just a framework where you can embed all these charts and make it look more dashboard type. Let me stop my screen. Okay, coming back to ggplot2. And before I actually start ggplot2, just to let you know, do you know how to write data back to your computer? Like you know how to import CSV file into a data frame, right? Within R session. After you do some kind of data wrangling, some kind of changes to the data set, right? Can you write the data back to the file, or your computer? If not, this is the syntax for it, just for your reference. So you can just say write.csv data frame name, whatever data frame you have, and then give the file equal to and the path and file name. So this is the telecom churn data. It has data about all the customers. So we'll start with ggplot2. Guys, line number 23 is ggplot2 code. Okay. So this is an example of histogram. That's the first chart we'll see. Let me plot the histogram and then show you what it is actually doing. So what I'm doing in this, and let's see what is getting plotted here. So ggplot data equal to customer churn. What is customer churn? It's a data frame name, right? So we have to pass what data you want to use for your plotting. All right. And then you say aesthetics x equal to tenure. So AES stands for aesthetics here. This is like a settings for your chart. What settings you want to use for your chart. So what I'm saying, I want my x-axis to be tenure. And what is tenure? It is one of the columns, right? How much time the customer has spent with the network. If you remember the data frame here, how much time the customer, how many months the customer has spent with the network, right? Now, and then once the data frame is declared, my aesthetics is declared, I just say plus geom underscore histogram. So plus means after doing all the settings, you need to give the chart name. So if I give the chart name, see what I get. So what this really means, I'll tell you. This actually breaks the tenure into multiple parts. Okay, and it gives you some idea about the frequency of customers for different tenures. For example, for any customer whose tenure is 20, for all the customers whose tenure is 20 months, how many such customers exist? So around 200 such customers exist. Are you getting this point? This is a frequency chart. How many customers do we have with 0 months tenure? Around 600 customers. It's like a frequency chart. All of you get it? But internally what it does, it's not about just individual record, but this gives you how many customers do we have between 0 to 3, then between 3 to 6, 6 to 9, 9 to 11, sorry, 9 to 12 and things like that, right? So it gives you for every range, how many customers do we have for a particular range of tenure, okay? And this range is actually called bin. So if I draw it here, let's say I have customer 1, sorry, let's say I have this customer ID and this is tenure, okay? So customer ID 1, 2, 3, 4, 5, and so on till let's say 1000, okay? And I have tenure like 21 months, 22 months, 34 months, 7 months, 12 months, 14 months, and things like that. Now, how will the histogram look like? In the x-axis, I will have 0 to 5, 6 to 10, 11 to 15, 16 to 20, and so on. Okay. So for 0 to 5, I'll have no records. So this y-axis will have 0. 6 to 10, I might have 1 because we have 1 record, right? 11 to 15, I might have 2. Then I think for 16 to 20, there's nothing. And then 21 to 25, I have again 2. So likewise, this is my frequency plot. Okay. Now let me ask you this. This is actually called bin size, 0 to 5, 6 to 10. So what is your bin size now? It is 5, right? So what if we increase the number of bins? Like for the same range, let's say tenure ranges from 0 months to 100 months. If we increase the number of bins, what will happen to bin size? If we increase the number of bins, okay. So if I increase the number of bins, my every bin size will reduce, right? My every bin size will reduce. It might be like 0 to 3, then 4 to 6, right? 7 to 9, like this, right? So if I do that, will I gain information or lose information if I increase the bin size? Will I gain information or lose information? Think logically now. I'm not discussing syntax here. Will I gain information or lose information? So if you want to increase your bins, you can just specify. In addition, you can just specify bins equal to 40, 50, 60, whatever. Okay. We'll come back to histograms for sure. Here it is only about syntax. Yeah, of course, you can add more colors here, red, green colors, and you can stick to the same number of bins, right? And you have option to actually do a breakdown also. Breakdown means, or drill down. What that means, I'll tell you. If you see here, for every bin, if I need a breakup of how many customers in the first bin who are partners and non-partners, how many customers in the second bin who are partners and non-partners. If you want to do the breakup by the column, you can use that in the fill parameter. Okay. So this is about histogram. Similarly, this syntax is always like it's on the similar lines. If I go for the bar chart, it's the same thing. You see, ggplot, data equal to customer churn, everything is same. Aesthetics, x equal to dependence plus geom bar. If I do this, instead of geom histogram, I'm doing geom bar. If you observe here, if I click on this, sorry, let me expand this for you. Just a moment. Yeah. So if I do geom bar, what happens? By default, it gives us count. And it gives us count by category. What is that category here? Dependence or non-dependence. Okay. And you can fill this with colors. Again, you can always fill this with colors. And you can fill this with some other column as well if you want more or further breakup. Look at this. I'll pause here. I know I'm switching between the screens. I'll pause here. You see here. Here we have count by dependence and non-dependence. And then further, the drill down is on the, what do you call? The way you do the billing, or sorry, do the payment, bank transfer, credit card, credit check, or the mail check. Okay. So likewise, see, there are actually tons of options. Just ggplot2 has around 20-25 charts available. Okay, fine. Sorry, there's a scatter plot here. Do you know what is a scatter plot like? And most likely these two axes will have some numbers. I'll take a similar example as you said. Let me take like X1 is the sales, let's say, and this is the profitability. Okay, because volume of sales can be more, but sometimes the profit percentage can be less, right? So let's take profit and let's take like different cities. City 1, city 2, 3, 4, and 5. There are many cities. So whatever is falling in this cluster, right? What is happening? In these cities, sales are huge, even the profit margin is huge. In these cities, sales are high, but the profit margin are not quite high, right? In these cities, profit margins are high, but sales is not quite high. Make sense? So if you see the syntax is not very fancy. Again, ggplot, data equal to customer churn, which is the data frame name. Aesthetics, what do we pass? We pass Y and the X column, which is total charges and monthly charges. I am passing the third column. It's not mandatory, but I'm passing it. It's called internet service. And then we are just saying plus geom point. Why plus geom point? Because geom point is the scatter plot name. Okay. The third column, which I added, internet service, it kind of gives us for every customer what are the total charges versus monthly charges and what internet service that customer has opted for. So mostly you see the customers who opted for fiber optic internet service, they pay a reasonably. So there are two categories, one with high total charges and one with low total charges, but mostly the monthly charges are high. Okay, so that's the message here. You can always do it yourself. It's very easy. Trust me, it is very easy. Okay. The last one, again, the stock market guys here. Charts are super important in the stock market, right? Especially in India, the way it is booming now, right? The stock market investment, everyone wants to learn stock market. And everybody is trying to become an expert. Candlestick plot. This is the x-axis. This is the y-axis. Let's say this is what? Salaries. So this is your y-axis is salary. I'll talk about x-axis in a bit. Let's say you have 5,000 employees working in your company, hypothetically. Yeah, you're owning a company and you have 5,000 employees. How are their salaries? So this bit represents the minimum salary. This one represents the maximum salary. Is this clear, guys? Minimum, maximum. Your employees will have minimum, maximum salary, right? Your entry-level employees and compared to your CFOs and CEOs, right? Okay. Now there are three more points, useful points here, which you may not know now, but let me just call it out. This is the 75th percentile. Now you might not know what is percentile. This is 50th percentile. And this is 25th percentile. So what does a percentile mean? So let's say somebody's salary is, let's say in India it is, let's say 1.2 lakhs per month. Okay, 1.2 lakhs per month, and it is a 25th percentile, meaning there are 75% other employees who are earning more than this. 75% more employees, or 75% of the employees are earning more than 1.2 lakhs per month. If the 25th percentile is 1.2 lakhs per month, means 75% of the customers are earning more than 1.2 lakhs per month. Okay. What if my 75th percentile is 10 lakhs per month? 10 lakhs per month. This means only 25% of the employees are earning more than 10 lakhs per month. Getting? So this is what your box plot gives you. This is what your box plot gives you. And why have I drawn the x-axis? There's no use for the x-axis here, right? Do you see any use? So it can be used. Maybe you want to compare two cities, your employees in Mumbai and your employees in Delhi. You want to compare that. Again, it might be wrong. Don't take it literally. Generally, Mumbai salaries are more because of the cost of living, right? But yeah, this is how it shows. So the x-axis can help you compare two different dimensions of any data. Okay, yeah, let me show you a good example and then I'll talk about the syntax. Just give me a moment. So here what is happening? Monthly charges of customers by the internet service. So most likely, guys who have opted for fiber optic are actually paying more, right? Compared to DSL and no internet service, right? How did we plot it? So here's the chart. The syntax is same. So meaning what I'm trying to say, you can store all the settings in a variable. Every setting you can store in a variable and then plot, just call that variable. That's it. Now, why that is useful? That's useful because there are options like you can add facet grid. Now, what is facet grid? I'll tell you. Facet grid is a property in ggplot2. I don't know if you will find it useful or not. What if we split this chart into three different mini charts? In Tableau and Power BI and ClickView, these are called mini charts concepts. What I'm essentially talking about is, can I have three different histograms for three different internet service types like DSL, fiber optic, and no internet service? So what I'll do, I'll pick up G1 and I'll just say plus facet grid internet service. If I do this, it gives me three charts. If you really want to split it, you can do. Now, apart from this, again, we'll leverage the variable concept. We store the settings in a variable G1. What is this plot? This plot is a simple bar chart, and you can actually add labels here. G1 plus labels, store in G2, plot G2. So what do you mean by labels here? You see, I have first of all, I can add a title like distribution of tenure. Then I can add a theme background. Okay. Don't try to remember the syntax. It's of no use. Remembering the syntax is of no use. You should just know that this kind of capabilities exists. Okay, if you really want to, add more aesthetics to it. If I want to add plot background, I'll just add it, G3, some plot background, and then there will be one title as well. And finally, yeah, you can adjust the whatever title left or right or whatever. What I'm trying to say is you can have a plot background, theme background, title, and you can adjust the font and everything. Okay, that's pretty much from data visualization side for now. We will park it for now. We'll just keep it. I would say we'll keep these code snippets handy. Whenever we start machine learning case studies, you can choose to use boxplot2 or plotly, whichever you want to. But I would like to see a few charts. When you explain me your insights, right, charts will help. Let's say if I'm your business partner, it would be great if you can show me a few charts and explain what your analysis is, right? Because visually it will be easier for me to interpret. All right.
We'll be working on a project. So this project would be on recommendation engine. So have you ever wondered which book to read next? Well, I often have, and to me, book recommendations are a fascinating issue. And that is exactly what we're going to do today. So our dataset for the case study comprises of these four files: ratings.csv, books.csv, booktags.csv, and tags.csv. So as the name suggests, ratings.csv contains all users' ratings of the books. So there are a total of 980,000 ratings for 10,000 books from 53,424 users. So the books.csv contains more information on the books, such as the author's name, publication year, book ID, and so on. Then we have the book tags.csv file. So this file comprises of all tag IDs users have assigned to the books and the corresponding tag counts. So the tag IDs basically denote the categories into which the books fall into, and the counts denote the number of books belonging to each category. And we have the tags.csv file. So this file contains all the tag names corresponding to the tag IDs. That is, it gives out the labels corresponding to different tag IDs. So these are the tasks which you'd have to perform in this project. So in the first phase, we do a bit of data cleaning. So we'll start off by removing the duplicate ratings. That is, there are cases where a user has rated the same book more than one time. So we'll go ahead and remove all these instances. After which we'll go ahead and remove those users who have rated fewer than 3 books. Right guys, so we are into our studio now. So let us go ahead and load all of the packages required for our case study. So these are all of the packages required. Right, now after which I'll load the 4 files from our dataset. So these are the 4 files. So we have books.csv, ratings.csv, book tags.csv, and tags.csv. And I'm storing this in objects, books, ratings, book tags, and tags. So we have loaded these 4 files. Now let us have a glance at these 4 files. So I'll be using the view function to have a glance at our 4 files. Right, so these are our datasets, guys. So we have the ratings dataset, which comprises of these 3 columns: book ID, user ID, and the rating. Then we have the books dataset, and these are the columns. So it has ID, book ID, work ID, ISBN, the author's name. Then we have the original publication year, original title, language code, and so on. After which we have the book tags. And here the columns are Goodreads book ID, tag ID, and the count. And then we have the tags dataset. Here we have the tag ID and the corresponding tag name for that tag ID. Alright. So as part of our first phase, we had to do a bit of data cleaning. And the first task of our first phase was to remove all of the duplicate ratings. And to do that, we'd have to find out how many times has one single user rated one particular book. And this would be the command for that. So here what I'm doing is I am grouping this ratings data set by user ID and book ID. After which I'm using the mutate function and I'll add a new column to this, and that new column would be given by the n function from the deployer. So this basically would give us the number of times a single user has rated one particular book. And I'm giving the name of the new column to be capital N, and I'm storing the result back to ratings. So let me have a glance at ratings now. View of ratings. So we see that a new column has been added. So this is the user number. So the user number 314 has rated the book number 1 only once. Similarly, if we take this case over here, the user number 2900 has rated the book number 1 only once. So let me go down and see if there are some changes over here in the count of n. Right, so let's have a glance at these 2 cases over here. So the user number 4206 has rated the book number 8945 2 times over here, right? So these are the duplicate ratings which I'm talking about. So these records need to be removed, right? Right, so now let me also use the table function to find out the distribution of these duplicate ratings. So I'll use table function and I will give in ratings $n over here, which would give me the count of the different ratings given by one particular user to one particular book. Right, so this value over here tells us that there have been 5 instances where one particular user has rated the same book 5 times. This tells us that there are 28 instances where the same user has rated the same book 4 times. This tells us that there have been 156 instances where the same user has rated the same book 3 times. And this tells us that there are 4,298 instances where the same user has rated the same book 2 times. And this is all of those cases which are not duplicate. That is, the user has rated that particular book only one time. Right. So now what I'll do is, from this ratings data set, I will filter out all of those duplicate records and I will store them in a new object. So I will put in the name of the dataset, which should be ratings over here, and I will use the filter function to select all of those records where n is greater than 1. That is, which have duplicate ratings, and I will store it in a new object. So we have successfully created this new object. Now let me have a glance at this view of duplicate ratings. Right, so there are 4,487 entries in total which have duplicate ratings. Or in other words, there have been 4,487 instances where the same user has rated the same book more than one time. Right, now we'll go ahead and remove all of these duplicate ratings. Now this is a very simple command to do that. So from the ratings object, all you have to do is filter out only those records where the value of n equals to 1. So this basically means that we are filtering out those records where one particular user has rated one particular book only once, and I am storing this result back to the ratings dataset. Right, so we have done the changes. Now let me have a glance at it. View of ratings. Right, so these are all of the records where there are no duplicate ratings. So our second task was to remove all of those users who have rated fewer than 3 books. So for this, we'd have to start off by grouping the users with respect to user ID first and find out the number of ratings given by each user. So I will select this command over here and I'll paste it over here. So I have given ratings over here and I'm grouping this ratings with respect to user ID. After which I am using the mutate function, and over here again I am adding a new column, and that new column would be ratings given, and I will get that ratings given column with the help of this n function from the deployer package. So this n function from the deployer package would basically give me the number of ratings given by each user. Right, so I will store this back into the ratings dataset. Now let me have a glance at it. View of ratings. So this is the user ID. So the user number 314 has given 181 ratings in total. The user ID 439 has given 173 ratings in total. Similarly, the user ID 9246 has given 190 ratings in total. So now we'll go ahead and remove all of those user IDs who have given less than 3 ratings. So this is the command for that. I have again given ratings over here, and I am filtering out only those records where the ratings given by each user is greater than 2. That is, each user has at least rated 3 books or more, and I am storing the result back to ratings. So view of ratings. So this is our final data set. So we see that there are 960,595 entries in total. So we are done with the first phase. In the second phase, we'll do some data exploration. So we'll start off by extracting a sample set of 2% records from the entire data set. Then we will make a bar plot for the distribution of ratings. That is, we'd want to analyze the count of different ratings. After which we'll make a plot to understand how many times each book has been rated. Then we'll make a plot for the percentage distribution of different genres. Going ahead, we'll find the top 10 books with highest ratings. And finally, we'll find out the 10 most popular books. Right, so we are back to our studio again, and it's time for phase 2 now. So the first task in our phase 2 was to select a sample from the entire data set. So I'll go ahead and set a seed so that if I ever want to run these commands again, I can get the same results. So I'll set the seed value to be 1. And I'll set a user fraction of 0.02. That is, from the entire user base, I need only 2% of the sample users. So I am assigning this value of 0.02 to a new vector and naming that new vector to be user fraction. Now, after which I will find out all of the unique user IDs. So I am using the unique function over here, and I will give in the user ID column from the ratings dataset. So this will give me all of the unique user IDs, and I am storing the result in the users object. Now, after this, let me have a glance at the number of the unique user IDs. So length of users. So we see that there are 45,016 unique user IDs in total. So we need 2% of these unique user IDs. So 2% of this would be 0.02 into 45016. So this would give us 900 users. So from 45,016 users in total, we would need 900 users. Right. So we'll do a random sampling of 900 users from the entire user base. So this is the command for that. So I am using the sample function, and this is the list of all of the users. And from all of the users, I only need 900 of the users. So earlier we had multiplied the user fraction into the length of the users, which gave a value of 900 point something. So we are basically rounding that off, and I will store that result in sample users. So now let me have a glance at the length of sample users over here. Length of sample users. So we see that there are 900 sample users in total. Now let me also have a glance at the number of ratings.
Just a quick info, guys. Intellipaat provides online data science master's program in partnership with IBM. The course link of which is given in the description below. Now let's continue with the session.
So initially, the number of ratings which we have is 9,60,595. So now what I'll do is, from this ratings data set, I will be filtering out only those user IDs which are present in the sample users object. That is, I would need only the sample users from all of the users. And I will store the result back to ratings. Right, now let me have a glance at the number of ratings. So n row of ratings. So now we see that the number of ratings has reduced to 18,832. So initially we had more than 9 lakh ratings. So now after filtering the data set, we have just 18,832 ratings. Alright. So our second task was to make a distribution of these ratings. So let me go ahead and do that. So guys, this is the command for that. So again, I am using the ratings data set, and on top of this, I am building the ggplot. So here, I am mapping the rating column onto the x-axis. So this column over here, so we have different ratings, 1, 2, 3, 4 and 5. So I am mapping this column onto the x-axis. So the fill color would also be determined by the rating column. And after that, since we'd have to make a bar plot, I am using the geom_bar function. And the color which I give to the boundary of the bar plot would be gray 20. And the color which would be coming to all of these bars would be from this palette over here. So the palette is YLGNBU. So this stands for yellow, green and blue. So we'll be giving this inside the scale fill brewer function. Right. And I am also setting the guides to be false. Let me hit enter. So this is what we get. Let me zoom this now. So this is quite an interesting plot, isn't it? So let's have a glance at this bar over here. So this basically tells us that there are more than 6,000 cases where a rating of 4-star was given. Now similarly, we see that there are more than 5,000 cases where a rating of 5-star was given. And this bar over here, so this tells us that around 4,700 times a rating of 3-star was given. So the count of these two bars is quite low. So there have been very less cases where a rating of 1-star was given. So maybe not even 500 times a rating of 1-star was given. So this is for the rating of 2 stars. So around 1,000 times rating of 2 stars would have been given. So guys, this is the distribution of the ratings. Now after which we had to find the number of ratings per each book. So let's also do that. So here again, I start off by giving the ratings data set, and I would have to group this with respect to book ID, because I'd want to find the number of ratings per each book. So that is why I am grouping it with respect to book ID. Now after grouping it, I will use the summarize function. So basically inside this summarize function, I will basically get the count of number of ratings for each book. So here I am again using the n function. So this n function would give me the number of ratings per each book, and I'm also naming the result to be number of ratings per book. After which I'll again use the pipe operator and add a layer of the ggplot on top of it, and I am assigning the number of ratings per book onto the x-axis. The fill color is orange, the boundary color is gray 20, and the x-axis values would range from 0 to 40. Right guys, so this is the plot. Let me zoom this now. So from this graph, we can basically infer that there is not even one case where a book was rated more than 10 times. So let's have a glance at this bar over here. So this tells us that there are more than 2,500 instances where a single book was rated only by one user. So this is for those instances where a single book was rated by two users, or in other words, a single book was rated 2 times. This is for those instances which tells us that a single book was rated by 3 users, or in other words, a single book was rated 3 times. And the count for this is around 1500 times. Right, so this plot was for the number of ratings per each book. Then we had to get the percentage distribution of the different genres. So what we'll do is we'll start off by making a new object and giving it the name genres. So this genres object would basically have a list of different genres in it. So I have basically listed down a bunch of different genres over here, and I am storing all of these into the genres object. So the different genres are art, biography, science, thriller, travel, humor and comedy, and so on. So after building the genres object, what we'll do is from this tags data set, I will be extracting only those tag names which are present in the genres. Or in other words, I am extracting only those genres which are listed down over here. So this is the command for that. So what I'm basically doing over here is I am finding out if the listed genres are present in the tag names or not. And if they are present, I am extracting only those genres and I am storing them in available genres. So let me hit enter and let me actually see what are the available genres. Right, so these are all of the available genres in the tags dataset. So there are 27 genres in total, and these are Christian, business, poetry, philosophy, science, and so on. Now similarly, I will extract all of the corresponding tag IDs with respect to the tag names. So let me find out which are the available tags. So over here, I am basically extracting all of those tag IDs if the tag name is present in one of the available genres, right? So if the tag name is present in one of the available genres, only those tag IDs I'm extracting. And similarly, if the tag name is not present in the available genre, then I won't be extracting those tag IDs. And I am storing the result in available tags. So next we had to make a plot for the percentage of each genre. So let's go ahead and do that. So before we do that, let's actually get a count of the different genres available. So this would be the command for that. Let me print it over here. So what I'm basically doing over here is from the book tags dataset, I am extracting only those tag IDs which are present in available tags. And then again, I am grouping it with respect to the tag ID. After which I'll use the summarize function and get the number of counts of each of these tag IDs. Or in other words, I'll get the count of the different genres. So let me hit enter and let me see what do we get. So this is the tag ID 2938. And for this corresponding genre, the count is 436. That is, there are 436 books belonging to this genre. Similarly, this is the tag ID 4605 and the count is 1109. So this means that there are 1109 books present for this particular genre over here. And let's take this over here. So the tag ID is 7778 and the count is 469. So this means that there are 469 books present with respect to this genre. Now let me go ahead and also find the percentage. So let me select all of this code over here. Right.
So now we had run the command till here. Now, so we basically got the count of each genre. Now, after getting the count of each genre, I am ungrouping it again. After that, I will use the mutate function and find the total count. That is the total count of all of the genres combined. And I am also creating a new column percentage. So this percentage over here, I am dividing n upon sum of n. That is, this would give me the percentage of each of the genre. And after getting the percentage of each of the genre, I will arrange the data set in descending order. And after arranging the data set in descending order, I will also left join the tags data set to the book tags data set. And the joining would be done by the tag ID column over here. So let me store this in a new object. So let's say book info. Now let me have a glance at it. View of book info. Right. So guys, this is the tag ID. This is the count of the tag ID. That is the number of times this genre is present. And this column gives us the total count of all of the genres. This gives us the percentage of the genre. And this is the tag name, which is fantasy. So we've got our data set ready. Now we'll go ahead and make a plot on top of this. So now let me go ahead and make a plot. So the object name was actually book info. So let me change this to book info over here. And on top of this book info object, I am adding a ggplot layer. So here I'll be mapping the percentage column onto the y-axis and the tag name column onto the x-axis. And the fill would be determined by the percentage column. And since we'd want to make a bar plot, we'll be using the geom bar function, and the stat which I've used is identity. And I'll also use the quad flip function over here because I'd want these bars to be stacked horizontally and not vertically. And the color to these bars would be determined by this palette over here. So this is YLORD. So this would be for yellow, orange, and red. And the label which I've given for the y-axis is percentage, and the label which I've given for the x-axis is genre. Let me hit enter. Right guys, so this is the plot. So here I have mapped genre onto the y-axis, percentage onto the x-axis. So we see that fantasy is the most prevalent data set, or in other words, most of the books belong to the fantasy genre, and the least percentage is of the cookbooks. So this was the distribution of the percentage of different genres. So next we'll go ahead and find the top 10 books with highest rating. So this would be the command for that. So if you have to find out the top 10 books with highest rating, all we have to do is arrange this average rating column in descending order. And that is what we are doing over here. So here I have given the name of the object, which is books, and I am arranging this data set in inverse order of average rating. After which I am selecting just the top 10 records, and the columns which I'd be selecting are title, ratings count, and average rating. So let me store it in top 10. Let me have a glance at top 10 now. Right guys, so these are the top 10 highest rated books. So the Complete Calvin and Hobbes is the book with the highest rating. So it has the highest average rating of 4.82. And then we have Words of Radiance. So it has a rating of 4.77. Third in place is the Harry Potter box set, which has 4.77 rating. Fourth is ESV Study Bible, which has a rating of 4.76. Fifth in the list is Mark of the Lion Trilogy, which has an average rating of 4.76. Alright guys, so we have successfully found out the top 10 books with highest ratings. Next we'll go ahead and also find the top 10 most popular books. So this would be the command for that. So to find out the top 10 most popular books, we'd have to arrange this ratings count column in descending order. That is, whichever book has the most number of ratings, it would automatically mean that it is the most popular book. Right, so this is the command for that. Let me run it over here. So here what we are doing is, on the books data set, I am arranging it in inverse order of the ratings count column. And then I will be extracting the top 10 records, and I'll be selecting the title column, the ratings count column, and the average count column. So let me store this in top popular. Let me have a glance at top popular. Right, so these are the top 10 most popular books. So the most popular book in the list is The Hunger Games, which has the highest ratings count. Then the second most popular book is Harry Potter. Third most popular book is Twilight. And the fourth most popular book is To Kill a Mockingbird. In the third phase, we'll finally do some recommending. So we'll start off by building the user-based collaborative filtering model. And then we'll recommend 6 new books for 2 different readers. Right guys, so it's finally time to recommend some books. So before we go ahead and do that, we'd actually have to restructure our data a bit. So our data actually needs to be in the form of a matrix where all the rows should correspond to the users and all the columns should correspond to the books. So the dimension names would then nothing be but the user IDs and the book IDs. So the user IDs would represent all of the rows and the book IDs would represent all of the columns. So let me go ahead and extract all of the dimension names first. So here with this command, what I'm doing is I am extracting all of the unique user IDs and I'm also extracting all of the unique book IDs and I'm storing them in this object dimension names. So this is our first task. So we have basically got all of our dimension names. Now we'll go ahead and convert the format of our data frame from long format to wide format. So with this command, what we are doing is we are actually selecting the book ID, the user ID and the rating columns from this data frame over here. And I'll be splitting this book ID column. That is, this value of book ID 1 would become one column. This value of book ID 2 would become the second column. This value of book ID 3 would become the third column and so on. And these rating values over here, they would become the values for the corresponding book IDs. So this is how we can use the spread function to spread out our data frame from long format to wide format. And we'll also remove the user ID column because it doesn't serve a purpose. And I will store it in a new object and name that object to be rating mat.
Just a quick info guys. Test your knowledge of R programming by answering this question. Which of the following is used for statistical analysis in R language? A. Studio. B. RStudio. C. Heck. Comment down your answer in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
So let me hit enter. Right, so we have created our rating matrix. So we have created the rating mat object. Now let me have a glance at the class of this. So class of rating mat. So we see that this is still in the form of a data frame. But we can build our user-based collaborative filtering model only on top of the real rating matrix. So first we'll have to go ahead and convert this data frame into a matrix. So let me do that. So here with the help of as.matrix function, I am converting the class of rating mat from a data frame to a matrix and I am storing the result back to rating mat. Right. So now let me have a glance at the class. So class of rating mat, and we see that now it is a matrix. So let me have a glance at the first 5 rows and the first 5 columns of it. So these are the first 5 rows and these are the first 5 columns. So we see that this user ID column has not been removed. So let us go ahead and manually remove these. So what I'm doing is I am manually removing this first column and I am storing it back into rating mat. Now let me have a glance at first 5 rows and first 5 columns. Right. So these are the first 5 rows and these are the first 5 columns. So these rows basically correspond to all of the user IDs and these columns basically correspond to all of the book IDs. So these NA values which you see over here, so this basically means that the first user has not rated the first book, the first user has not rated the second book, similarly the fourth user has not rated the third book and so on.
Right, so we have our rating metrics ready. Now let me also assign the dimension names to the dimension names of this rating mat object. So here I am assigning all of the dimension names which I've extracted to the dim names of the rating mat. Right. So now let me have a glance at the dim names of rating mat. So dim names of rating mat. So these are all of the dimension names for the rows. So this is the name for row number 1, this is the name for row number 2, and this is the name for row number 3. So this basically signifies that all of the rows are represented by the user IDs. Similarly, if I go down, then we have all of the book IDs. So all of the columns are represented by the book IDs over here. Now let me use the dim function to find out the number of rows and columns in the matrix. So we see that there are 900 rows and 8,431 columns. Or in other words, there are 900 users and 8,431 books. So we have got our metrics ready, but we can't just build a user-based collaborative filtering model on top of the metrics. So we have something known as a real rating matrix. And the recommender lab basically works only on this type of object. So I will store this rating mat into a new object and name that object's name to be rating mat 0. Let me again have a glance at the number of dimensions of this. Dim of rating mat 0. So we have the same number of rows and columns. So again here, the number of rows are 900 and the number of columns are 8431. Now after this, what we'll do is, wherever we have NA values, we will replace those NA values with 0. So in rating mat 0, wherever we find NA values, I am replacing those NA values with 0. So now let me again have a glance at the first 5 rows and the first 5 columns of this. So it'd be rating mat 0, 1 to 5 and 1 to 5. So we see that all of the NA values have been replaced with zeros. So now we can go ahead and convert this matrix into a sparse matrix. So I'll be using the as function and I am converting this rating mat 0 object into a sparse matrix, and I will store this in a new object and name that object to be sparse ratings. Now let me again have a glance at the first 5 rows and first 5 columns of this. So sparse ratings 1 to 5 and 1 to 5. So this is how a sparse matrix looks like. So basically with the help of a sparse matrix, we end up saving a lot of space. Now it's the last part of the transforming. So we will go ahead and convert this sparse matrix into a real rating matrix. So for this we would need the new function, and with the help of new function I am converting this sparse ratings object into a real rating matrix. So this over here takes in 2 parameters. So the first parameter is basically what we are trying to convert this into, and then we given the data which we are trying to convert, and I'll store this result in real ratings object. Let me print real ratings now and let's see what do we get. Real rating. So this is what we get. So it is a rating matrix where there are 900 rows and 8431 columns, and it is of class real rating matrix with 18,832 ratings. Right. So we finally have our real rating matrix ready. So now we can go ahead and build a model on it. So what we'll do is we'll go ahead and split the data set into train and test sets. So it'll be a 80-20 split. So I'll be using the sample function to create this 80-20 split over here. So I am using the sample function, and I will generate true or false values over here, and this sampling would be with replacement, and the probability is 80-20. That is, I would want to divide the data set into 2 parts, where the first part would comprise of 80% of all of the observations, and the second part would comprise of 20% of the rest of the observations. And I will store the split criteria in a new object and name that object to be split book. So now in real ratings, wherever the value of split book is equal to true, I will select all of those records and store those records in RecTrain. Similarly, from the real ratings matrix, wherever the value of split book is assigned to be false, I am extracting all of those observations and storing those observations in rec test. So we have our training and testing sets ready. Now we can finally go ahead and build our first model. So we'll be using the recommender function, and this over here takes in two parameters. First is the training set on which we'd want to build the model, and next is the method or the type of the recommender model which we'd want to build. And since we'd want to build a user-based collaborative filtering model, we'll given the type to be UBCF. So if we wanted an item-based collaborating filtering model, then the method would be IBCF. But in our case, since we want user-based collaborative filtering model, so the method would be UBCF, and I will store the result in an object which would be rec model UBCF. Right, so I have successfully built the model. Now I'll give a value for the number of books to be recommended. So I am assigning the value 6 to a vector, and the name of that vector is nRecommended UBCF. So this basically lets us know that we'd have to recommend 6 books in total. Right, so the model building process is done. So let me go ahead and predict the values. So I'd have to use the predict function for this. So over here, this takes in 3 parameters. First is the model which you built. Next is the dataset on which we'd want to predict the values. And third is the number of values to be recommended. Right. So first we'll given the model which you built, which is rec model UBCF, and then we'd want to predict on top of the test set. So the test set is rec test, and the number of books to be recommended is 6, which is stored in nRecommended UBCF, and I will store this result in rec predicted UBCF. Right, so the prediction is also done. Now let me go ahead and find out the item numbers which have been predicted. So now that we have predicted the values, let's go ahead and recommend some books to user number 1. So here we will use this object rec predicted UBCF. So this is the object which we've just built using the predict function. And I'd want to find out the item numbers which have been recommended to user number 1. So this command over here, rec predicted UBCF @items1. So this will give me the column numbers which have been recommended to user number 1. So let me have a glance at user 1 book numbers. So this basically means that user 1 has been recommended to read these books which are presented columns 2177, column number 6343, column number 423, column number 1908, column number 2274, and column number 2514. Now we just have the column numbers. So let's actually find out the labels for these column numbers. Right, so from rec predicted UBCF, we have the item labels, and inside the item labels, I will give in the book numbers which have been recommended. Right, so these are the item labels. So the book ID, which is under column number 2177, is 2636. The book ID which is under column number 6343 is 7482. Similarly, the book ID which is under column number 2274 is 2750. So we have successfully got the book IDs. So now that we have the book IDs ready, let's actually use these book IDs to extract the name of the book and the name of the author. Right, so what I'll do is I will extract the title of the book and the author's name, where the book ID is 549. So the name of the book is Cordry and the author's name is Don Freeman. Similarly, let me extract the title and the author's name, where the book ID is 2750. So here we see that the book recommended is Mrs. Pigglewiggle, and the authors are Betty McDonald and Alexandra Boyger. Similarly, let me extract the titles for the book ID 3029. Let's see what do we get. 3029. So the book recommended is Rage of Angels, and the author is Sidney Sheldon. Right, so these are the 6 books which have been recommended, and this is how we can extract the name of the book and the author of the book. Now similarly, let's also go ahead and recommend 6 books for the user number 5. So this is what I'd have to do. I will be using the rec predicted UBCF object, and I'll be using the @tag and extracting the items for user number 5, and I'll store this result in user 5 book numbers. So now that we have the item numbers, let's actually extract the column numbers for each of these items. So for this, the command would be rec predicted UBCF @item labels, and inside this I will give in the book numbers. Right, so these are the book IDs which have been predicted. Right, so similarly, let's extract the title and authors for some of these book IDs. So we are extracting the title and the author's name, where the book ID is 4624. So the recommended book, so the name of the recommended book is The Girl Who Circumnavigated Fairyland in a Ship of Her Own Making, and the author is Catherine M. Valentine and Anna Wan. Similarly, let's extract the name of the book and the author's name, where the book ID is 6867. So here the book is Malgudi Days, and it's been written by R.K. Narayan and Jumpalari. Now let me extract the title and the author's name for the book ID, which is 7326. So the book's name is Doctors, and it has been written by Eric Segal. Right guys, so we have successfully implemented the user-based collaborative filtering model, and we have recommended 6 books to 2 different users. So have you ever wondered which book to read next? Well, I often have, and to me, book recommendations are a fascinating issue. And that is exactly what we're going to do today. So our dataset for the case study comprises of these 4 files: ratings.csv, books.csv, booktags.csv, and tags.csv. So as the name suggests, ratings.csv contains all users' ratings of the books. So there are a total of 980,000 ratings for 10,000 books from 53,424 users. So the books.csv contains more information on the books, such as the author's name, publication year, book ID, and so on. Then we have the booktags.csv file. So this file comprises of all tag IDs users have assigned to the books and the corresponding tag counts. So the tag IDs basically denote the categories into which the books fall into, and the counts denote the number of books belonging to each category. And we have the tags.csv file. So this file contains all the tag names corresponding to the tag IDs. That is, it gives out the labels corresponding to different tag IDs. So these are the tasks which you'd have to perform in this project. So in the first phase, we do a bit of data cleaning. So we'll start off by removing the duplicate ratings. That is, there are cases where a user has rated the same book more than one time. So we'll go ahead and remove all these instances. After which we'll go ahead and remove those users who have rated fewer than 3 books. Right guys, so we are into our studio now. So let us go ahead and load all of the packages required for our case study. So these are all of the packages required. Alright, now after which I'll load the 4 files from our dataset. So these are the 4 files. So we have books.csv, ratings.csv, booktags.csv, and tags.csv. And I'm storing this in objects books, ratings, book tags, and tags. So we have loaded these 4 files. Now let us have a glance at these 4 files. So I'll be using the view function to have a glance at our 4 files. Right, so these are our datasets, guys. So we have the ratings dataset, which comprises of these 3 columns: book ID, user ID, and the rating. Then we have the books dataset, and these are the columns. So it has ID, book ID, work ID, ISBN, the author's name. Then we have the original publication year, original title, language code, and so on. After which we have the book tags. And here the columns are Goodreads book ID, tag ID, and the count. And then we have the tags dataset. Here we have the tag ID and the corresponding tag name for that tag ID. Alright. So as part of our first phase, we had to do a bit of data cleaning. And the first task of our first phase was to remove all of the duplicate ratings. And to do that, we'd have to find out how many times has one single user rated one particular book. And this would be the command for that. So here what I'm doing is I am grouping this ratings data set by user ID and book ID. After which I am using the mutate function and I'll add a new column to this, and that new column would be given by the n function from the deployer. So this basically would give us the number of times a single user has rated one particular book. And I'm giving the name of the new column to be capital N, and I'm storing the result back to ratings. So let me have a glance at ratings now. View of ratings. So we see that a new column has been added. So this is the user number. So the user number 314 has rated the book number 1 only once. Similarly, if we take this case over here, the user number 2900 has rated the book number 1 only once. So let me go down and see if there are some changes over here in the count of n. Right, so let's have a glance at these two cases over here. So the user number 4206 has rated the book number 8945 two times over here, right? So these are the duplicate ratings which I'm talking about. So these records need to be removed, right? Right, so now let me also use the table function to find out the distribution of these duplicate ratings. So I'll use table function and I will give in ratings $n over here, which would give me the count of the different ratings given by one particular user to one particular book, right? So this value over here tells us that there have been 5 instances where one particular user has rated the same book 5 times. This tells us that there are 28 instances where the same user has rated the same book 4 times. This tells us that there have been 156 instances where the same user has rated the same book 3 times. And this tells us that there are 4,298 instances where the same user has rated the same book 2 times. And this is all of those cases which are not duplicate. That is, the user has rated that particular book only 1 time. Right. So now what I'll do is, from this ratings data set, I will filter out all of those duplicate records and I will store them in a new object. So I will put in the name of the dataset, which would be ratings over here, and I will use the filter function to select all of those records where n is greater than 1. That is, which have duplicate ratings, and I will store it in a new object. So we have successfully created this new object. Now let me have a glance at this view of duplicate ratings. Right, so there are 4,487 entries in total which have duplicate ratings. Or in other words, there have been 4,487 instances where the same user has rated the same book more than 1 time. Right, now we'll go ahead and remove all of these duplicate ratings. Now this is a very simple command to do that. So from the ratings object, all you have to do is filter out only those records where the value of n equals to 1. So this basically means that we are filtering out those records where one particular user has rated one particular book only once, and I am storing this result back to the ratings dataset. Right, so we have done the changes. Now let me have a glance at it. View of ratings. Right, so these are all of the records where there are no duplicate ratings. So our second task was to remove all of those users who have rated fewer than 3 books. So for this, we'd have to start off by grouping the users with respect to user ID first and find out the number of ratings given by each user. So I will select this command over here and I'll paste it over here. So I have given ratings over here and I'm grouping this ratings with respect to user ID. After which I am using the mutate function, and over here again I am adding a new column, and that new column would be ratings given, and I will get that ratings given column with the help of this n function from the deployer package. So this n function from the deployer package would basically give me the number of ratings given by each user. Right, so I will store this back into the ratings dataset. Now let me have a glance at it. View of ratings. So this is the user ID. So the user number 314 has given 181 ratings in total. The user ID 439 has given 173 ratings in total. Similarly, the user ID 9246 has given 190 ratings in total. So now we'll go ahead and remove all of those user IDs who have given less than 3 ratings. So this is the command for that. I have again given ratings over here, and I am filtering out only those records where the ratings given by each user is greater than 2. That is, each user has at least rated 3 books or more, and I am storing the result back to ratings. So view of ratings. So this is our final data set. So we see that there are 960,595 entries in total. So we are done with the first phase. In the second phase, we'll do some data exploration. So we'll start off by extracting a sample set of 2% records from the entire data set. Then we will make a bar plot for the distribution of ratings. That is, we want to analyze the count of different ratings. After which we'll make a plot to understand how many times each book has been rated. Then we'll make a plot for the percentage distribution of different genres. Going ahead, we'll find the top 10 books with highest ratings. And finally, we'll find out the 10 most popular books. Right, so we are back to our studio again, and it's time for phase 2 now. So the first task in our phase 2 was to select a sample from the entire data set. So I'll go ahead and set a seed so that if I ever want to run these commands again, I can get the same results. So I'll set the seed value to be 1. And I'll set a user fraction of 0.02. That is, from the entire user base, I need only 2% of the sample users. So I am assigning this value of 0.02 to a new vector and naming that new vector to be user fraction. Now after which I will find out all of the unique user IDs. So I am using the unique function over here, and I will give in the user ID column from the ratings dataset. So this will give me all of the unique user IDs, and I am storing the result in the users object. Now after this, let me have a glance at the number of the unique user IDs. So length of users. So we see that there are 45,016 unique user IDs in total. So we need 2% of these unique user IDs. So 2% of this would be 0.02 into 45016. So this would give us 900 users. So from 45,016 users in total, we would need 900 users. Right. So we'll do a random sampling of 900 users from the entire user base. So this is the command for that. So I am using the sample function, and this is the list of all of the users. And from all of the users, I only need 900 of the users. So earlier we had multiplied the user fraction into the length of the users, which gave a value of 900 point something. So we are basically rounding that off, and I will store that result in sample users. So now let me have a glance at the length of sample users over here. Length of sample users. So we see that there are 900 sample users in total. Now let me also have a glance at the number of ratings. So initially the number of ratings which we have is 9,60,595. So now what I'll do is, from this ratings data set, I will be filtering out only those user IDs which are present in the sample users object. That is, I would need only the sample users from all of the users, and I will store the result back to ratings. Right, now let me have a glance at the number of ratings. So in row of ratings. So now we see that the number of ratings has reduced to 18,832. So initially we had more than 9 lakh ratings. So now after filtering the data set, we have just 18,832 ratings. Alright. So our second task was to make a distribution of these ratings. So let me go ahead and do that. So guys, this is the command for that. So again, I am using the ratings data set, and on top of this, I am building the ggplot. So here, I am mapping the rating column onto the x-axis. So this column over here, so we have different ratings 1, 2, 3, 4 and 5. So I am mapping this column onto the x-axis. So the fill color would also be determined by the rating column. And after that, since we'd have to make a bar plot, I am using the geom_bar function. And the color which I give to the boundary of the bar plot would be gray 20. And the color which would be coming to all of these bars would be from this palette over here. So the palette is YLGNBU. So this stands for yellow, green and blue. So we'll be giving this inside the scale fill brewer function. Right. And I am also setting the guides to be false. Let me hit enter. So this is what we get. Let me zoom this now. So this is quite an interesting plot, isn't it? So let's have a glance at this bar over here. So this basically tells us that there are more than 6,000 cases where a rating of 4-star was given. Now similarly, we see that there are more than 5,000 cases where a rating of 5-star was given. And this bar over here, so this tells us that around 4,700 times a rating of 3-star was given. So the count of these two bars is quite low. So there have been very less cases where a rating of 1-star was given. So maybe not even 500 times a rating of 1-star was given. So this is for the rating of 2 stars. So around 1,000 times rating of 2 stars would have been given. So guys, this is the distribution of the ratings. Now after which we had to find the number of ratings per each book. So let's also do that. So here again, I start off by giving the ratings data set.
Just a quick info guys. Intellipaat provides online data science master's program in partnership with IBM. The course link of which is given in the description below. Now let's continue with the session.
And I would have to group this with respect to book ID because I'd want to find the number of ratings per each book. So that is why I am grouping it with respect to book ID. Now after grouping it, I will use the summarize function. So basically inside this summarize function, I will basically get the count of number of ratings for each book. So here I am again using the n function. So this n function would give me the number of ratings per each book, and I'm also naming the result to be number of ratings per book. After which I'll again use the pipe operator and add a layer of the ggplot on top of it, and I am assigning the number of ratings per book onto the x-axis. The fill color is orange, the boundary color is gray 20, and the x-axis values would range from 0 to 40. Right guys, so this is the plot. Let me zoom this now. So from this graph, we can basically infer that there is not even one case where a book was rated more than 10 times. So let's have a glance at this bar over here. So this tells us that there are more than 2,500 instances where a single book was rated only by one user. So this is for those instances where a single book was rated by 2 users, or in other words, a single book was rated 2 times. This is for those instances which tells us that a single book was rated by 3 users, or in other words, a single book was rated 3 times. And the count for this is around 1,500 times. Right, so this plot was for the number of ratings per each book. Then we had to get the percentage distribution of the different genres. So what we'll do is we'll start off by making a new object and giving it the name genres. So this genres object would basically have a list of different genres in it. So I have basically listed down a bunch of different genres over here, and I am storing all of these into the genres object. So the different genres are art, biography, science, thriller, travel, humor and comedy, and so on. So after building the genres object, what we'll do is from this tags data set, I will be extracting only those tag names which are present in the genres. Or in other words, I am extracting only those genres which are listed down over here. So this is the command for that. So what I'm basically doing over here is I am finding out if the listed genres are present in the tag names or not. And if they are present, I am extracting only those genres and I am storing them in available genres. So let me hit enter and let me actually see what are the available genres. Right, so these are all of the available genres in the tags dataset. So there are 27 genres in total, and these are Christian, business, poetry, philosophy, science, and so on. Now similarly, I will extract all of the corresponding tag IDs with respect to the tag names.
Just a quick info, guys. Test your knowledge of R programming by answering this question. R functionality is divided into a number of dash A. Packages, B. Functions, C. Domains. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
So let me find out which are the available tags. So over here, I am basically extracting all of those tag IDs if the tag name is present in one of the available genres, right? So if the tag name is present in one of the available genres, only those tag IDs I'm extracting. And similarly, if the tag name is not present in the available genre, then I won't be extracting those tag IDs. And I am storing the result in available tags. So next we have to make a plot for the percentage of each genre. So let's go ahead and do that. So before we do that, let's actually get a count of the different genres available. So this would be the command for that. Let me print it over here. So what I'm basically doing over here is from the book tags dataset, I am extracting only those tag IDs which are present in available tags. And then again, I am grouping it with respect to the tag ID, after which I'll use the summarize function and get the number of counts of each of these tag IDs. Or in other words, I'll get the count of the different genres. So let me hit enter and let me see what do we get. So this is the tag ID 2938. And for this corresponding genre, the count is 436. That is, there are 436 books belonging to this genre. Similarly, this is the tag ID 4605 and the count is 1109. So this means that there are 1109 books present for this particular genre over here. And let's take this over here. So the tag ID is 7778 and the count is 469. So this means that there are 469 books present with respect to this genre. Now let me go ahead and also find the percentage. So let me select all of this code over here. Right. So now we had run the command till here. Now, so we basically got the count of each genre. Now, after getting the count of each genre, I am ungrouping it again. After that, I will use the mutate function and find the total count. That is the total count of all of the genres combined. And I am also creating a new column percentage. So this percentage over here, I am dividing n upon sum of n. That is, this would give me the percentage of each of the genre. And after getting the percentage of each of the genre, I will arrange the dataset in descending order. And after arranging the dataset in descending order, I will also left join the tags dataset to the book tags dataset. And the joining would be done by the tag ID column over here. So let me store this in a new object. So let's say book info. Now let me have a glance at it. View of book info. Right. So guys, this is the tag ID. This is the count of the tag ID. That is the number of times this genre is present. And this column gives us the total count of all of the genres. This gives us the percentage of the genre. And this is the tag name, which is fantasy. So we've got our dataset ready. Now we'll go ahead and make a plot on top of this. So now let me go ahead and make a plot. So the object name was actually book info. So let me change this to book info over here. And on top of this book info object, I am adding a ggplot layer. So here I'll be mapping the percentage column onto the y-axis and the tag name column onto the x-axis. And the fill would be determined by the percentage column. And since we'd want to make a bar plot, we'll be using the geom bar function. And the stat which I've used is identity. And I'll also use the quad flip function over here because I'd want these bars to be stacked horizontally and not vertically. And the color to these bars would be determined by this palette over here. So this is YLORD. So this would be for yellow, orange, and red. And the label which I've given for the y-axis is percentage, and the label which I've given for the x-axis is genre. Let me hit enter. Right guys, so this is the plot. So here I have mapped genre onto the y-axis, percentage onto the x-axis. So we see that fantasy is the most prevalent data set, or in other words, most of the books belong to the fantasy genre, and the least percentage is of the cookbooks. So this was the distribution of the percentage of different genres. So up next we'll go ahead and find the top 10 books with highest rating. So this would be the command for that. So if you have to find out the top 10 books with highest rating, all we have to do is arrange this average rating column in descending order, and that is what we are doing over here. So here I have given the name of the object, which is books, and I am arranging this data set in inverse order of average rating, after which I am selecting just the top 10 records, and the columns which I'd be selecting are title, ratings count, and average rating. So let me store it in top 10. Let me have a glance at top 10 now. Right guys, so these are the top 10 highest rated books. So the Complete Calvin and Hobbes is the book with the highest rating. So it has the highest average rating of 4.82. And then we have Words of Radiance. So it has a rating of 4.77. Third in place is the Harry Potter box set, which has 4.77 rating. Fourth is ESV Study Bible, which has a rating of 4.76. Fifth in the list is Mark of the Lion Trilogy, which has an average rating of 4.76. Alright guys, so we have successfully found out the top 10 books with highest ratings. Next we'll go ahead and also find the top 10 most popular books. So this would be the command for that. So to find out the top 10 most popular books, we'd have to arrange this ratings count column in descending order. That is, whichever book has the most number of ratings, it would automatically mean that it is the most popular book. Right, so this is the command for that. Let me run it over here. So here what we are doing is, on the books data set, I am arranging it in inverse order of the ratings count column, and then I will be extracting the top 10 records, and I'll be selecting the title column, the ratings count column, and the average count column. So let me store this in top popular. Let me have a glance at top popular. Right, so these are the top 10 most popular books. So the most popular book in the list is The Hunger Games, which has the highest ratings count. Then the second most popular book is Harry Potter. Third most popular book is Twilight. And the fourth most popular book is To Kill a Mockingbird. In the third phase, we'll finally do some recommending. So we'll start off by building the user-based collaborative filtering model, and then we'll recommend 6 new books for 2 different readers. Right guys, so it's finally time to recommend some books. So before we go ahead and do that, we'd actually have to restructure our data a bit. So our data actually needs to be in the form of a matrix where all the rows should correspond to the users and all the columns should correspond to the books. So the dimension names would then nothing be but the user IDs and the book IDs. So the user IDs would represent all of the rows and the book IDs would represent all of the columns. So let me go ahead and extract all of the dimension names first. So here with this command, what I'm doing is I am extracting all of the unique user IDs, and I'm also extracting all of the unique book IDs, and I'm storing them in this object dimension names. So this is our first task. So we have basically got all of our dimension names. Now we'll go ahead and convert the format of our data frame from long format to wide format. So with this command, what we are doing is we are actually selecting the book ID, the user ID, and the rating columns from this data frame over here. And I'll be splitting this book ID column. That is, this value of book ID 1 would become one column. This value of book ID 2 would become the second column. This value of book ID 3 would become the third column, and so on. And these rating values over here, they would become the values for the corresponding book IDs. So this is how we can use the spread function to spread out our data frame from long format to white format, and we'll also remove the user ID column because it doesn't serve a purpose, and I will store it in a new object and name that object to be rating mat. So let me hit enter. Right, so we have created our rating matrix. So we have created the rating mat object. Now let me have a glance at the class of this. So class of rating mat. So we see that this is still in the form of a data frame, but we can build our user-based collaborative filtering model only on top of the real rating matrix. So first we'd have to go ahead and convert this data frame into a matrix. So let me do that. So here with the help of as.matrix function, I am converting the class of rating mat from a data frame to a matrix, and I am storing the result back to rating mat. Right. So now let me have a glance at the class. So class of rating mat, and we see that now it is a matrix. So let me have a glance at the first 5 rows and the first 5 columns of it. So these are the first 5 rows and these are the first 5 columns. So we see that this user ID column has not been removed. So let us go ahead and manually remove these. So what I'm doing is I am manually removing this first column and I am storing it back into rating mat. Now let me have a glance at first 5 rows and first 5 columns. Right. So these are the first 5 rows and these are the first 5 columns. So these rows basically correspond to all of the user IDs and these columns basically correspond to all of the book IDs. So these NA values which you see over here, so this basically means that the first user has not rated the first book, the first user has not rated the second book, similarly the fourth user has not rated the third book, and so on. Right, so we have our rating matrix ready. Now let me also assign the dimension names to the dimension names of this rating mat object. So here I am assigning all of the dimension names which I've extracted to the dim names of the rating mat. Right. So now let me have a glance at the dim names of rating mat. So dim names of rating mat. So these are all of the dimension names for the rows. So this is the name for row number 1, this is the name for row number 2, and this is the name for row number 3. So this basically signifies that all of the rows are represented by the user IDs. Similarly, if I go down, then we have all of the book IDs. So all of the columns are represented by the book IDs over here. Now let me use the dim function to find out the number of rows and columns in the matrix. So we see that there are 900 rows and 8,431 columns. Or in other words, there are 900 users and 8,431 books. So we have got our metrics ready, but we can't just build a user-based collaborative filtering model on top of the metrics. So we have something known as a real rating matrix. And the recommender lab basically works only on this type of object. So I will store this rating mat into a new object and name that object's name to be rating mat 0. Let me again have a glance at the number of dimensions of this. Dim of rating mat 0. So we have the same number of rows and columns. So again here, the number of rows are 900 and the number of columns are 8431. Now after this, what we'll do is, wherever we have NA values, we will replace those NA values with 0. So in rating mat 0, wherever we find NA values, I am replacing those NA values with 0. So now let me again have a glance at the first 5 rows and the first 5 columns of this. So it'd be rating mat 0, 1 to 5 and 1 to 5. So we see that all of the NA values have been replaced with zeros. So now we can go ahead and convert this matrix into a sparse matrix. So I'll be using the as function and I am converting this rating mat 0 object into a sparse matrix, and I will store this in a new object and name that object to be sparse ratings. Now let me again have a glance at the first 5 rows and first 5 columns of this. So sparse ratings 1 to 5 and 1 to 5. So this is how a sparse matrix looks like. So basically, with the help of a sparse matrix, we end up saving a lot of space. Now it's the last part of the transforming. So we will go ahead and convert this sparse matrix into a real rating matrix. So for this, we would need the new function. And with the help of new function, I am converting this sparse ratings object into a real rating matrix. So this over here takes in two parameters. So the first parameter is basically what we are trying to convert this into. And then we given the data which we are trying to convert. And I'll store this result in real ratings object. Let me print real ratings now and let's see what do we get. Real rating. So this is what we get. So it is a rating matrix where there are 900 rows and 8431 columns, and it is of class real rating matrix with 18,832 ratings. Right. So we finally have our real rating matrix ready. So now we can go ahead and build a model on it. So what we'll do is we'll go ahead and split the data set into train and test sets. So it'll be a 80-20 split. So I'll be using the sample function to create this 80-20 split over here. So I am using the sample function and I will generate true or false values over here. And this sampling would be with replacement. And the probability is 80-20. That is, I would want to divide the data set into two parts where the first part would comprise of 80% of all of the observations and the second part would comprise of 20% of the rest of the observations. And I will store the split criteria in a new object and name that object to be split book. So now in real ratings, wherever the value of split book is equal to true, I will select all of those records and store those records in rec train. Similarly, from the real ratings matrix, wherever the value of split book is assigned to be false, I am extracting all of those observations and storing those observations in rec test. So we have our training and testing sets ready. Now we can finally go ahead and build our first model. So we'll be using the recommender function, and this over here takes in two parameters. First is the training set on which we'd want to build the model, and next is the method or the type of the recommender model which we'd want to build. And since we'd want to build a user-based collaborative filtering model, we'll given the type to be UBCF. So if we wanted an item-based collaborating filtering model, then the method would be IBCF. But in our case, since we want user-based collaborative filtering model, so the method would be UBCF, and I will store the result in an object which would be rec model UBCF. Right, so I have successfully built the model. Now I'll give a value for the number of books to be recommended. So I am assigning the value 6 to a vector, and the name of that vector is nRecommended UBCF. So this basically lets us know that we'd have to recommend 6 books in total. Right, so the model building process is done. So let me go ahead and predict the values. So I'd have to use the predict function for this. So over here, this takes in 3 parameters. First is the model which you built. Next is the dataset on which we'd want to predict the values. And third is the number of values to be recommended. Right, so first we'll given the model which you built, which is rec model UBCF. And then we'd want to predict on top of the test set. So the test set is rec test. And the number of books to be recommended is 6, which is stored in nRecommended UBCF. And I will store this result in rec predicted UBCF. Right, so the prediction is also done. Now let me go ahead and find out the item numbers which have been predicted. So now that we have predicted the values, let's go ahead and recommend some books to user number 1. So here we will use this object rec predicted UBCF. So this is the object which we've just built using the predict function. And I'd want to find out the item numbers which have been recommended to user number 1. So this command over here, rec predicted UBCF @items1. So this will give me the column numbers which have been recommended to user number 1. So let me have a glance at user 1 book numbers. So this basically means that user 1 has been recommended to read these books which are present at columns 2177, column number 6343, column number 423, column number 1908, column number 2274, and column number 2514. Now we just have the column numbers. So let's actually find out the labels for these column numbers. Right, so from rec predicted UBCF, we have the item labels, and inside the item labels, I will give in the book numbers which have been recommended. Right, so these are the item labels. So the book ID, which is under column number 2177 is 2636. The book ID, which is under column number 6343 is 7482. Similarly, the book ID, which is under column number 2274 is 2750. So we have successfully got the book IDs. So now that we have the book IDs ready, let's actually use these book IDs to extract the name of the book and the name of the author. Right, so what I'll do is I will extract the title of the book and the author's name, where the book ID is 549. So the name of the book is Cordry and the author's name is Don Freeman. Similarly, let me extract the title and the author's name, where the book ID is 2750. So here we see that the book recommended is Mrs. Pigglewiggle, and the authors are Betty McDonald and Alexandra Boyger. Similarly, let me extract the titles for the book ID 3029. Let's see what do we get. 3029. So the book recommended is Rage of Angels and the author is Sidney Sheldon. Right, so these are the 6 books which have been recommended, and this is how we can extract the name of the book and the author of the book. Now similarly, let's also go ahead and recommend 6 books for the user number 5. So this is what I'd have to do. I will be using the rec predicted UBCF object, and I'll be using the @tag and extracting the items for user number 5. And I'll store this result in user 5 book numbers. So now that we have the item numbers, let's actually extract the column numbers for each of these items. So for this, the command would be rec predicted UBCF @item labels. And inside this, I will give in the book numbers. Right, so these are the book IDs which have been predicted. Right, so similarly, let's extract the title and authors for some of these book IDs. So we are extracting the title and the author's name, where the book ID is 4624. So the recommended book, so the name of the recommended book is The Girl Who Circumnavigated Fairyland in a Ship of Her Own Making, and the author is Catherine M. Valentine and Anna Wan. Similarly, let's extract the name of the book and the author's name, where the book ID is 6867. So here the book is Malgudi Days and it's been written by R.K. Narayan and Jumpalari. Now let me extract the title and the author's name for the book ID, which is 7326. So the book's name is Doctors and it has been written by Eric Segal. Right guys, so we have successfully implemented the user-based collaborative filtering model, and we have recommended 6 books to 2 different users.
Python and R are the 2 most commonly used languages in data science. And nowadays, most of the freshers get confused whether they should use R or Python to kickstart their career in the field of data science. And in this video, I'm going to tell you the long and short of both of these topics. So, without wasting more time, let's get started. I'm going to start off with their basic definitions. So, starting off with R. R is a programming language made by statisticians and data miners for statistical analysis and graphics, supported by the R Foundation for Statistical Computing. R also provides high quality graphics, and it also has some popular libraries which help in analytical parts such as R Markdown and Shiny. Python, on the other hand, is a fully fledged object-oriented and high-level programming language made by programmers and developers for general-purpose programming. Python is widely used in graphical user interface-based applications such as games, graphic designs, web applications, and many more. So we can say that R's functionality is developed by statisticians' mind, thereby giving it a field-specific advantages, while Python is often praised for being a general-purpose language with an easy-to-understand syntax. Let us start from the first factor, that is the speed. So guys, when it comes to speed, Python is faster than R only till 1000 iterations. But after the 1000 iterations, R starts using the Lapley function, which increases its speed. In that case, R becomes faster than Python. So both have their own advantages, right? Moving forward to the next point, that is the code and syntax. In this topic, I'm going to give you a brief about the variable declaration, data handling capacity with the scatter plot visualization, and the class plot graphics. Starting off with variable declaration. So guys, I'm going to take the case of string here, as R uses a similar implementation to that of the S programming language, which uses arrow signs in order to initialize the variable, which was also present in case of S programming language. These arrows can be used from right to left or left to right, indicating whom to assign the variables, whereas Python uses an assignment operator to initialize the variables. So basically, our developers thought that it would be better to tell the direction of assignment rather than just using an assignment operator, which could actually confuse any new programmer about which variable is being assigned. Right. Next is the data handling capability. Here, I'm going to show you the case of scatter plots, by which you will see the visualizations in R and Python. So guys, these are the piece of codes in R and Python, and after running these codes, you will get the very similar plot results in both the cases. If you try to analyze this code right here, then this clearly shows that how our data science ecosystem has many smaller packages like ggalley, which basically is a package that helps ggplot2, and also it is mostly used in R plotting package. Whereas in Python, matplot library, or we can call it matplotlib, is the primary plotting package, and cborn is a widely used layer over the matplot library. So guys, these are the plot results that I was talking about. So you can see that the graph results of both R and Python are similar, but the only difference is the visualization. Right. So based on these points and plot results, we can conclude that R has many packages supporting different methods of doing things, whereas there is usually one way to do something in Python. Moving on to the next point, that is the graphics. So here we will take the case of class plots. So guys, we already discussed that R was basically built for statistical analysis. So it has many specific libraries for plotting as well. This is the reason R comes up with many beautiful charts and graphs, whereas Python's main agenda was not a statistical analysis. So in the early stages of Python, packages for data analysis was an issue, but it has improved a lot. So guys, this is the plot result which is on your screen that I was talking about. As you know that the picture says more than 1,000 words. So here you can see by yourself that R comes up with a beautiful graphical representation. So here we can say that R is handy when it comes to the data handling. Our next point of attention is the deep learning, which is today's trend. So as you all know that almost majority of the companies are working on artificial intelligence, and deep learning is the main part of artificial intelligence. So when it comes to deep learning, Python is more versatile than R, as it provides more features to deep learning, whereas R is new to deep learning. R has newly added APIs like Keras and Keras R, which are written in Python. So guys, somewhere in your mind, this question might be floating. Why Keras? Actually, Keras in Python has the capabilities to run over Python's strong APIs like TensorFlow or Theano or Microsoft's CNTK. So we can say that Python has a greater advantage here. Till now, we have seen that both are useful in their own terms, right? Moving forward to the next point, that is the percentage of switching. In the past years of research, the percentage of people switching from R to Python are more as compared to Python to R. Let us say if 10% people are switching from Python to R, then 20% are switching from R to Python, which is twice as compared to the before scenario. Next, we are going to look at the trends, community support, and jobs. So guys, if we talk about the trends, before 2016, R was more in use. But here we can see that from 2016, Python is in trend. So it is more popular than R. And because of its popularity, it has overall good support for general purpose programming. So guys, if we talk about the community support, then Python's and R's support aspects are quite similar to each other. Because Python support is found at mailing list, user contributed code, and documentation and Stack Overflow. So basically it has more adoption from developers and programmers end. Whereas R language support is also found at mailing lists, user contributed documentation, and active Stack Overflow members. So basically R has more adoptions from researchers, data scientists, and statisticians end. Now, if we talk about the job trends, let us check the Google job trends graph right here. So guys, this is the job postings of R and Python in past 12 months worldwide. Whereas Python is asked more as compared to R. How is it possible? Because of its popularity and its need in the current industry. Since Python is more versatile and an all-rounder programming language, which can be used for majority of the purposes such as web application, game development, artificial intelligence, data science, statistical analysis, etc. Whereas R language is used among statisticians and data miners for developing statistical software and data analysis, which clearly depicts that there are more jobs for Python than R. Now let's move forward. So which one to choose for data science, R or Python? So guys, this is a frequently asked question by the majority of the learners in this domain. I would suggest using both if you have the choice. Everything has their own pros as well as cons. So as in the case of R and Python, if we talk about pros in R, well, then R is great for prototyping and for statistical analysis. It has a huge set of libraries which are available for different statistical type analysis. Even RStudio IDE is definitely a big plus as it eases most of the tedious tasks and fastens your workflow. Talking about its cons, well, the syntax could be obscure sometimes and it is harder for it to integrate to production workflow. The library's documentation isn't always user friendly. Talking about the pros in Python, Python is great for scripting and automating your different data mining pipelines. It is the de facto scripting language nowadays, and it also integrates easily in a production workflow. Besides, it can be used across different parts of a software engineering team like for backend, cloud architecture, etc. The scikit-learn library in Python is awesome for machine learning tasks. Talking of its cons, then Python isn't as thorough for statistical analysis as R, but it has come a long way in these recent years. In my opinion, the learning curve is steeper than R, since you can do so much more with Python. To conclude it, I would like to say that you can use R and Python both. Learn and how they interoperate together. Start with one and then add another to your workflow. It only adds another skill set into your resume, which comes as an added bonus to your career, isn't it?
Just a quick info, guys. Test your knowledge of R programming by answering this question. Which of the following is used for statistical analysis in R language? A. Studio, B. RStudio, C. Heck. Comment down your answer in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
Now let us begin with our programming interview questions and answers. So the first question is, we have to compare R and Python. So what are the differences in R and Python? So starting with R programming, it helps in model building and it is similar to Python. And talking about Python programming language, so it is also used for model building similar to R. So these are the common things or a common objective that is achieved using R as well as Python programming. Then talking about R programming, model interpretability is good. Then in Python programming or using Python programming, model interpretability is not good as in comparison to R programming. Then coming to production, so production is not better than Python in R, and Python provides a better way and more functionalities, packages and libraries for the production of the model. Then R has good community support over Python, and community support in Python is not better than R. There are more professionals and there is a large community of R developers. Then comes in R, the data science libraries are same as Python, and in Python the data science libraries and packages are same as R. That is, they serve the purpose of data analysis, data manipulation, creating machine learning as well as AI models. So both of these programming languages consist of various libraries and packages that are used in data science. Then R has good data visualizations libraries and tools, whereas data visualization libraries is not better than R in Python programming. So R provides more informative and beautiful graphs in comparison to Python programming. Then for R, it has a steep learning curve, and in Python the learning curve is easier than R because, as you already know, Python is one of the simplest programming language. So these are the points of comparison between R and Python. Now let me go to the next question. Explain the data import in R language. So R provides import data functionality in R language, and data can be imported in R language in three ways, and these are: you can select the dataset in the dialog box or enter the name of the dataset as required in the terminal. Then data is entered directly using the editor of R command prompt via data as new dataset. So you can write it in the command prompt for importing the data. And finally, data can also be imported from a URL or from plain text file or from any statistical package or from the clipboard also. So you can import the data in R using these three ways. Now let me go to the next question. Explain how to communicate the outputs of data analysis using R language. So to communicate the outputs of data analysis, you have to combine the data, code and analysis results in a single document using nitar package, And then what you can do is you can verify the findings or the results and add it to them, and you can then engage the conversation between the outputs of data analysis, and then you can redo the experiments by inserting new data values and applying it to different problems. So you have to add the new data again and again, then you will implement the same code on the updated data and see the analysis, then you have to verify the analysis or the result you get from the model. So in this way you can communicate the outputs of data analysis using R language. Now let me go to the next question. We'll see the difference between library and require functions in R language. So starting with library function, it gives an error message if the desired package cannot be loaded, whereas in require, the require function is used inside the function and throws a warning message whenever a particular package is not found. Then in library, it loads the packages whether it is already loaded or not, whereas in require or while using require function, it just checks that it is loaded or loads it if it is not loaded. So when you will go through the documentation of the require function, it clearly states that neither function will reload an already loaded package. Now the third point in library function is it is better to use the library as it gives the error message if the package is not found during the package loading time, whereas require function will just fail without an error if the package is not there. So these are the differences between the library and the require function. Now let me go to the next question. What are the advantages of using R programming? So these are the major advantages of R programming, and they are: it is open source. That means the software or the original code or the source code is made freely available and may be redistributed and modified in future. So it is freely available. This is one of the most important thing. So it does not have any charges for using. Then it supports data wrangling operations. So data wrangling is actually the process of transforming and mapping data from one raw data into another format with the intent of making it more appropriate and valuable for a variety of downstream purposes such as analytics. So we can say that R programming provides us the libraries, packages and features for data analytics. Then it is highly compatible. It is platform independent. That is, we can run the code, or you can say the R codes, in any platform. Finally, it supports machine learning operations. So we can do a lot of things using R programming. So we can perform data manipulation, data visualization, then data exploration, or we can say exploratory data analysis, then creating machine learning models, and it supports a lot of algorithms that we can actually use for building ML based applications. So these are the advantages of R programming. Now let us move on to the next question. What are the disadvantages of R programming? So apart from the advantages of using R programming, there are certain disadvantages, and these are listed over here. So there is a lack of standard GUI. So when you are using Python for data science or machine learning or for AI, we use Jupyter Notebook, and for R we use RStudio. So you can see the difference between both of these. Jupyter Notebook provides a better GUI that is more easy to go through in comparison to RStudio that we use for R programming. Then R programming is not good for big data. So if you are handling large amounts of data, then you should use Python because it is not efficient for big data. Then comes weak origin. It lacks basic security. It has lesser speed than other softwares that we use for data manipulation, visualization, or creating machine learning models. Then another disadvantage is spread across various packages. Now these are the major disadvantages. Now let us move on to the next question. What is the use of with and by function in R? With function applies an expression to a data set, and syntax, you can see the syntax over here. With, you have to give the data and the expression that you want to execute. So it is a generic function that evaluates expression in a local environment constructed from data, and the environment has the caller's environment as its parent. So this is very useful for simplifying calls to modeling functions, and if data is already an environment, then it is used with its existing parent. Now coming to by function, it applies a function to each level of a factor. So by function in R applies a function to specified subsets of a data frame, and first the parameter of by function then takes up the data, and second parameter is which by the function is applied, and the third parameter is actually the function. So this is the syntax of by function. So here are three arguments: data, factor list and function. Now let us move on to the next question. In R programming, how missing values are represented? In R, missing values are represented by NA, which should be in capital letters. So NA is not actually a string or a numeric value, but an indicator of missingness. So we can create vectors with missing values. So x1 and x2 are the vectors, and C function is the combine function. So here are the values in the vector, including 1, 4, 3, NA and 7. And in the vector x2 there is A, capital B, NA and NA as string also. So the values which are in inverted comma, so these are strings, and the original NA value is simply written as NA. So there are also the values that are divided by 0 or are represented by the symbol NaN, which represents that it is not a number. So these values are actually the impossible values that are available in the data set. So there are various methods for handling the missing values that we'll discuss later. So here we have discussed about the missing values, how they are represented in R. Now let us move on to the next question. What is the use of subset and sample function in R? So subset function in R returns subset of data frame, vectors or matrices which meet the specific conditions. And this is the syntax of the subset function, which includes X, condition and select, where X can be a matrix, data frame or vector. Then condition is the condition that which you want to impose, the condition that you want to use.
Just a quick info guys. Intellipaat provides online data science master's program in partnership with IBM. The course link of which is given in the description below. Now let's continue with the session.
So that is denoted by the condition. Then comes select, which denotes the column that are to be selected. Now let us look at an example. So here new data is equal to 30. So there is a data set where there are 30 values. We use the subset function and give the arguments. So the above code select the data from the empty cars table where MPG is greater than or equal to 30, and so the output will be, as you can see, that the values of MPG, CY, L and gear. Now let us look on to the next one, that is sample function. So sample function in R generates a sample of the specified size from the data set or elements, either with or without replacement. So this is the syntax of the sample function, that is the sample keyword, and the arguments are X, size, replace and the prob. So X denotes the data set or a vector of one or more elements from which sample is to be chosen. Then comes size, which denotes the size of a sample. After that replace, so there you need to mention should sampling be with replacement. So you need to give it as true or false. Then comes prob, so it gives the probability weights for obtaining the elements of the vector being sampled. So you can see the example using the sample function. We give the values as 1:20, 10 and replace equal to 2. So when we run the above code, we'll get the output as you can see it on your screen, that is 6, 8, 12, then 19, 5, 18, 19, 14, 13 and 2. So these are the 10 values between 1 to 20, and these are actually the random values. So now let us move on to the next question, that is explain what is transpose. So transpose is used for reshaping of the data which is used for analysis. So rotating or transposing our objects frame so that the rows become the columns and the columns becomes the rows. So that is what we are transposing, and we are actually transposing the rows and the columns. So you can see the example image over here. So the original matrix consists of A, B, C, D, E, F, G, H, I, where A, B, C are in the horizontal frame. After applying the transpose on this matrix, the A, B, C comes in the vertical frame, and same is the case with D, E, F and G, H, I. So this is actually the transpose of a matrix. So we apply transpose in a matrix in our programming so that we can analyze the data in different ways. Now let us move on to the next question. Now the question is, why do we use R programming? So R programming is used for data manipulation, data visualization, and for creating machine learning models as well as AI based applications. Now starting with data manipulation, as you already know, the data collection process done by machine involves a lot of errors and inaccuracies in reading. So data manipulation helps us to remove these inaccuracies and make the data more accurate and precise. So data manipulation involves modifying the data to make it easier to read and to be more organized. So we manipulate the data for analysis and visualization tasks, and it is also used with the term data exploration, which involves organizing data using available set of variables. So there are many methods and functions in R that we use for data manipulation, such as filter that helps to pick up rows based on their values, then distinct to remove the duplicate rows, and to arrange to reorder the rows, then select function that select columns by their names, then rename function is used to rename the columns, mutate function and transmutate function is used to add or create new variables. So by using all these functions, we can manipulate the data, we can remove the duplicacy, we can arrange them in an order that we can easily understand. So in simple words, we can say that data manipulation is a crucial function for any business operations and optimization, and to properly use data and transform it into useful insights, like analyzing financial data if you are working for any financial organization such as bank or any other company which is related to finance, then customer behavior and performing trend analysis. So here you have to be able to work with the data in the way you need it. So that is why data manipulation is a very necessary task. So using R programming, we can easily manipulate the data according to our use. Then comes data visualization. So whatever data is collected, manipulated and performed exploratory data analysis on it. So we need to analyze and we need to understand the data in the form of graphs and plots, so that we can understand the trend, we can analyze it, we can understand it using certain statistical parameters, we can understand the change in the values and the behavior of the customer as well using data visualization. So data visualization is another important part of business analytics task, or you can say data analysis, or it is used in data science as well. So most of the companies uses data visualization to analyze their business, to analyze their customer, the trends of the market, the behavior of the customer, their buying behavior, their interest. So it helps them to make a proper strategy based on the past data visualized, and then optimize their business process for gaining or for increasing their revenues. So R programming provides a lot of libraries and packages and tools that help us to visualize the data in a very efficient way with informative graphs and plots. Then comes machine learning. So we can create various algorithms, we can create various models of machine learning using R programming. So there are various functions, various libraries that are present in R for creating classification, regression, clustering algorithms that are used in machine learning. Also, artificial intelligence is one of the field that is covered by R programming. So we can create image classification model as well as CNN, that is convolutional neural network, as well using R programming in artificial intelligence. So we start with data manipulation, then we visualize the data. According to it, we create machine learning models, and we can also create AI based applications using R programming. So this is the use of R programming. Now let us move on to the next question. What is the function used for adding data sets in R? So for adding two data sets, we use rbind function, where the condition is the column of the two data sets must be same. And here is the syntax of rbind function. We have to write the rbind keyword, and then we have to give the argument as x1, x2, where x1 and x2 can be vector, matrix or data frames. So rbind basically stands for row bind. We also use cbind, that stands for column bind, that helps to bind the columns, and here the data or the arguments can be vectors, matrices or data frame. And the condition over here for using rbind function is also that it combines vector, matrix and data frame by rows. So the column numbers of the two data sets must be the same, otherwise the combination will not be effective and it will be meaningless. So if two vectors do not have the same length, so the elements of the short one will be repeated. So that is why the number of the column of the two data sets must be same. So this is about the R-bind function. And now let us move on to the next question, which is how you can produce correlations and covariances. So correlations is produced by COR function and the covariances is produced by COV function. So correlation, or represented by R, measures a linear dependency between two variables x and y, and it is also known as a parametric correlation test because it depends to the distribution of the data. So here you can see the graph where the correlation is represented. Now coming to covariance, it is a statistical term used to measure the direction of the linear relationship between the data vectors. So here you can see the graph plotted between x and y. So here is positive covariance and the negative covariance. So here you can see the graph for positive covariance and the negative covariance where the data points are spreaded. So in actual words, variance refers to the spread of a data set around its mean value, while a covariance refers to the measure of the directional relationship between the two random variables. And talking more about covariance, it is actually the measure of the joint variability of the two random variables. And here the sign of covariance therefore shows the tendency in the linear relationship between the variables. So in positive covariance, you can see the values or the mean values of the data set are increasing positively, while in negative covariance they are decreasing gradually. So this is about the correlation and the covariances. And now we'll move on to the next question. What is the difference between matrix and data frame? So data frame can contain different types of data. So as you can see in the table that there are x and y columns in this data frame, and x consists of the values 12.3 and 3, 5.01, 2.3, and y consists of mango, orange, banana and grapes. So it can contain multiple data types in multiple columns called fields. So these are called fields. Then coming to matrix, matrix can contain only similar type of data and it has a fixed number of rows and columns. So here you can see the values 12.3, then 3, 5.01, 2.3, and in the next column it has 8.1, 5.2, 3.0 and 0.1. So it can only contain the similar type of data. It cannot have different types of data such as in data frame. Now let us move on to the next question. What is the difference between lapply and sapply? So starting with lapply, so this function is useful for performing operation on list objects and returns a list object of same length of original set. So L in this lapply function stands for list. So we are applying the function on a list. Then coming to sapply, this function takes list, vector or data frame as input and gives the output in vector or matrix form. Then lapply returns a list of similar length as you already know and as input list object, and each element of which is the result of applying fun to the corresponding element of the list. Whereas sapply, it is useful for operations on list objects and returns a list object of the same length of original data set. So in sapply, it is useful for operations on list objects and returns a vector of same length of original set. Now in lapply, it takes a list, vector or data frame as input and gives the output in list itself. But in sapply, it does the same job as lapply, but it returns a vector. So this is the major difference between lapply and sapply function. Now let us move on to the next question. How many data structure R has? So there are 5 types of data structures in R that are shown below in the diagram. So it has vectors, data frame, list, matrix and array. So starting with vector, it is one of the basic data structures in R programming and it is homogeneous in nature, which means that it only contains elements of the same data type, and data types can be numeric, integer, character, complex or logical. So vector in R programming is created using the C function and coercion takes place in a vector from lower to top, and if the elements passed are of different data types from logical to integer or to double to character, so we use that. Then if we want to check the data type of the vector, we can use type of, and for checking the class of a vector we can use the class function. Now elements of a vector can be accessed by using the indexes. that it has inside the brackets to specify the indexes of the elements that are to be accessed, and we can also use logical indexing, negative indexing. Apart from that, we can perform addition, subtraction, multiplication and division on vectors having the same number of elements. Now apart from that, if arithmetic operations are performed on the vectors having unequal lengths, so we can recycle it, and then the vectors elements which are shorter in number as compared to the other vectors are recycled. For example, if we are having a vector 1 containing the value 876501 and we have vector 2 that has 7 and 15, so vector 2 will take the values repetitively of 7, 15, 7, 15 and 7, 15, and when we add the vector, then the corresponding values will be added. So this is how a vector can be recycled. Now we'll go to list. So a list in R programming is a non-homogeneous data structure, which implies that it can contain elements of different data types, and it accepts numbers, characters, lists and even matrices and functions inside it. So it is created using the list function. Also, the elements of a list can be accessed by using the indices of those elements that are present in that, and we can add and delete the elements only at the end of a list. So this is about the list. Now we'll go to matrix data structure. So the matrix in R programming is a two-dimensional data structure that is homogeneous in nature, which means that it only accepts elements of the same data type, and coercion takes place if the elements of different data types are passed, and it is created using the matrix function. And the basic syntax to create a matrix is you have to give the matrix keyword, and then in brackets you give the arguments as data, number of rows represented by n row, then n column for number of columns, then by row, and the dimensions name. So in data you have to put the input element of a matrix given as a vector, and in number of rows you have to give the number of rows that have to be created, then number of columns, the number of columns that you need to create, then by row function, so the row wise arrangement of the elements instead of column wise, and for that you have to use by row function, and dimension name, so you have to give the names of the columns and rows to be created. So this is the matrix data structure. Now after that, coming to data frame. So data frame in R programming is a two-dimensional array like structure that also resembles a table in which each column contains values of one variable and each row contains one set of values from each column. So the column names of a data frame should not be empty, then row names should be unique, and data stored in a data frame can be numeric, factor or character type, and each column should contain the same number of data items. So this is about the data frame data structure in R. Now coming to arrays in R. So they are the R data objects which can store data in more than two dimensions. For example, if we create an array of dimension 2, 3, 4, then it creates 4 rectangular matrices, each with 2 rows and 3 columns. So an array can store only similar type of data, and an array is created using array function, and it takes vectors as input and uses the values in the dim parameter to create an array which represents the dimension of it. So this is about the data structures in R. Now let us move on to the next question. What are R packages? So packages are the collection of data, R functions and compiled code in a well-defined format, and these packages are stored in a library. So as you already know, R is a programming language and it is free software environment for statistical computing and graphics supported. So they are the essential tools for various data analysis as well as data science, machine learning implementation. So R language is widely used among statisticians and data miners for developing statistical software as well as implement data analysis technique, and implements various data manipulation, data visualization on various types of business data. So this is possible due to the packages that are provided by R. So these packages are actually the development package that help us to visualize the data, manipulate the data and work on machine learning models as well as create AI based applications. So the package over here refers to the development package that is provided by R. Now let us move on to the next question. What is the function which is used for merging of data frames horizontally in R? So there is merge function that is used to merge two data frames. So here is an example. You can see the sum, which is an instance variable, or you can say the object, which will store the output of the merge function, where the arguments are data frame 1, data frame 2, and the argument for adding, so by equal to id. So it will add the data frames by their id. So it is a unique variable that are present in both the columns. So this is how we merge the two data frames horizontally in R. Now let us move on to the next question. What is the power analysis? So it is used for experimental design that is used to determine the effect of given sample size. So you can see the graph over here. So it is actually an important aspect of experimental design, which is used to detect an effect of a given size with a degree of confidence. So there are various steps for calculating the sample size for doing power analysis. So you can specify a hypothesis test, specify the significance level of the test, then you can specify the smallest effect size that is of scientific interest, and then you can estimate the value of other parameters necessary to compute the power function. So also you have to specify the intended power of the test, and then you have to calculate it. So determining a good sample size for a study is always an important issue. So power analysis combines statistical analysis and subject area knowledge and the requirements to help you derive the optimal sample size for your research or study. So there is also a good power analysis value, and the desired power level is typically 0.8, but the researcher performing power analysis can specify the higher level, such as 0.9 also, which means that there is a 90% probability that the researcher will not commit a type 2 error. And one of the stringent factors in power analysis is the desired level of significance that we use for our data. What is the use of AB line function? So AB line function adds the reference line to a graph, and the R function AB line can be used to add vertical, horizontal or regression lines to a graph. Also here x and y values are single values specifying the intercept and the slope of the line. So here is the syntax for AB line function. So we have to use AB line keyword, then in brackets we have to give the y values and the x values represented or stored in h and v. So these are specifying the intercept and the slope of the line. So this is the use of the AB line function. Now let us move on to the next question. What is iPlots? So it is a package which provide bar plots, mosaic plots, box plots, parallel plots, scatter plots and histogram. So iPlots is actually a package for the R statistical environment which provides high interaction statistical graphs that are written in Java, and it offers a wide variety of plots that you can see over here, that is histograms, bar charts, scatter plots, box plots and many others. So by using iPlots in R, we can actually visualize our data in a much efficient way. So besides these interactive plots, iPlots also provide an API for managing plots and adding user defined objects such as lines or polygons to a plot. And the version 2.0 of it not only adds new multivariate plots and interactive features throughout all the plots, but also lays the foundation for interactive and customizable plots. Now this is about the iPlots. Now let us move on to the next question. What is the use of choregram function? So choregram function is used to plot correlograms. So the cells of the matrix over here can be shaded or colored to show the correlation values. So in the analysis of the data, a correlogram is a chart of correlation statistics. For example, in time series analysis, a plot of the sample autocorrelations versus the time lags is an autocorrelogram. So if cross correlation is plotted, then the result is called cross correlogram. So this is the use of the correlogram. Further, the correlogram is a commonly used tool for checking randomness in a dataset. And if non-random, then one or more of the autocorrelations will be significantly non-zero. So in addition, correlograms are used in the model identification stage for auto-regressive moving average time series models. Now this is all about the choregram function. Now let us move on to the next question. How to create scatterplot matrices? So we use pair or splom function for creating scatterplot matrices. So this is useful to visualize correlation of small data sets, and each scatter plot in the matrix visualizes the relationship between a pair of variables allowing many relationships to be explored in one chart. Then scatter plots used to visualize bivariate relationships between combination of the variable, that is same as visualization between different types of variables in a same plot. So the scatter plot matrix shows all the pairwise scatter plots of the variables on a single view with multiple scatter plots in a matrix format, and this gives us a more sorted way of representing the data and understanding the relation between the variables as well as visualizing it for further analysis. So here you can see a scatter plot matrix is a grid or matrix of scatter plots that is used to visualize the data and the relationship, and the scatter plot matrix is composed of a grid of mini plots. So there are multiple plots over here and one larger preview plot that shows a selected mini plot in more detail. So there are variables you can see over here that shows sepal length, sepal width, petal length and petal width. Now this is about the scatter plot matrices. Now let us move on to the next question. What is the use of a diagnostic plot? So it is used to check the normality, heteroscedasticity and influential observations. So diagnostic plots actually show residuals in 4 different ways: residuals versus fitted, and used to check the linear relationship assumptions. A horizontal line without distinct patterns is an indication for a linear relationship that implies what is good or what is not good. Then there could be a non-linear relationship between the predictor variable and an outcome variable, and the pattern could show up in this plot if the model doesn't capture the non-linear relationship. And if you find equally spread residuals around a horizontal line without distinct patterns, that is a good indication you don't have a non-linear relationship. Now coming to normal QQ, so this plot shows if residuals are normally distributed. So it also answers the question, do residuals follow a straight line well or do they deviate severely? Then it's good if residuals are lined well on the straight dashed lines. Then coming to scale location, it's also called spread location plot. So this plot shows if residuals are spread equally along the ranges of predictors, and this is how you can check the assumption of equal variance. And it's good if you see a horizontal line with equally or randomly separated points. Now residuals versus leverage. So in this, plots help us to find influential cases, that is subjects if any present in it. So not all the outliers are influential in linear regression analysis, but even though data have extreme values, they might not be influential to determine a regression line. So that means the results wouldn't be much different if we either include or exclude them from analysis. So they follow the trend in the majority of cases and they don't really matter, they are not influential. On the other hand, some cases could be different or influential even if they look to be within a reasonable range of values. So there could be extreme cases against a regression line and can alter the results if we exclude them from analysis. And another way to put it is that they don't get along with the trend in the majority of the cases. Now this is about the use of the diagnostic plots. Now let us move on to the next question, which is define ANOVA function. So ANOVA is used to compare the nested models. So it stands for analysis of variance and is an analysis tool used in statistics that splits an observed aggregate variability found inside a dataset into 2 parts, that is systematic factors and random factors. So the systematic factors have a statistical influence on the given datasets, while the random factors do not. Moreover, ANOVA is a statistical test for estimating how a quantitative dependent variable changes according to the levels of one or more categorical independent variables. And ANOVA tests whether there is a difference in means of the groups at each level of the independent variable. So this is about the ANOVA function and its usage. Now let us move on to the next question.
Just a quick info, guys. Test your knowledge of R programming by answering this question. R functionality is divided into a number of dash: A. Packages, B. Functions, C. Domains. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
What is the use of MANOVA? So MANOVA stands for multivariate analysis of variance. And by using ANOVA, we can test more than one dependent variable simultaneously. So the multivariate analysis of variance or ANOVA is an ANOVA with two or more continuous outcomes or response variables. And the one-way ANOVA test simultaneously statistical differences for multiple response variables by one grouping variable. So what is the use of ANOVA, or what is ANOVA used for? So this multivariate analysis of variance is a type of multivariate analysis used to analyze data that involve more than one dependent variable at a time. And ANOVA allows us to test hypotheses regarding the effect of one or more independent variables on two or more dependent variables. So the actual difference between ANOVA and MANOVA method is ANOVA method includes only one dependent variable, while the MANOVA method includes multiple dependent variables. So MANOVA is actually used to determine whether there are any differences between independent groups on more than one continuous dependent variable, and in this regard it differs from one-way ANOVA, which only measures one dependent variable. Now this is all about MANOVA. Now let us move on to the next question. What is logistic regression? So logistic regression is used to predict the binary outcome from the given set of continuous predictor variables. So logistic regression is actually a supervised learning classification algorithm used to predict the probability of a target variable. And the nature of target or dependent variable is dichotomous, which means that there would be only two possible classes. So here 0 or 1. 0 represents that it is incorrectly classified output, and 1 represents the correctness of the output. So there are types of logistic regression. So here logistic regression is the proper regression analysis, as you already know, that is used when the dependent variable is categorical or binary. So there are three types over here: binary logistic regression, multinomial logistic regression, and ordinal logistic regression. So in binary logistic regression, only two outcomes are possible, whereas in multinomial logistic regression there are more unordered categories, and in ordinal logistic regression there are three or more ordered categories. Now this is about logistic regression. Now let us move on to the next question. Define Poisson regression. So it is used to predict the outcome variable which represents counts from the given set of continuous predictor variable. So Poisson regression actually assumes the response variable y has a Poisson distribution and assumes the logarithm of its expected value that can be modeled by a linear combination of unknown parameters. So a Poisson regression model is sometimes known as a log linear model, especially when used to model contingency tables. So why do we actually use Poisson regression? So it is used to predict a dependent variable that consists of count data given one or more independent variables. And the variable we want to predict is called the dependent variable, or sometimes the response or the outcome, or you can say the target variable. So that is why we use Poisson regression. Now let us move on to the next question. Define cluster.stats function. So it is defined in the FPC package, which provides a method for comparing the similarity of two clusters solution using different validation criteria. So clustering in R is actually a technique of data segmentation that partitions the data into several groups based on their similarity. And basically we group the data through a statistical operation, and these smaller groups that are formed from the bigger data are known as clusters. So talking about cluster stats, it computes a number of distance based statistics which can be used for cluster validation, comparison between clusterings, and decision about the number of clusters. So it can be cluster sizes, cluster diameters, average distances within and between the clusters, then cluster separation. It can be biggest within cluster gap and average widths. So here you can see it in the plot. There are three clusters represented by different colors, and we can calculate the cluster diameters, cluster sizes, as well as the distance between the clusters using the cluster.stats function. So this is about cluster and why do we use it. Now let us move on to the last question of this R programming interview questions and answers tutorial. What is principal function? It is defined in psych package, which is used to rotate and extract the principal components. So basically it is just doing a principal component analysis for n principal components of either a correlation or covariance matrix, as you can see in the graph. Also, this returns a subset of just the best n factors. So it can show the residual correlations as well, and the quality of reduction in the squared correlations is reported by comparing the residual correlations that we evaluated or calculated to the original correlations. So here are the two plots. So first one is transformed non-standardized training datasets after PCA and transform standardized training dataset after PCA. So you can see the difference after the rotation and using the principal function that is applied for the principal component analysis, and it changes the component as you can see in the plot over here, and it helps to represent the classes differently, and we can make a cluster of it to analyze it in a better way. So this is about the principal function.
Just a quick info guys. Intellipaat provides online data science master's program in partnership with IBM. The course link of which is given in the description below.